This is a complete 6 hours long Agentic AI with LangGraph masterclass which will make you a pro LangGraph developer, because this will cover difference between AI agents versus Agentic AI, agentic nodes and edges, state schema for stateful orchestration, Pydantic orchestration graphs, conditional nodes in LangGraph, tool binding with LLMs, React agent architecture, prompt chaining, worker orchestrator framework, Generator-Evaluator architecture, adding human in the loop feature in LangGraph, managing memory in LangGraph, and much more. The best part is this course is made for total beginners. That means you do not need any kind of prior experience and knowledge. Some basic Python knowledge will be very good. Plus, I have used amazing doodle graphics throughout this video for the explanation so that you can easily grasp each and every concept in detail with ease. Plus, I have provided all the notes, code files, resources, everything with this particular video. In short, this is one-stop solution for you to master LangGraph this year. Just a small request, I have literally put so much of efforts to create this dedicated course on LangGraph and providing it for free. You will hardly take 1 second to hit the subscribe button, so just do it right now. And let's get started with this amazing LangGraph masterclass.
So what's up my fam? Happy Sunday! Finally. By the way, thank you so much for giving me such a great response on my LangChain video. And you said, Ansh, Lamba, just create LangGraph video. So there is a complete zero to hero course for you for LangGraph. First of all, quickly, let me just tell you that if you have some basic Python understanding, if you know how to write Python functions, if you know how to run loops, if you know how to use if and else conditions in Python, you can continue with this video. I know that is your only question. And second question, if you do not even know LangChain before and if you are directly learning LangGraph, still this video is for you, because I have covered everything from scratch and I have covered everything from, you can say, all the areas that are required for this particular video. So do not need to worry at all. And now third question, if you already know LangChain, then it will be like cherry on the cake because you already know the fundamentals. You can easily work with LangGraph because this video is like purely focused on LangGraph. And if you do not know about LangGraph is built on top of LangChain. Okay, and this gives you more control. And to be honest, in the industry, in the companies, we use LangGraph most of the time. We integrate LangChain with LangGraph, but when we want to build the solutions, we use LangGraph. And obviously that is why you are seeing LangGraph everywhere in the job descriptions as well. So I thought I need to help my lovely data family members. And if you are part of my lovely data family members, then welcome to my video. If you are not the part of my lovely data family members, then what are you waiting for? Simply hit the subscribe button right now. Okay, and then just be the part of my lovely data family members, because do you know what, we have amazing fun and we grow together. Very good. So now the questions are clear, the prerequisites are clear, and your agenda is the next thing. Agenda is very simple. So I would expect that you have zero understanding about LangChain, LangGraph, whatever, Agentic AI, nothing, zero understanding. But you are a beginner who knows Python. Okay, who knows Python, who knows how to write the functions in Python, how to run loops in Python, how to import packages in Python, right? Are you that person? Very good. Then you can just watch this video, and the agenda of this video is very clear. You will complete this video, which is amazing course, like 6+ hours long course, you can imagine. And right now I know like everyone is like creating a hype around agentic AI, but you need someone who can actually guide you and teach you agentic AI, right? We need to learn as well, along with like talking about agentic AI, because both are important. So now this video will help you learn about agentic AI and how you can just build agentic AI pipelines in the industry. And after completing this video, you will be, yes, a LangGraph developer from scratch. Okay, so that is a good thing. So that is the agenda. All the prerequisites are clear, all the questions are clear. Now I don't want to waste your time, and I know you want to watch this video, you really want to be a LangGraph developer. So let's get started with the video. And before that, let me just actually congratulate my lovely data family members. So congratulations to all of my lovely data family members who cracked their dream roles. Okay, and you will say, just two? Who said just two? Let me show you more. Congratulations to everyone. Congratulations. I'm really happy for all of these people who have actually got offers from big companies, MNCs, Big Four, and amazing consulting firms, and really happy for that. If you also want to come here, you just need two things. One is obviously this channel. Second is consistency. You need to be a consistent learner. You need to be dedicated towards learning, and the rest of the things I will take care, because I will just teach you. That's it. Okay, and let's get started with our amazing masterclass on LangGraph. And these are some handles of mine. If you just want to follow me, you can just do that. Okay, so let's try to get started. Not try. Let's get started with our LangGraph masterclass. So finally in the LangGraph classroom. So now, first thing first, I want to ask you one question. Why do you need to learn LangGraph? Because if you do not know why, then I don't know how you will learn it. Simple. So let's talk about first of all why LangGraph. Okay, and then obviously what is LangGraph will be automatically covered. Make sense? And as I just said earlier, if you already know LangChain, it will be a little bit easy for you to understand. And even if you do not know about LangChain, don't worry, I will just make it easy for you. So just enjoy. So basically LangGraph is the most popular framework right now in the era of agentic AI. What did I say? Agentic AI. Okay. So I can say LangChain is the kind of go-to framework for agentic AI. Agentic AI app solution, whatever you want to say. Because it is open source, it is free, you do not need to pay to anyone, and it is amazing. Like, I personally love it. I am a big fan of agentic AI, like LangGraph. So now let's talk about it. So basically, what will happen if I want to create agentic AI solution? I need to build first of all AI agent. Then I need to build the agentic AI solution. Now you can be tricked. You'll be like, hey, what is the difference between AI agent and agentic AI? That's a very good question, because that should be your first question. So now let's try to talk about AI agent versus, let's say, agentic AI. Simple. Do you know what? The difference is very, very simple and very straightforward. So let's talk about AI agent first of all, and then we can just go to our, you can say, agentic AI. Simple. So if I want to talk about AI agent first of all, so AI agent is like when you want to build a solution which can perform some tasks on its own. Simple. For example, let's say you want to create a chatbot. If you have used ChatGPT, let me just open any ChatGPT instance. That's a kind of AI agent. Kind of, because now it can perform so many tasks. Earlier it was not, but now it can perform, because it can perform some tool calls and it can perform some searching as well, whatever you want to perform. So here, if I say what is the temperature in, let's say, Bangalore right now. So now what it will do, it will simply do something magical behind the scenes. Nothing magical. It will simply say searching the web. See, so now it is saying right now in Bangalore or Bengaluru, India, the current temperature is 29 degrees. Wow, feels like 29. Wow, under clear skies. So how did it know this thing? How? Obviously it is not storing all of the data continuously. So it made something called as API call. Make sense? So agent will look like this. Let's say you are building an AI agent. So let me first of all remove this. Let's first of all talk about AI agent. So what it will do, so let's say we have the agent, and let's say agent is look like it's like this person. Make sense? Okay. Let's say this is the AI agent. Okay. Now you came to this person. This is you. You came to this person and you said, hey, I want to know the temperature in Bangalore. Simple. Simple. Your query. Now this will process information, and this has something called as some tools. What kind of tools? Let's say it has some tools, like lots of tools. Let's say it can be accessing the internet. Obviously it can access internet, like making the API calls, for weather information or anything. So what it will do, it will make those API calls because this is connected to these tools. Let's say these are the tools. Simple. These are the tools, and it will make some API calls, and it will get back the data, and you will get the response back. Simple. But this is a very basic example of AI agent. Under the hood, AI agent is not just like making the API calls. It is also about the building the sequence, or basically building the chain, building the workflow. So now let's talk about a little bit complex example. Okay. When you want to create an AI agent to do your multiple tasks. So for example, you have a task number 1 like this. Okay. You have task number 2 like this, which will be performed after this one. Then you have some kind of, you can say, parallel tasks like this, like this, like this. So you can perform all of these tasks. Simple. Because AI agent is just a like hyped word. Under the hood is just like workflow. Simple. Okay. Simpler the way you will look at AI stuff or AI engineering, better you can understand it if you will be keep on learning the technology by using words AI agent, agentic AI. You'll be like, bro, what is this? If you know like this is a workflow, it's fine, because you can build these kinds of workflows using pure Python as well. But why do we use these frameworks? Because they have like strong integration with those APIs and those service providers. That's the only reason we use these frameworks. You can build these frameworks with Python as well, not a big deal. So these are some tasks, and let's say once all of these tasks are completed, you need to do this task final. So this is a kind of AI agent that you have built, a kind of workflow. Simple. This is the AI agent that you have built. In LangChain or LangGraph kind of frameworks, we call it as a chain. Because what is a chain? Chain is nothing but your AI agent, which can perform some API calls, which can perform some tasks. It can be any agent, or it's not only about the agent. It can be agent, it cannot be an agent. Because agent also has so many kinds of frameworks. You have a React agent. Don't worry, we will just talking about all of these things. Currently, we are simply talking about from a very high level overview. Okay. So this is a kind of chain that you create, and this can be considered, or you can say bucketed under this category called AI agent. Simple. Okay, very good. Because it's your own definition. In your case, a simple chain can be an AI agent. In my case, let's say I'm building multiple loops in parallel and so many other things. For me, it's my AI agent. So you define your own definition of AI agent. Because AI means you are using some kind of technology under the hood, which is LLM. Make sense? You are using LLM, large language model, and you are utilizing large language model, and you are building a chain on top of it so that it can perform those tasks. Because LLMs are smart. Simple. LLMs are smart. LLMs know like how to generate the text and how to make those API calls and whatever. Because with the course of time, we have like amazing open source LLMs as well and closed source LLMs as well. Simple. Makes sense? So now everything was fine. We were able to work with chains and simple workflows. But now, with the course of time, with the more advancements in the you can say AI solutions, we found so many problems with only this kind of framework. We cannot scale it up. If we will scale it up, it will actually create a mess, because you cannot scale it to, let's say, hundreds of nodes or thousands of nodes. And in the real world, yes, we need to have those kinds of solutions. Let's say you're building the AI solution for the entire enterprise, or let's say for the entire domain, for the entire data domain, for the entire project. Let's say you are building an AI solution for your project. You want one agent for data analytics. You want one agent for business analytics. You want one agent for, let's say, data engineering. You want one agent for XYZ task. So when you will be building such a kind of agent which will perform everything, it will become a mess. That's where a new concept came into the picture, which is called agentic AI. Okay, agentic AI. Okay, so agentic AI means now you created this chain, right? Wow, very good, very good development. Let me take this chain, okay, let me put it here, and let me say, okay, this is my one of the chains that I'm using. Perfect. Let me just cover it with this one. Simple. This is my one chain. Now I want to use this chain, okay, and then I want to make another chain which will be linked to this one. Wow, can we do it? Yes. That's why we call it as Agentic AI. So then this will take place. Make sense? Then this will take place. Let's say these are these chains. Then after running this thing, I want to run this chain. Okay. Simple. Let's say I want to run this chain. Then after running everything, I want to, let's say, run one more chain. Let's say this. Let's keep it like this. Okay. Let's say these three chains. One for business analytics, second for data analytics, and then third for data engineering, or so on. Simple. Now I want to like work like this. Simple. I want to work like this. Now why am I just calling it as Agentic AI? Because now I am building a bigger solution. I am building multiple agents, or I can say I can orchestrating multiple agents, and not just orchestrating. This is called stateful orchestration because I want this state. State means basically what exactly you are traveling between the chain. So I want this data to travel here and then this data to be traveled here. Wow. This is the concept of agentic AI. This kind of framework is very difficult with this framework alone, which is AI agent, and this is for LangChain. But when we can just build this kind of stuff, it becomes agentic AI, and we can do it with LangGraph. Because in LangGraph, you have total control over everything. Total control. You are the owner of your solution. So who is the owner of solution in LangChain? You are still the owner, but you do not have the full control. Okay. I will just talk about it. Don't worry. Talk. I will talk about it. So now this is it. This is a very quick brief about AI agent and agentic AI, and this concept should be crystal clear. Then only you can just proceed. Okay, very good. So now let's talk about what is LangGraph. Now you can easily understand it because you have already understood the intent behind building LangGraph. Okay, what is LangGraph? And you know what? This is self-explanatory. Graph is the main word in LangGraph. And just a quick info, LangChain was the first framework by the team who developed LangChain LangGraph, and the LangGraph was the second framework. LangGraph was not the first one, because when they built LangChain, they built it, it was a great hit, okay, but companies started complaining, or you can say developers started complaining that, hey, we do not have full control over the applications, framework, solution that we are building. Can you please allow us full control? So they came up with the new framework or new library called LangGraph. So they said, hey, if you want to use our own, you can say built-in features to build your solution, use LangChain. If you want full control, build LangGraph. But eventually people started using both LangChain and LangGraph both. LangChain for like very basic chains, so that you do not need to write every code from scratch. And then after building those very small chains, you started using building your solution with LangGraph. I know for now it is like too much, but don't worry at all. That's how you grow and learn. You need to gather all of this information, and you will actually learn when you will be just building it, and you will build amazing solutions. Don't worry with this video. So what is LangGraph? LangGraph is built on top of LangChain. Simple. LangChain, and is fully interoperable. That means you can, like, you do not need to switch the code between LangChain and LangGraph. You do not need to do something else. No. LangChain and LangGraph both go hand in hand. Both are best friends. Okay. Or I would say brothers. Okay. Or sisters, because see, so both are like actually integrated. Okay, it's not like if you know LangChain Oh, should I just learn LangGraph? Okay, I am learning LangGraph. Should I learn LangChain? Bro, both are not separated. Both are not separated. LangGraph is just a kind of upgrade of LangChain, or you can say kind of adding more features on top of LangChain. Make sense? So instead of adding more features within LangChain, they just create a new library. And when you will be just building the LangGraph applications solutions using VS Code and all, you will see that most of the libraries that we are importing, either it's, let's say, building the LLM connection, writing prompts, building chains, we will be using LangChain even for RAGs. LangGraph is just for the orchestration and building nodes. Wow, Ansh Lamba, you have used two very heavy words, orchestration and nodes, and we do not even know anything. Don't worry. That's why I used it. And is fully interoperable with LangChain. Okay. So I use two words. Okay. Orchestration, nodes. Let's talk about it. Basically, you can say pillars. This is, by the way, my explanation, my understanding. Okay. So the pillars of LangGraph are, or you can say the two major pillars. The two major pillars of LangGraph are, the first one is nodes and edges, and then second is orchestration, or I would say stateful orchestration. These are the two major pillars that I personally feel, because I have worked with LangGraph. So this is like my observation. These are the two major pillars. Simple. Two major, let's say, pillars. Simple. Nodes and edges and stateful orchestration. That means you can build your solution and you can create independent nodes. Let me show you. When you see these things, these are nodes. You can say node number 1. Simple. Then node number 2. Then let's say node number 2 and node number 3. Perfect. Okay, these are the nodes. Node 1, node 2, node 3. This is edge. Edge, or you can say branch. Same thing. Okay. Edge 1, edge 2. So this decides the flow. What is the dependency? Node defines the execution. What you need to execute. Make sense? And you travel the data. Whatever the, you can say, result of this particular node will travel to the node 2. The result of node 2 will travel to the node 3. Make sense? Make sense? Okay, good. So that's how you just travel your data. How you can just travel your data, we will talk about it. Don't worry at all. So this is all about the LangGraph and stateful orchestration, because data travels from one node to another node. Simple. Very well done. This is the backbone of it. Nodes and edges. And why this is like such a big deal? Because when you create nodes and when you create your own edges, you have full control. You can define the condition, like how it should just flow to the next node, how it should just go to the next node. In LangChain, it's not very much easy. Plus, it does not manage all of the things that you will be managing in Agent AI. Makes sense? Does it make sense? Very good. So now you know the problems, now you know the solutions, now you know why LangGraph, and now you obviously know what is LangGraph. It is just a framework to build Agent AI solutions. Simple, with control. Very good. Now, I have also explained a very important concept called LangChain and LangGraph are not separate. They are well integrated. It's a kind of adding more features on top of LangChain. Simple. So let me just write. It's like adding more features on top of LangChain. Simple. Good. Very good. Now, let's talk about a very important, one of the most important concept. It is called React agents. Wow. This is very important. Now let's talk about the React agents. If you already know about this concept called React agent, very good. If you do not know about React agents, then very good, because you are on the right video. Now you will know it. And I am so sure that you would have heard about this term React agents. I'm so sure about it. Even if you haven't worked with it or developed any solution for it, you would have heard about this term React. React is actually made up of two words: reasoning plus acting. Okay, reasoning plus acting. It is actually made up of two words. That is why I have written like this: re and then act, re and then act. And actually, what will happen? Let me just draw the entire architecture, okay, of the React. So let's say you have this agent. Okay, do I have the better? Yeah, let's use this one. So let's say this is the agent. Simple. An agent is nothing but, you can say, just a kind of node. One of these nodes. Okay, just node for now. You do not need to go much more technical for now. So let's say this is the agent. Now you are this developer. Okay, let's say this one. So you are this developer. Okay, and you have asked one question from this particular agent. Simple. This is your input query. Okay, simple. So you have said, let's say, input query, whatever. Simple. So this is the very first step. Now what this React agent will do, so now this is an agent. One of the most, you can say, powerful properties of an agent is it has access to some external tools. It is not like hard and set rule, but most of the time whenever we are building agents, we make sure that our agent, that our LLM has some access to the outsider, you can say, tools and technologies. Now under the hood, let's say this is a kind of LLM. Okay, this is an LLM. This is not an agent, and for now you can say this is an LLM. Let me bring the LLM. Do I have LLM? Any LLM? No. So let me just say, let me pick that. Yeah, let's say this is my LLM. Okay, simple. So this is my LLM. This can be OpenAI LLM. This can be your Anthropic LLM. This can be your Gemini, whatever you want to say. Let's say this is Gemini. I know Gemini is very popular nowadays. So let's say this is Gemini. Simple. Very good. Now this is Gemini. I want to ask some questions from Gemini. Or let's say OpenAI, because you can relate it to OpenAI better, because you have lived that moment. Let me just talk about which moment. So when you just used ChatGPT back in the days when it was like really new, when you would have asked a question like what is the temperature in Bangalore or any other city, it will not tell you, because it does not have access to the weather, and especially weather like current weather. Or if you had asked about any kind of calculation, it would throw like some wrong calculations. Why? Because it does not have, it didn't have access to the calculators back in time. That means LLM was only able to produce the answers using the knowledge base that it had. But sometimes that knowledge base is not enough. It has to just give you the response on the basis of some external tools. Okay, so for example, you have asked this question from an LLM, and this LLM can answer the question. Let's say you have asked what is, let's say, the meaning of your name. Okay, let's say you want to know the meaning of your name, and congratulations if you do not know about the meaning of your name. Very well done. So let's say you wanted to ask the meaning of your name. So if it knows, it will simply generate the output. It will simply generate the output. Simple. Let's say like this. It will generate the output. Okay, let's say this is the output. But let's say this is like very simple scenario when it knows the answer, but most of the time the question that you are asking right now it doesn't have access. Same way, see, I also asked the question and LLM cannot answer that question, what is the weather right now. LLM is not a weather forecaster. So now I have asked some questions. Now what it will do, it will use its, you can say, superpower. And what is the superpower? Some tools. Let's say it has access to some tools. Let me just draw that. Let's say it has access to a kind of API. Okay. Let's say it has access to some web search. Let's say it has access to some kind of calculator or anything, and it has access to some kind of documents, whatever. It has some tools available. Okay, it has some tools available. It has access to, let's say, running some SQL database queries or anything. It is linked to a kind of, you can say, SQL REPL. Okay, so it has some tools. Okay. So now what it will do, it is directly linked to these tools. Simple. Very good. Now what will happen? Now let me just tell you the real React, how will it take place. So now let's say you have asked a question and that question cannot be answered by LLM. Now what will happen? This LLM will go to the tools. Okay. Will go to the tools. Simple. Now LLM will go to the tools and it will say, hey, do I have any tool that I can just use to answer this question? And yes, for example, yes, it has the access to that tool. Let's say I want to use this API. This is a weather API, let's say. So I know this question can be answered using this API call. Yes, it will use that tool. Very good. And it will make the API call. And that tool will give the response back to the LLM like this. Let's say like this. Simple. Perfect. Now what will happen? The moment this particular LLM made the API call, okay, and it has got the response back. Let's say this is called tool call. Simple. This is a tool call and this is the response, or let's say tool response. You need to understand this concept very carefully because you will be building this solution very, very soon, because I will not explain this thing while writing the code, because while writing the code, I just need to write the code. Okay. So let's say this is a tool call and this is a tool response. Now what will happen? Now LLM will note down the response. Let's say it has a kind of scratch pad. Okay. Let's say a kind of scratch pad. Do I have scratch pad? Let's say notes. Perfect. So it will take care of these things, whatever information you are providing it. Okay. Let's say here it is attached. Notes. Simple. Now tool response will be registered in the notes. It will note it down. Then it will think, do I have the final answer available? If the answer is yes, perfect. Output is generated using the tool call. If the answer is no, that means the final answer is not ready yet. I still want to make more API calls or more tool calls. It will go back to the tool call again and it will keep on running this loop until your final answer is generated. See, this loop will be keep on running until this note section will say, I have everything that I need and you can proceed. Let's say this says I am okay. Now you can simply generate the answer. Okay, let's say. So if it says yes, approved, then your final output will be generated. Make sense? That's how React framework, or you can say React architecture, works. Simple? Very good. So this is understood? Very good. Now the problem with this particular architecture in LangChain was you didn't have control over how to make these tool calls, how to control these edges. It was making these tool calls automatically behind the scenes. I still remember when I was just learning LangChain, I would say years back, I was like, why it is running endless loop? Because it was keep on running the loop even after finding the answer. And I was like, bro, this is too much. And then I got to know about LangGraph. I was like, let's start learning about LangGraph, because I knew like LangGraph is solving some problems with LangChain. Then I got to know, oh, okay, LangGraph is solving this particular issue. because I was just like digging so deeper to solve that problem. And I was like, bro, I know I can solve the issue, but it is taking too long. Then I got to know that we have a dedicated framework for it where we can develop the agents, React agents, not only React agent, by the way, so many agents, but yeah, React agent is like the most popular one. So we can build the React agent using LangGraph, and we can control this loop. We can control these edges. We can control these tool calls. I can even control these tool calls, like how many iteration I want. I have full control now in LangGraph. This is the thing. So in LangChain, we do not have control over this, but in LangGraph, we have control. We have full control. Why? Because this is a kind of node. This is a kind of node. This is an edge. This is an edge. This is an edge. This is an edge. Make sense? Make sense? So this is your React agent, okay? And we will just build this React agent. It is very easy now. Very, very easy. So now, do you know what? In the latest version of LangChain and LangGraph, which is V 1.0 plus, they have rewritten the code for LangChain, which was breaking before. They have just used the LangGraph under the hood. That's what I feel, because when I just make the agents with LangChain, I was just like creating the video for LangChain, so that's why I used it, because I use simply LangGraph to build my agents. I love LangGraph, but yeah, when I was just using LangChain for the video, I saw that it is just actually using the same framework under the hood. Makes sense? But don't worry, we are simply using the LangGraph in this video. Pure LangGraph. So this is your React agent. Now, in LangGraph, it's not just like only building this framework. In LangGraph, I even have human in the loop. So I can add myself within this loop, let's say like this. Wow. This is amazing. Yes, I can even add myself in this loop. Human in loop. Simple. That means before running this loop, or let's say before proceeding, I will be needed to allow, then only it will make those changes. So this is a kind of feature that we have got in LangGraph. Human in the loop. Make sense? That means human approval, a kind of human approval. Okay. Then obviously you have like full control over edges and nodes. Simple. So even if you, let's say, deny that you want to make tool calls, let's say tool calls are expensive, you want to deny it, you can deny it. It will simply break here. Simple. Break means like it will end the loop, it will not break it. So that's how you can just actually work. So see, this is a human. This human who asks the question has the power to decide what you want to do. That is the power of LangGraph. I hope it makes sense, and I hope now your ground level understanding about your React agent, AI agent versus agentic AI, why LangGraph now is clear. Because before directly showing you, hey, you can just build this node like this, you can install the library like this, you need to know why you are learning this, right? Why exactly you need to learn this. If you have LangChain, why you need to learn LangGraph? If you have LangGraph, what exactly you need to learn and what exactly you get? So these questions should be answered first of all, and now I think so it is answered very well. Now let's talk about the installation and how can we just get started with it. It's very simple. It's very simple. So let's say LangGraph installation. So if you want to install LangGraph, or it's not just like installation, it's like setup, LangGraph setup, because installation is very simple. It's just one line of thing. So let's say setup. So if you want to just work with LangGraph, you need some tools, you need some softwares, you need some IDEs, because obviously I will not be writing my code in Notepad. Okay, I'm not that kind of a guy. I am a Gen Z, so I started working with code and all directly in IDEs. If you know how to write the code in Notepad directly, very good, keep it up. So I will be just using any IDE, let's say VS Code. So you need VS Code. If you want to use any other IDE, let's say PyCharm, you can use PyCharm. If you want to use Cursor, you can use Cursor. If you want to use Anti-Gravity, which is a new one and is actually good because you get the agentic capabilities. You get agentic capabilities with VS Code as well, but it is for like just for few tokens per day. But if you just upgrade it, you can just, if it's like you can use any code editor. I don't need to promote anything, and I do not like promoting any code editor because every code editor is good, and I personally love VS Code, so you can use any code editor. So this is the first thing that you need. Then you would need Git. Why? Because we'll be just pushing our all the code in the GitHub, so that you can also highlight your learnings in your resume, and you can just attach any kind of thing. Plus it's very easy, simple. Okay, then you will need oh yeah, API. So you would need one API key. It can be from OpenAI, it can be from let's remove Git. Let's not worry about Git, because you'll be like, bro, how to use Git? We do not know how to use Git, so let's forget about it. So if you have Git, it's good, but let's forget about it. So let's say VS Code and let's say Fast API, but still I will just show you how to just push the code to GitHub, but I simply removed it. Don't worry at all. Let's keep it. Let's keep it. Okay, I know you are like, oh man, please include Git, because it's like a good skill to simply show it in your resume. So let's say you would need one API, and if you would need API, you can just create your account either in OpenAI dashboard or Anthropic or Gemini. In today's era, I would expect that you would have some API keys available to use the closed source models. I can use open source models as well. I have Lamba installed, I have Docker model runner, I can install those things. But do you know what? If you want to create agents which can efficiently make tool calls, you need some high level models. I'm not saying that open source models cannot perform this thing, but if you want to use those high level models with open source models, you need that system which can handle that particular load. And then you will say, bro, I do not have an expensive laptop which can handle this thing. Obviously not everyone can have like expensive laptop. I'd also like have a like decent laptop. So that's why I'll be using a closed source open model. Okay, I think Mac users can easily just run local models easily, because they have a kind of I don't need to explain that kernel thing now, so they can just run the models efficiently. But yeah, if you are on Windows, and I'm also on Windows, you can just use closed source models for this particular purpose. And now let's see how you can just get started with it. So first of all, let's try to install VS Code. So you can simply go to any browser and search VS Code, download, and you will get this link, VS Code download. If you are on Windows, download it. If you are on Debian, Ubuntu, or Amazon Linux, you can just download it. And if you are on Mac, you can just download it like this. Simple. First thing is done. Then download Git. Okay, and just forget about Git. Just forget about Git. Okay, because it will take extra 5 to 10 minutes. Okay, so now you can just go to OpenAI. Simply go to OpenAI API. Simply search OpenAI API. Search, and then you can click on API platform OpenAI, and perfect. Here you will land on the platform like this. And I'm not talking about ChatGPT. Okay, this ChatGPT is different, OpenAI is different. ChatGPT is just one of the products that OpenAI has built. Okay, so you can simply go to login and click on API platform, not ChatGPT or Codex or Sora. Go to API platform. Simple. The moment you will click here, you can simply put your email address, and you will land on your email, or basically OpenAI portal. So then you will land on this kind of project page, or you can say default page, where you will see something like this. Even if you do not see anything, it will be like something else, but you do not need to worry at all. You can simply go to this button called settings, and when you click here, you will land on the settings page. And after clicking on the settings page, you just need to go to this left bar and click on API keys. Simple. The moment you will click on API keys, then you can create your new API key. Simple. So I can also create my API key, create new secret API key. I can simply say LangGraph tutorial. I think I created one for LangChain, but yeah, let's say LangGraph tutorial. This is my API key name. Project, I can keep it as default project, and I can click on create secret key. Simple. And obviously I can show you, because I can delete this API key as well, but simply I will just keep it, you can say, hidden. So I have created my API key. As you can see, it is here, and you just need to copy the API key immediately, because after that you cannot copy it. Okay, so you can create one and then save it in your notepad or whatever, because we'll be just pasting it in our VS Code. Don't worry. So just for the 5 to 10 minutes, you can simply copy it somewhere. Perfect. Now you'll be very happy. Wow, we created the API key for free. Now we are good. Not actually. Now you need to go to billing. Okay, or you can say not billing exactly. I think, yeah, billing. So here you will see, after go to billing, you will see something pay as you go, and here you can simply go to add to credit balance. You can add some credit. I think the default or minimum amount is $5. You can just add $5, and then you can just use it as pay as you go model. So basically what will happen, whenever you will make an API call, it will use this amount to deduct and fulfill the task that you are doing. I think if you will ask me that will $5 will be enough for this entire video, I will say more than enough, because it's not very, you can say what exactly you are thinking. So you will say $5, that means you will hardly make 5, 10, 15, 20 API calls. Not exactly. When you use OpenAI API for LLM for text-based generation, that you'll be just using, and obviously you'll be just using normal models, not like very expensive models. So you hardly spend, I will just show you the chart as well, and you will see like how much you spend when you just make an API call. So you do not need to worry about that thing, because $5 will be like more than enough. You can just watch hundreds of videos like this with this amount, and I'm not kidding. Okay, so you can simply add some amount, okay, in your account, and you can just go with pay as you go. This is one way of doing it with OpenAI. If you want to go with Anthropic, you can simply go to Anthropic API and then sign in and do the same stuff. It will be having its own particular, you can say, dashboard, and then you can simply create an API key using the same thing. There as well, you will need to add some amount. Same thing, you can just go to Gemini, create the API key, and I think Gemini provides some free access to student account. If you have student account, you can just use that particular thing, okay, and you can just create the API key. In short, you can use Anthropic, Gemini, OpenAI, whatever model you want to create, or whatever provider you want to use for this particular tutorial, because we'll be just using API calls or making API calls. Simple. That's it. Once you have the key, once you have the amount, then you can just make some API calls. Make sure you have some amount, okay? Otherwise it will throw the error that, hey, you do not have the amount in your account and you are just trying to make the API calls, trying to be smart, right? So if you do not want to see those errors, simply have some amount here. Simple. That's all. And now I will quickly open my VS Code editor and let me show you how you can just get started with it. Simple. So this is my VS Code editor. First of all, this will not be exactly like yours, because I have used some themes, some changes on the left hand side, but it is fine. Simple. You do not need to worry about that. One thing, now you need to go to file and you just need to click on open folder. Simple. Now open any empty folder. It can be in C drive, it can be in D drive, okay? Make sure it is not in your OneDrive. It doesn't make any sense to create the folder in OneDrive. Not a big deal, but maybe you will be having some access issue when you will be just pushing that code to GitHub or whatever. Make a new empty folder in local disk C and then open that folder like this. So I have created a folder called LangChain tutorial and it is empty. As you can see, there is nothing here. Okay, so I am working with this particular folder. Very good. Now I will open the terminal. Control Shift and not backslash, it is called, I think, back tick. So Control Shift and back tick. Ansh, Lamba, show us the normal way. Okay, click on 3 dots, go to terminal, click on new terminal, and you will see the shortcut. In Windows you will see this, in Mac you will see something else. By the way, how to use Mac? I have never used Mac, and I always think like, if I like how exactly we need to use Mac. I need a guide, someone who can teach me, hey, you need to use Mac like this. I would need a buddy. So let's say this is my you can say LangGraph tutorial and C drive. So first thing first, I need to download a very special thing. It's called UV. Ansh, Lamba, what is this? Is it like related to LangGraph? No, it is related to Python. So remember, whenever we want to create the virtual environments, yeah, so what we used to write? We used to write Python -m VNV and .VNV. And wait a second, my ultra legendary people, I forgot to mention one important thing. So you would need Python as well. Okay. We are learning LangGraph and Ansh, Lamba, where is Python? Yes, we need Python. See, I thought like you would have some common sense. I thought. Then I got to know, wait, Common sense is not very common nowadays. So you need Python as well. Okay. So once you have downloaded the VS Code editor, you would also need to download the Python as well. So if you want to download Python, simply go to your favorite browser, click or search Python download. Simple. Go to download Python, and here do not download directly from here. It will download the 3.14, which is like full of bugs. Okay. So now it is like bug fix error right now. You can download 3.13. It is fine, but I personally like 3.12. It is very stable and very good, very good. And 3.13 is also in the bug fix zone, but I think 3.13 works fine for me, but 3.12 is better. So you can simply go here and download 3.12 from here. Download, simple. Click on download and it will ask you to install it. Make sure that you tick the box called add dot something to path. So basically it will add that particular path to your environment variable. Simple. So you need to check that box and then click on install, and then your Python will work fine. Okay. If you do not check that box, it will just throw some errors when you'll be just building virtual environments. It will just throw errors while just, let's say, switching the virtual environments. It will not actually run that interpreter. Simple. Makes sense. Okay. Now let's get back to our VS Code. Simple. So first of all, let's check our Python version. So I will simply write Python, and I am using Python 3.11.9. I have 3.11, I have 3.12, I have 3.13. Yes, but I personally currently use 3.11 because that was the Python version I used last time. So I can even change it, not a big deal for me. Okay, so now I will simply say clear. Clear is not defined. Let's say exit, control C. Oh man, let me open a new terminal. So now what I was saying like if you want to create a new virtual environment, you will simply say Python -m VNV and then .VNV, right? That's the way we use with, or you can say we work with virtual environments, but we do not need to do this thing. This is like older way to do it. Now we have UV. UV manages our Python packages, our virtual environments, our get everything. So you simply need to download pip install UV and hit enter, and which can cause conflicts. Okay, we don't worry at all. So it will simply say a new release of pip is available, requirement already satisfied. That means I already have UV. In your case, it will download UV. Okay, and now if I write UV, I will see this thing, all of the information, right? Makes sense? And it is saying an extremely fast Python Python package manager. Very good. So I love UV. You will also love UV after this tutorial. I'm so sure about it. And do not worry, I'm not the creator of UV. I am simply using UV. I'm simply educating you about UV. So now I'll be just using UV for everything. So now if I want to initialize my virtual environment and everything, I simply need to run this command UV init, and that's it. UV init, and that's it. Hit enter, and you will see some files automatically created for you. .get, getignore, Python version, main.py, toml file, readme. UV created all of these files. Simple. And I can go to my Python version. In your case, it will get by default Python version that it has, right? And in my case, it has picked 3.12. I can even change to 3.11, 3.13, whatever, but 3.12 is fine. So now you need to run one more command, UV sync, because it will create the virtual environment for you with this. Perfect. Now you can see virtual environment is created. Simple. If you do not see .git folder, do not worry at all, because you either do not have the git installed or you have made this folder as hidden. And if it is hidden, it is good for you, so that you cannot change anything in this thing, because .git folder is very critical. You should not touch it. So just ignore. So now what I will do, I will simply say .venv scripts and then activate. Basically, I want to activate the virtual environment. Make sense? In I think Mac, it is also similar. I think .venv. You can simply go to this folder and you will see .venv. Because I hardly use Mac, so I can simply search it for you if you want to. Activate virtual environment in Mac. And there's nothing to judge in this. I do not use Mac. I do not like Mac. Why do I need to learn the commands for it? So yeah, it is. In Mac is source virtual environment name, which is .venv, then bin, then activate. In our case, in Windows users, it is .vnv, then sources, not sources, scripts, and then activate. Simple. Okay, perfect. So this is the command that we have to run, and let me just hit enter, and you will see this virtual environment created. See, wow. Now if I write Python, you will see 3.12, not 3.11, because 3.11 is running in my global environment. But for this virtual environment, I'm using my 3.12 interpreter because I have both installed. If you have just one interpreter installed, it will just show you one. If you have multiple, you can just change it from here as well. But to be honest, it's fine because Python version after 3.9 or 10, it's the same. But before that, it can cause some problems. So just make sure that you have the 3.10 or 11 above version. It's better. Simple. Okay, very good. So that's all that we need to do with UV, and we are good. Now we will be just creating some folders. Simple. Okay. Now here you will see that I will be using some LangChain libraries as well. But those LangChain libraries are just the packages that we use to work with LangGraph. Do not feel like I am writing LangChain, so I need to know everything in LangChain. No. If you already know about LangChain, it is good. If not, I will try my best to cover all of the things that are required for you to know in the field of LangGraph. Simple, because the things that we need in LangGraph from LangChain are very simple, are like something that when you see at once, you understand it immediately. It's not something like out of this world. It's not something a kind of new concept. If it would be a new concept or a different concept, I will explain it to you. Otherwise, I will simply say, write this code. This is for this purpose and that's it. Simple. I hope the expectations are set. Because see, if you are new, you can feel confused. Hey, like we are learning LangGraph and this is writing LangChain. So do not worry at all. Those are simply the packages. Simple. Very good. So now I will simply install some of the things, and before installing it, I will create one very important file. Just click on this plus new file and create .env. Okay. So here you need to create the environment file, and here I need to create one environment variable. It's called OpenAI API key. Simple. And here I will paste my OpenAI API key in double quotes. Simple. You can also create this variable and save it. Control S. Simple. Obviously, I will not show you this thing. So I will create one more file for you so that you can see all of the variables. .env.example. And I will simply say OpenAI API key equals to. So this is basically the best practice that we do when we need to just push our code to GitHub. And obviously I will push my code to GitHub. So you can see this file just for the reference, and you can create your own .env file using the same thing, using same variables. So now if you are using, let's say, Anthropic, then you can just write Anthropic API key. Okay. If you are using Gemini, I think it is called Gemini API key. I can just confirm, don't worry at all. But for OpenAI and Anthropic, it's confirmed. For Gemini, I can just confirm right now. So let's say Gemini LangChain. Chat Google Generative AI integration. Yes, this is the one. So what is the key name? Let me just check. Oh, it's called Google API key, not Gemini API key. Okay. So let me just write it for you. So you can just go here, and it is called Google API key. Simple. Okay, makes sense. Google API key. And okay. Chat Gemini. Yeah, Gemini is the model, Google is the API key. Perfect. And I can similarly look at the Anthropic quickly just to confirm. So for Anthropic, this is the one. Yeah, Anthropic is like Anthropic API key. Simple. Very good. So now your environment is created. Now you are just good to go with the next steps. Simple. Very good. So here I have just pasted my API key as well. I will just simply remove it. Do not worry. Do not feel happy. And by the way, this is not a complete API. It's like very big. Okay. So this is my API key, OpenAI API key. In your case, you can just paste it here. In case of Google, you can just paste it here. Simple. So now let me just create a quick folder, or just you can say a Python file is enough, I would say. Yeah. So here, perfect. So I will create one, and then I can say basics.py, because obviously this masterclass is structured in the form of chapters so that you can just learn step by step. So that's why I'll be just using the naming convention called like 1, 2, 3, 4, 5, so on. Simple. Okay, very good. So now you can even remove main.py. This is a default Python notebook that your UV creates. Okay, so now I simply need to just show you some of the packages that you would need to install with your LangGraph. Simple. So first of all, let me just tell you, whenever you want to install any package, you can install directly with your requirements.txt, because in my case, or you can say in your case, you will use my GitHub repo, right? So you will also see one file called requirements.txt. Simple. I will also show you how you can just create it. So when you create like requirements.txt, you can download that particular all the packages step by step. It's not a big deal. Simple. And if you just want to download all of the packages that you would need here for your this particular course, you can just create one requirements.txt, and let me just paste that requirements.txt here, and let's say I will simply add requirements.txt, and here I can just paste all of the packages. Currently it is empty, not a big deal, but yes, if you want to install anything, you can simply go to the terminal and simply search uv, not search, simply type uv, then add uv add, and then -r requirements.txt. In Python we simply say pip install, or it can say pip install -r requirements.txt, right? So here we simply say uv add -r requirements.txt, hit enter, and obviously it is empty, so it will not install anything. When you will download my requirements.txt from GitHub, then you can obviously run this command and it will automatically download all of the packages in your case. So you just need to chill. Simple. But obviously I don't have any package right now, so let me just install some of the packages. So first package that I want to install is LangChain OpenAI. So I will write uv add. So whenever I want to add any package, instead of writing pip install that package name, I just simply need to type uv add, and that's it, and it will automatically add that particular package for me. That is a kind of thing that we add, or you can say do in uv. Simple. Okay, so let me just add 2 to 3 basic packages. So it will be like LangChain core. So LangChain core is downloaded along with some amazing other dependencies as well, and as you can see, my LangChain package is 1.1 plus, I think. Yeah, so it is 1.2 because this is the latest one and it has like some amazing changes in LangGraph as well. So yeah, okay, and after that I can simply add uv add LangChain, then OpenAI. If you're using Anthropic, you have to download LangChain Anthropic. Let me just show you. Let's say LangChain and Anthropic. Simple. So it will download all of these things. If you are using you can say Gemini, then you can simply get that specific package. So you can get the package from, let's say, where is that model? Google LLM. Okay, so I think it is LangChain Google, but still I can just simply confirm before telling you. Yeah, so you can simply download this package, LangChain Google GenAI. Simple. So our package is completed. Very good. Now I need to create a connection with the LLM. So that is why I have just considered this basics file where you can simply create a basic connection and then you can just get started with it. Now you can get started with your tutorial with Python scripts. But personally, I like writing my code in the form of cells, basically the notebooks. The same way we write our code in the Jupyter notebook. Okay, so this is very similar to that. So if you want to get started with the masterclass with notebook, you can simply change the file format to .ipykernel. Okay, Python notebook IPYNB. Simply save it and then it will become your Jupyter notebook. Simple. Very good. Now when you will be selecting the kernel, let's say select kernel, just make sure you have Python environments. In your case, you will not see Collab. This is basically a kind of extension that I have downloaded if I want to connect to Collab notebook, but this is like out of scope for you. Like you can use Google Collab as well because you get the free GPUs, but that is not required for this course because we are using closed source LLMs. Simple. So let me just select kernel, Python environments, and here you can just pick this particular environment. Simple. Do not pick global environment. No, you simply need to pick LangGraph. Simple. Okay, let me just pick it, and this time you can see this thing. Perfect. Let me just save it. Very good. So here I will just show you one code, and this code will be there in every notebook because in every notebook we will be using LLM, right, to make AI agents, agentic AI, whatever. So there is one boilerplate code, kind of boilerplate code that we will write in every notebook, but you need to understand that as well. First of all, you need to create one code cell. Simple. And then I will write from, let's say, LangChain dot core, and then let's say you want to import chat models. Now there are two options to import the chat models. There was like initial way, okay, which is still used. It's not like it is not used now, but if you just want to use the new method, you can still use a new method if you want to. So let me show you how you can just do that. So if I will personally refer this course to OpenAI, and it is exactly the same in every other thing as well. So let's say OpenAI, and here if you go to chat OpenAI, perfect. So here you will see, where is that new method? Yeah. So this is the older method that I personally like from LangChain underscore OpenAI. You can simply say import chat OpenAI. Simple. But right now they have just simply created one more generic class where you do not need to connect specifically to OpenAI. You can connect to any other, you can say, model, Gemini model, Anthropic model, and you do not need to worry about any kind of dedicated connector. But I personally like this particular method. Okay, so I will prefer you using this one. It's pretty much straightforward and more readable. So let me just go to my VS Code. So I will simply write it here, this thing from LangChain OpenAI, import chat OpenAI. Simple. Makes sense. So here I want to now create an LLM object. Simple. Now I know that in chat OpenAI, or basically OpenAI, I have so many models, basically chat models. I have GPT 4.1 mini, I have, I think, 5.1 as well, this as well, and 4.1 mini as well, 4.0 mini as well. There are so many models, and if I just go to the list, you can literally see that we have a long list. So OpenAI models, simple. So here you will see a long list of it, and you can pick any model. I will just tell you which is the best one for this particular course. I think you can see GPT-5 mini. Okay, simple. This is a good model, by the way, but this is a little bit costly because you can see $0.25 for input per 1 million token and $2 for output. Still, it is like more than enough, but we will just simply pick the cheap options. So I will simply go to, let's say, GPT-5 Nano, and you will see this is very good. $0.05 for input and $0.4 for output, and this will perform almost all the stuff that we want to perform here. Simple. There are some more other options as well, but I would say this is the best one, GPT-5 Nano. So I can just copy the name here, and I can just go to my VS Code, and I can just paste it here. So I will remove it, and I will paste it here. I can remove the date because date is just for the last updated date it was updated. So GPT-5 Nano, you can create this instance or basically object of LLM. Now after this step, everything is same. If you are using Google Gemini, Anthropic, any model, everything is same. Only these two lines are different. Simple. Only these two lines are different. In case of chat OpenAI, you have to just use OpenAI and then chat OpenAI. In case of Google Gemini, I have already showed you. Still, I can just show you again. Let's say you are using Anthropic. So here you can simply use this code. Let's say from LangChain Anthropic, import chat Anthropic AI. And obviously you can just pick any model. You can pick Claude, Haiku 4.5, or you can pick Sonnet 4.5 because Opus is expensive. So Haiku or Sonnet is fine. Simple. And if you are using Google, the same way, click here on the Google, and here you will see the Google code as well. And let's see, where is that? Okay, perfect. So here you can simply define Gemini 3 Pro preview or Gemini 3 Pro. That's it. Makes sense. So only this thing is, these two lines are different. Everything else is exactly the same. Simple. So now I want to run this model, right? I want to just use this LLM to build my LangGraph application, but I cannot use it directly. Why? Because I would need the API key to make the API calls. Now you will say, Ansh Lamba, you have this here, right? Yes, but I didn't load this thing, right? So I first need to load this API key. There are multiple methods. The best method is using a load.env method. Simple, load.env method. So in load.env method, you simply need to load the, you can say, your .env file. So what it will do under the hood, it will create the environment variable on the top of all the variables that you have defined in your .env file. Simple. Let me just show you how you can just do that. So simply go to terminal and download or add uv add.env, I guess. I think it was already added when we just loaded that thing. So here I can write from .env import load.env. So this is the package name, and then I need to run the function called load.env. Simple. And let me just run this code in the new cell because I want to show you a very small step. So I will run it here, and it will just prompt you to install this thing. Simply click on install. It will install the IPy kernel. So now this code will be running. Now what will happen? Whatever variables I have written in my .env file will be automatically loaded in my environment. You want to confirm? Let me just show you. If I write import OS, simple, and I want to confirm that if os.environ, and environ name is OpenAI API key, okay, if this exists, simply say OpenAI key is set, otherwise you can raise the error as well, raise exception error, value error, whatever. Let's try to run it. What did I get? OpenAI key is set. Simple. If you get this, only then you need to proceed. Otherwise, you should not proceed. Why? Because you first need to have your OpenAI API key set. If you do not see this error, then maybe you have not created this .env file, or maybe you have not saved it with the right name, or you have not saved this file. Maybe it is there, but you forgot to save it. So just make sure that it is saved as well. Simple. Now you are good to go. Let me now just transfer this code here, and perfect. So these are the sections for our library. So we will be just reusing this particular area to import the packages. Simple. So I'll just reusing this thing. Okay, makes sense. So this is my libraries that I'm just importing, and now I will create the LLM here in this cell. So I will write LLM equals to chat OpenAI. Let me just write it here. Good. So this is my object. But it's saying chat OpenAI is not defined, obviously, because we didn't run this cell. So let me just run this cell for one more time. So now it will simply import everything. Now let's run this. So this is my LLM object that I have created. Now this LLM object is created. That means now I can use this LLM to make the API calls to the model called GPT-5 Nano. The same way I asked the questions from ChatGPT, now I can do the same stuff with the LLM object as well. Let me just show you. Let's say I want to ask one question. So let's say I will say LLM, and there is a .invoke method in the LangChain. LangChain, LangGraph both. So whenever I'm saying LangChain, I'm referring to LangGraph. Whenever I'm just saying LangGraph, I'm just referring to LangGraph. Simple, because both are connected. So I will say I want to know the meaning of this would be a very high level question. So let's say meaning of water. Water. Okay. So let's say I want to know the meaning of water. Simple. And I want to ask this question. So I will wrap my question here and I will invoke it. Simple. I will invoke it. I will run this cell and I will say shift enter. So now let's wait and let's see what answer do we get. It will take some time obviously to throw some answer because it will fetch the answer, then it will just show you. So I have just got something AI message. Content equals to here are a few ways to understand water. I think this was a difficult question for LLM as well. Scientific meaning. Wow. Water is a chemical substance with the formula H2O, 2 hydrogen atoms bounded to 1 oxygen atom. Wow. It exists in 3 forms, solid, liquid, gas, and whatever. So this is the answer that I have got from LLM, from AI. Kind of AI, right? LLM is also a kind of AI. Deep learning model, transformer model. Okay, so that's how I can just ask the question. But you know what? I can only get the answer for the question that it can answer. So if I will ask the same question that I asked to ChatGPT few minutes back, what's the temperature in, let's say, LA? Okay, let me just run this. It will not tell me. Why? Because it doesn't have access to network APIs, nothing. It is just an LLM, pure LLM. Do you mean Los Angeles? Yeah, I meant Los Angeles. Oh, so it is saying finally I don't have real-time weather data here unless your platform support this thing. So it is specifically mentioning that first of all it is confirming like LA means what, okay, and second it is asking like me to provide some kind of clarity about the platform because my platform doesn't have the support with current APIs for weather. Simple. So when that thing happens, then you need to make sure that your LLM is equipped with tools and you'll be just working with that thing. Don't worry at all. But for now, we do not have any tools or all. Okay. But we can just use LLM to make the question calls that it can answer. Simple, because LLM can perform so many things other than just making the API calls. So it can actually answer so many things and it can work on the responses as well. So we are good with that. So let's say this question is good and I can just make the API calls. And as you can see, we are just simply making API calls. Obviously, it is just using my amount, which is stored in the OpenAI account. Simple. Okay. So this is a very basic notebook that we have created. Simple. So now what I will do, I will just show you and just remember this thing. Okay. So this is basically a kind of boilerplate code that we will be just reusing in every notebook. Like first of all, importing the libraries and then making the API call. Simple. So now I want to show you how you can just create your basic and very first LangGraph. LangGraph means graph. It is a kind of graph. Graph means nodes and edges. Same like here. If I go here, so this is a graph, right? This is a graph where you have nodes, edges, everything. So I will just show you how you can just create your very first graph. Simple. And let me just show you how your first graph will look like. So let's say first graph. Simple. First graph. So here the requirement is very simple. Let me first of all explain. You will create your very first graph and the requirement is you are a developer. Okay. Developer of the graph and obviously the user as well, both. So you need to create your very first graph. So it should be like very simple, a kind of greeting message. That's it. That's how you learn and grow. Okay. So now greeting, yeah, very first is like greeting, simply like just one node and that's it. Simple. Very first node. So because that's how you will learn like, okay, how we can just create these nodes. Simple. So how you will just create this graph, let me just show you. So let me just grab that particular code for it and it will look like this. So let me just go to mermaid to Xcali draw. Yeah. So here, let me just write the code for it. Insert. So this is your tag or basically graph. Simple. You can just draw it here as well, or you can just use the mermaid website as well. Let me just show you that as well. Mermaid live editor. So here I will just write the code. From where that code appeared, do not worry at all. I will just show you. That is just a way to just create or display the graph. Okay, for now you do not need to worry at all. This is just a kind of visual way, and I'll be just using this particular website to create or visualize that thing. Simple. But for this example, I'm just using my native library. Perfect. So you need to create this graph where you will start the graph, you will greet it, and you will end it. Simple. This is your task. You need to create this graph. Simple. Let's draw it. Let's draw it together, and not just draw, let's craft it together. So first thing first, you need to get started with it using a kind of schema. The first thing in graph that you should have in your mind should be schema. Like what exactly you need to travel from one node to another. Okay, the step one should be define the schema. Now in LangGraph, we have a very good name, or you can say in the AI era, we have a very good name of schema, or second name of schema is called state. It's called state. State of your graph. Simple. So let me just write the heading. First graph. Simple. So first graph, and let me just write it here. Markdown. Let's say step one. Step one is define the schema. Simple. This is the very first step. Define the schema. You need to define the schema of your node. And do you know what? Schema should not be changed. And schema can be changed but should not be changed. This is your something that you should have in your mind. Simple. You define the schema first and then you build your graph. Simple. Let's say in my case, I want to define a schema where I want columns or keys such as name and message. These two things. Name and message. Simple. And you can define a schema using two things. The first is lightweight schema. The second is heavyweight schema. Heavyweight schema is like with strict rules. The lightweight schema is like without strict rules. So we will just continue with lightweight schema, and we always work with lightweight schema. We use heavyweight schema when we want to build very strict rules, but it's fine. I will just show you that as well later on. But currently we are simply building lightweight schema. So if you want to build a lightweight schema, we will use a package called typing, and I will import typedict. Simple. I can import list as well. So this is a kind of library in Python that we use. So here I will create a class. Which class? I will call it as, let's say, schema, or you can say graph schema. Simple. Graph schema. And while defining this class, I need to inherit typedict. Simple. So that I can just create all of the columns with ease. So I want just two keys. First of all, name, and this will be of string type. Simple. I want greet, or let's say not greet, let's say welcome. Let's say welcome, anything. Okay. Or let's say message. Okay. Message. And this will be of string type as well. Simple. This is my schema. This is my schema. Perfect. My schema is ready. Now I know that my graph will be just carrying this particular thing, right? Now the step 2 is very easy. Now you need to build the node. But when I say you need to build the node, you need to build the functions of nodes, like what exactly you need to execute within the node. So I will say step 2, create the node functions. Okay, node functions. So in my case, I just have single node. So very simple question. How many functions will I have? Only one. Obviously, only one, right? So I will simply say def, very simple Python function, and I will say welcome. This node name is welcome. Simple. Now it's very important. And by the way, let me just nose it. It is just keep on writing my code and it is not letting me write any code, bro. You're making me lazy. So it's actually very good when you're just developing something. I want to explain you, and I do not want you to be like distracted by looking at the code. So that is why I have just turned it off. By the way, it's very good. You should use it. And yeah, let's talk about this function. So basically now this is the, you can say, very important concept of the entire graph thing. Now you will be creating nodes. Yes. Now in every node function, basically node function, you have to use something called as schema. And this is the backbone of stateful orchestration. Now what will I do? I will create this function and I will use and you can say a variable. Let's say schema. Let's say schema. Okay. Because I am a data engineer, I am an AI data engineer, so I like to use schema word, but you can also use state. Okay. So let's try to use state. Simple. Now this is state variable which will be available to each function automatically by default. By default. Because that is the LangGraph framework design. That's how like LangGraph framework is designed. And this state variable will have the data type that you have defined here. Graph schema. That means it will have name and message. Wow. Yes. So you can say this data type of this particular variable is graph schema. Simple. And what it returns the graph schema data type, because that what we should return every time. Simple. Makes sense. So this is a very first step. So I have defined my function def. Simple. Okay. Now I will, let me just add some space. Now I will use this particular variable state. Now we know that this state is a kind of dictionary, right? Typed is a dictionary. It will convert this particular object into a dictionary. Simple. So now I want to fetch name and message from the state, from the current state, right? So I can write, let's say, current name equals state of name, current message equals to state of message. Simple. Current name, current message. Simple. So I have simply fetched the information. Now do you know what will I do? I will simply make an API call. How? By using LLM. I will simply say response equals LLM dot invoke, right? Now I need to just pass the message. So I will write like this using f string. My name is, and what is my name? Current name. Simple. Simple. And then I will pass the message exactly as it is. Current message. Now response, in the response I get everything, as you know. See, chat, OpenAI, profile and whatever. If I, let's say, run this again just to show you, so I get everything like AI message, then content and everything. If I want to just fetch the response, or basically the content, this content only, because in the response I have so many things regarding tokens and all, so many things like metadata. I don't want this thing. I just want the content. I can say dot content, then I will only see the text message, right? That's how we fetch the information. Fundamentals of Python. That's why we say fundamentals are important. But nowadays, no one wants to learn the fundamentals. Everyone wants to directly jump onto the LangGraph, LangChain. Cover your fundamentals first of all, bro. So I will simply say dot content. Simple. This is my response. Now what will I do? Do you know what? I will change the message. Wow. This message was initially something else. That was my message, user's message. But I will change it to AI message. I can do that. I can do that. How? I will simply say state of message equals response. Simple. And I can simply return state. Simple. Wow. This is amazing. And just to like make it more beautiful, I can simply say, so that you will also see the change in the real time, I will say let's say I can also use plus. Yeah, let's use plus. So I will say your message was, okay, your message was current message. Let's use F. Your message was current message. Here is my response, and then I will just write the response. Simple. So this is a current state. That means I have changed the state of this message to this updated message. Wow. And now I'm returning this state. That means the entire dictionary. Did I change name? No. So name will be as it is. Name will be as it is. And now, very important concept. Whenever you write something here, state message equals to this thing, it will automatically update the value with this latest message. That is again the fundamental. That means you can make the in-place changes in the dictionary, right? Have you studied about pointers in Python or in any programming language? No? Fine. So what will happen if you have a dictionary, right? Let me show you. If you have a dictionary like this, let's say dictionary equals to A10. Let's say the value of A is 10. Simple. And if I just print the dictionary, I will get A10. But now if I say dict of A is equals to 100, and if I just print dictionary, it will make in-place changes. See, A equals to 100 now. That is called pointers, like pointers lesson. Okay, so I just made the changes in the message dictionary, message key of my dictionary, and I'm returning this. Perfect. This is my step 2 because I just have single node. Simple. I just have single node. That's it. Now if I have like just single node, so what I will do now, I will create my state graph. Yes, we just call it as state graph. So I will simply say step 3, create the state graph. That is a better name, and that is a, you can say, name given in the LangGraph as well. So create the state graph. Simple. So in order to create the state graph, you need to import something from LangGraph. You need to import from LangGraph, import state graph. Let me just check the exact dictionary package name. Yeah, it's langgraph.graph. Okay, import state graph. Simple. So you need to import langgraph.graph, and then you need to import state graph. Simple. Very good. Let me just run this, and you will see error obviously because we have not imported LangGraph module. Let me just add that as well. So I will simply say uv add LangGraph. Perfect. Let me just run this. Perfect. Now you just also need to add start and end. This is very important in the graph. So this is my package that I need to import. Now I will create an instance of the graph. So I will simply say graph equals state graph, and then I need to pass the argument as my own graph. That means my schema of the graph, which is graph schema. Simple. This is my graph object. Simple. And now once I have the graph, now I will add the nodes to this graph because currently this is an empty graph. So I will say graph.add node, very first node. Which node? Welcome. And this is my graph name. Oh, sorry, node name in the graph. Now, which function is associated to this particular node? The function name is welcome. Right here. As you can see, welcome. Oh, okay. So we are simply creating the node. Now my node is created. Now I need edges, branches, And in Lamba, we just have single node. So what branch, what is that? So even if you have single node, you always create two branches, start and end. That tells LangGraph that this is the starting point of the node and this is the ending point of the node, or basically starting point of the graph and ending point of the graph. So I will say, let me just add the comments. Graph.add node, and I want to add basically edge from start to welcome. Basically we create edges between nodes, so we get two nodes by default, start and end. These are basically the nodes, by default nodes. So I'm saying, hey, create my one edge from edge, create my one edge from start node till welcome, and then second node from welcome to end. Make sense? Very common sense, bro. You just need to create a graph start to end, simple. So you will first of all say start welcome and then welcome to end. Graph.add edge, welcome to end. So this is it. My graph is ready. Really, graph is ready. Yeah, kind of. I just need to now compile it. That's it. Okay. So now in order to compile your graph, okay, in order to compile your graph, you would need to first of all run this cell. Welcome is not defined. Very good, very good, very good. Do not run this function. F your function invalid syntax. What is, oh, okay, I forgot to add plus sign. By the way, I'm using f string, so why do I need to use plus sign? I will use my variable directly. That's the best thing about f strings. Okay, now I can just run this. Simple. So this LangGraph object is created. Now let me just say markdown, and let's say step 3 or 4. Step 4. Step 4 is compile the graph. Simple. So if I want to compile my graph, I again need to import something. So I will simply say from LangGraph dot graph, not dot graph this time. I think for compile I can simply compile it directly. I think so. Yeah, I think I can compile it directly. I can simply say first graph equals my graph object, which is graph here. See, graph.compile. Simple. Let me just run it. So this is completed. Wow, this ran successfully. But do you know what? Whenever we run anything, yeah, whenever we run or basically create our first graph, we do not just want to compile it, we actually want to see it as well, so that we can just make sure, okay, our graph is actually running fine. Make sense? So for that we have a very special library that we just use. It's called from, I think they just keep on changing it, but do not worry at all. ipython.display. Yeah, import image, and then you can just import display. Simple. So this way you can actually import these things. So what will happen now, I will write one line of code and it will draw the mermaid diagram for you by default. Okay, and you have to write this code after. So let me just write that code. It goes like, I think, image, okay, and then image graph, or you can say your first graph, whatever you have compiled. So in my case it is first graph, and then you can use render, but I will use dot get graph, and then you can use dot draw mermaid png. Simple. And you need to make sure that you use exact same code, otherwise you can see some errors. Let me just say display as well. Oh, it worked because I'm just using notebooks. So this is my graph. Wow. Start, welcome node, and then end. This is actually nice. Yes. So do you know what? Sometimes it works, sometimes it doesn't work. It can throw you some errors related to some networking, and some you will say like you are not in the network or whatever. It can throw you some fishy errors. So if you see that error, okay, because I also like see that error usually. If you see that error, let me just write it. You could see the errors with the below command. You can use the below command to see graph without errors, and I'm simply using this command, print Okay, and then I think first graph, obviously, then dot get graph dot draw mermaid. Let's try this thing. I think it should work. If I run this thing, do you know what will I see? I will see a code. Remember the same code that I just pasted in my whiteboard. So what you can do, if this particular code doesn't work, okay, you can use this code. What you will get, you will not get the graph, obviously, but you will get the code behind that graph. The code, the running code behind that graph. See, this graph is nothing but rendering this code. So what you can do then now, because you just want to confirm like your DAG is running fine and you just want to visualize it, right? You can just copy everything, okay? And then you can just paste it in the Mermaid website. So simply go to any favorite browser and simply search, let's say mermaid.live, and perfect. It will maybe asking you to, you can say login. So you can just log in and see, that's how you can just see this particular your graph. So this is another way. I usually use this thing as well if I just want to, let's say, render my graph and I'm seeing some errors due to any kind of networking thing, because what that particular thing is trying to do, it is trying to render your this code immediately within this server, within your local server. Sometime it works, sometime it doesn't work, so you can just simply copy this code. And for now I'm just simply commenting it out for you so that you can just use it if this code is not working. Simple. But for now my code is working fine, so I will just use this. This is my graph. This is my graph. Simple. Now finally our graph is fine as it is, that we want. Now I will simply say that I want to invoke my graph. So now I will simply say step 5, run the graph. Now if I want to just run my graph, I will simply say, hey, wow, such a big cell. So here I will say, I want to invoke the graph, and I can just use the same dot invoke method. So I will say graph dot invoke. Okay. Why graph dot invoke? Because this is the graph that we compiled. Same keyword. Okay. Where is that? I think first graph. The one that we compiled. Okay. The one that we compiled. So I'll simply say first graph. First graph dot invoke. Now while invoking, we have to make sure that we are following the schema. What is the schema? The schema is, the first thing is name. Let's say my name is Ansh. What is, let's say my name is Ansh. And then message. Message is, how are you? Let's say I'm being nice, so I'm simply asking you, how are you? This is my message. Now I want to invoke it. Now you will see the graph response. Now it will be just simply executing your graph, and perfect. What do I see now? Do I see a random message generated by AI? No. I see the response in the form of schema that I have defined. This is the power of stateful orchestration. So I can see name, Ansh, message, you message was you message, your message, you message. Okay. Your message. Okay. So it is saying your message was, how are you? Here is my response. Hi Ansh, nice to meet you. I am here to ready to help you whatever you need. I don't need any help. So this is your AI's response, but through LangGraph. Now you are not seeing any random messages. Now you are not seeing any random responses. Now you are seeing response in the exact schema that you created. LangChain was not obeying the schema that we wanted, because see, let's say you are building the downstream dependencies, right? And you know, whenever you just build the downstream dependencies, you need to make sure the response that you're generating is actually following the exact schema, or basically exact state, right? So now it will follow the exact state and exact schema because of our LangGraph. First of all, because of LangGraph, because second thing is we are manually updating the state. See, we are updating this thing. LLM is not taking, or you can say interfering in our thing. Here I am updating my own key. I am the owner of my key, right? I am generating the response for sure, but I am manually filling this key. I am manually putting the data in this key. That's the power of stateful orchestration. And with the help of this state, now you'll be like very excited. Let's say I just want to change this name. Let's say I want to use schema. What will happen if we just do this? Let's say run all. Let's see what will happen. Obviously I just need to change this as well. Let's say schema, schema and schema, schema. Perfect. So let me just interrupt it, and let me just interrupting LangGraph. Yeah, interrupt it right now. Whenever I just interrupt, it takes so long, and then I have to just, let me now just say run all. Now let's see what will happen. Let's see if it will just render my graph, or let's see what it will return in return. Okay, so where it is at currently. Oh, so here it is. Second step, third step. Okay, and then fourth step. Okay, this is here. So currently it is trying to generate the graph. Let's see if it is able to generate the graph. Yes. Yes. So see, it will also work fine, obviously. So it doesn't mean that you have to use the state keyword, or basically the state variable. You can use schema as well. But usually it is a good practice, and it is a practice that is written in the documentation as well, that we should use state. Simple. But if you want to use schema, no one can stop you, because you can use it. Simple. Because you just need to define the schema variable is of this type, and that's it. This is important. Make sense? So this is all about your very first graph, and I can also rename it, let's say first graph. And if you have understood this concept, whatever we have discussed in this particular first graph, I can say that you can easily build the graphs now, because I know we'll be covering some amazing complex scenarios, but now those complex scenarios are like easy to understand. This is the base. If you haven't understood completely so far, I would encourage you to rewatch this section again and again until you understand everything. Everything means everything. Okay, and congratulations, you have built this graph on your own. Simple. Greet, welcome, whatever. Let's say welcome. Simple. Very well done. And now let's build our second graph, third graph, and we'll be using multi-variables graph. Okay, conditional graph, all of those things. Let's see. So now let's talk about some not advanced, like one step ahead, how we can just make sure that our schema will not break. And first of all, I want to create a dedicated folder for it. Let's say notebooks, and let me just move my notebook here, because it doesn't look good when we just open this one. Okay, this is fine. So I have created this folder notebooks, and I will be just creating all of my notebooks within this folder. Now I want to create my second notebook, and this second notebook is all about Pydantic. If you are not aware about Pydantic, personally, I love Pydantic. Pydantic is a kind of data parsing and data validation library in Python, with the help of which we can make sure that the schema, the data, the state, the key value pairs we are passing is absolutely correct. So Ansh, Lamba, a quick question. If we use this one, which is our this schema, so you are saying that we can work with this schema, but it will not guarantee that it will just follow the schema exactly. This is a lightweight schema. This is just for type hinting, and that's it. This is not like actually the schema that can break the things, and that should break the things. Pydantic is that particular library that allows you to just add strict rules on top of your data, on top of your orchestration. And if you are building some APIs on top of LangGraph solutions, and obviously you will, because that's why you're learning LangGraph, then Pydantic is like amazing library. It is very similar to data class library, but why no one is talking about data class library nowadays? Because Pydantic is much more than that, and Pydantic is actually amazing. Okay, and obviously this is not a Pydantic class, by the way, but if you want to learn about Pydantic, I have a different video on, I think, advanced Python. Let me show you, because I just covered that particular concept. If you just go to any search on any browser, simply search, let's say advanced Python, and then just type Ansh Lamba, you will find a video or advanced Python, because I have two videos on Python. One is for like basics, second one is for like Python for AI engineering and senior level thing. So this is the video. This is like 4 hours course. In this particular video, just go to description or chapters, you will find one dedicated chapter on Pydantic. So you can learn Pydantic in detail if you want to, right? So here you are directly using Pydantic, and if you have some understanding about Pydantic, it's fine. If you don't have, you can, if you want to, like, you can learn, it will be better for you. If you do not want to learn in detail, it's your choice, because it's your life, it's your career. I cannot say anything, but it's good for you. It's my just a kind of suggestion. Now you are the owner who will take the suggestion or not, right? Simple. Now, and I'm not saying like you just need to follow my video, not really. You can just learn Pydantic from anywhere from the official documentation. It will be beneficial for you, especially in the AI data engineering, AI engineering, this kind of modern domains. Okay, so now let's talk about Pydantic. Let's say I want to build the similar notebook like this, right? So do you know what will I do? I will simply, first of all, copy this cell, which is like boilerplate code. So I will write it here, and let me just close the terminal as well. So this is my, you can say code cell. Okay, let me just run it. And this is the environment I want to pick. And after this, I will make sure that my model is up and running. So I will simply run this thing here. Okay, connecting to kernel, blah, blah, blah. So let me just restart this VS Code, because I just paused it in the middle. So maybe it is like stuck. So let me just restart it. So I have restarted it. Let me just rerun this cell. Perfect. It should now run fine. Perfect. So if you just see these kinds of issues with your ID, simply restart the ID. Pro tip. So let me just run this one. Perfect. So now what we are just trying to build here, we will be working with Pydantic. Simple. Pydantic graph. So now the graph will be a little bit, you can say, advanced, kind of advanced, or you can say a kind of extended. So what you will build right now, you will, the same developer will build a graph like this. So first of all, you will build, let's say, start, welcome, and whatever. But instead of just building this simple graph, now let's actually level up, because now your fundamentals are clear. So now you can just actually build some amazing things. So after starting, you can say the graph, I want to create here LLM, right? And here you can simply ask a question. Let's say LLM query. So you will query the LLM. Simple. Then what you can do, what is this arrow? Now what you can do, you can simply add one more node. And do you know what? Or let's say, let's make it like a more real time thing. So I will simply say generate post. So this is a kind of node that I want to create to generate my post, my social media post, my LinkedIn post, anything. Simple, on the basis of a topic. Simple. Now once it creates this post content, okay, this content, then I want to, you can say, tune it. In what sense? In what sense? Like, I want to, let's say, set a tone for this particular thing, or you can say a kind of evaluator to make it more, you can say, human style readable, and all of those things, right? Now you will say, Ansh, Lamba, you can just pass on all the format things and all the details in this node, why you want to create a different one. First of all, because we want to create multi-node architecture. Second, usually we do not pass all the things to a single node. It's not a good practice. You should always divide the work that you want to get it done from the LLM in small chunks, because it performs that task better when you just provide only one task at a time. Very small task. So this will be like generate post, and this will be like fine tuning, or let's say fine tune post. Simple. And then I want my response back. Simple. A kind of more real-time graph, and it will be like actually good. And this will be powered by Pydantic, because Pydantic will take care of the schema instead of TypeDict. Simple. So Pydantic is the hero here, and Pydantic will build the schema. Okay, very good. Now let's try to build our schema. So I will simply go to my Pydantic. So here I will say Pydantic schema. Simple. So now in order to you can say define the Pydantic schema, you need to import one package similar to typedict, and we call it as base model. Base model is basically a class available in the Pydantic. So I will say from Pydantic import base model, and I can also import field, because with Pydantic we can literally set some rules. Let's say I do not want any kind of null values. I want values within this range only. I want only these set of values. So we can actually perform so many things. Obviously, we are not covering all of these things in detail because that will be a Pydantic masterclass. But yeah, you should know about Pydantic. But for this LangGraph, we just need very basic understanding. So I will create a class similar to it. Let's say graph schema. Okay, and I will import base model. Simple. Now similar to typedict, I need to write my columns, or you can say keys that I want. I want first of all topic, like on which topic I want to generate the post, right? You can say equals like string. So in Pydantic, we also get amazing option called field, in which we can just define some description and all. Simple. And it is very handy when you are just passing on this information to LLM, right? Because more information you pass to LLM, better it will perform. So topic, okay, and here I will say post, okay, post, and this is obviously string, and this will be field description. Let me just change it, the LinkedIn post content, and I will create one more key which is called curated post, because I do not want to simply update the existing post that my LLM node 1 will create. I want to store this updated information in the curated post. Simple. Okay, string equals to field and description curated LinkedIn post content. Perfect. Simple. And I don't want hashtag, so it's fine. Simple. So this is my class. Now this has become my Pydantic model. Let me just show you how you can parse this object. Let's say I want to create an object for this particular class. So what I will do, and this is just a demo, so I will simply say demo object equals graph schema, and I can pass on some values, for example topic, and then I can say post, and then I can say curated post, like this. Simple. This is a very, you can say, hypothetical situation. So this is my thing. Now what is wrong? I think double quotes. Okay, perfect. So this is my object. Now do you know what? Let me just parse this thing and you will see that it will work fine. Why? Because I am following all of the rules. Topic key is there, post is there, curated post is there. Perfect. Let me just run this and let me just show you print demo object. Okay, so you will see everything. Topic equals to this and curated post equals to this. So everything is fine. Now if I make any mess here in this particular schema, let's say I just by mistake you can say wrongly spell this. Let me just, let's say, write like this, curated like this. Okay, do you know what will happen? It will fail. It will say one validation error for graph schema. So you cannot just simply pass this value. And this is very important. Let's say you are invoking the schema through an external API, and if that API does not follow all of these key pairs, it will not work. Okay, makes sense. Makes sense. Very good. So we know that it works fine. So now let's try to create the functions for nodes. So I will quickly create the node functions. I will say def, and this will be like create post. Okay, create post, and I want to get the state. State is this one, and what is the schema of state? Graph schema. Perfect. And it returns the graph schema. Perfect. Here I will first of all get the state of it, like topic, because I need topic to send it to LLM, right? So I will simply say topic equals to state dot topic. Now this is very interesting. Now you will say, Ansh, Lamba, in first example we treated our state as a dictionary. See, but here you are using dot notation because this is a Pydantic object. Make sense? And Pydantic object we use or we fetch the information with dot notation. If you want to treat it like a dictionary, that I personally like as well, because I don't like this dot notation. You can convert your Pydantic object into a dictionary, into a JSON using this one. Let's say state equals state dot model dump. So this is a function that converts your Pydantic object into a dictionary. Now you can just use this thing. Simple. I can say converting Pydantic model to a dictionary. Perfect. AI is here. So topic, we have got the topic. So I can say extract the topic from the state. Now you already know. I will simply say passing the topic to LLM to generate a LinkedIn post. Simple. So LLM.invoke, write a LinkedIn post about topic.content. Very good. Very, very, very good. So that's how you can just make sure that you are just passing on these things. Simple. So this is my post. Okay. And now I can just update the post. So update the state with the generated post. State of post is equals to post, and return the state. Return the state. Simple. So this node is done. Let me just create another function. Let me just create another function which is curate post. Simple. So here what I need to get, I simply need to first of all convert the state into model dump so that I can just convert it into a dictionary. Simple. And then I will extract the post from the state using post, and then I will pass this thing to LLM, and I will simply say, hey, curate the following LinkedIn post, and that's it. Or I can say curate the following LinkedIn post with Gen Z tone, something like this, right? So now simple, I can simply update the state and return state. Simple. My two node functions are done. Simple. I hope it was easy, because we have already covered these fundamentals and this is very, very easy. Perfect. So now what I need to do, I simply need to create my graph. And how I can just create the graph? Let's say graph equals, here you will first of all import the state graph from LangGraph dot graph, import graph, I think state graph. Perfect. State graph, start, end. Perfect. So here I will say graph equals to state graph. Perfect. And here you can just pass your schema of the state graph. I will say graph schema. Perfect. And then you can say graph dot add node, which is this one. And then I will not add edge, by the way. I prefer creating first of all nodes, and then I just create the edges. So I'll simply say add node. Let me just register the nodes. So this is my first node and this is my second node. Perfect. And my other two nodes are already created by the LangGraph. Perfect. So now let me just create the edges. So this is my first edge. This is my second edge. From curate post node to create post node to curate post. Simple, self-explanatory, very good. Then my last edge is this one. Now let's try to compile it. Okay. So I will say graph, or you can say Pydantic graph equals graph.compile. Simple. And I also want to display that amazing graph. So let's do it. Let me just import it here. Yeah, let's write it here. Okay, so are you ready to run this? Very good. Create post is not defined because we didn't run this. Perfect. Now let's run this. So let's see, what do we get? Perfect. Start, create post, curate post, and end. This is your graph. Very good. Now we need to invoke the graph just to test it. So I will simply say graph, or you can say Pydantic graph dot invoke. Now this step is very important because now you need to pass the schema. And what is the schema? First of all, topic. Topic is, let's say, importance of digital age in this thing, right? Now you know that you do not have any kind of other key. You do not have, let's say, post, right? Obviously you do not have, so you will keep it empty. Simple. And you have, let's say, curated post, and you will keep it empty. Simple, simple. Now let's try to run this. One validation error for graph schema. Why? Let me show you. So it is saying validation error for this curate post because I made a mistake. What is curate post? Pydantic does not understand anything. That's why I just made this mistake. It is not curate post. It is curated post, right? So that is the importance of Pydantic. Make sense? And you wouldn't see this error in TypeDict. Really? Yeah, you wouldn't see this thing. So when you want to make your graph work with strict rules, and in the real world we have to make strict rules, then yes, you have to use Pydantic. So it will take some time. Okay, let's wait. Okay, see, we have got the things: topic, post, and curated post. Simple. And this is the magic. This is the magic. Now it's Lamba. A quick question. Yeah, I know what is your question. What if I just pass topic and I do not pass these things? What will happen? Because I do not have any kind of information. So just keeping it null or empty. What if I just pass this? What will happen? You already know. It will not accept it. It will say, I have to keep those, you can say, keys. Make sense? So it will simply say, you need to pass those keys as well. So yes, you can just keep it empty, which is a very normal practice, but you have to pass the schema. It will only check the schema. Simple. So now let me just tell you very important topic, which will like actually enhance your understanding about how graph is working under the hood. Okay, and this is very important. Let me just talk about it. Let's wait for this response. Let's see what it will write this time. Bro, you are taking so much of time. Let me just show you directly. So now if I go to, let's say, my functions, see here. So these are my two functions. Here, let's say this is node 1, this is node 2. Let me just draw it. So let's say generate post. Simple. This is my generate post. Let's say generate post, and then I have fine tune post, or let's say curated post. Let's say, yeah, let's keep it because we know like we have used the different names, so it's fine. So let's say like this. Perfect. Do you know what? Never ever think that output of this node will be treated as the input of this node. Never. Because this is a very common practice when we work with LangChain. It's making so much of noise. Right, now it's good. So yeah, never ever think that the output of this node will be the input of this node. Never. LangChain works on this particular principle when the output of one, there we do not have nodes, but let's say one function is the input of the second one. Why? Because we do not have the stateful orchestration. That is the biggest advantage. So I can say in LangChain, the output of one node is the input of the next node, but in LangGraph the input, or you can say in LangGraph it's not the case. So how our next node is using the content which is updated by this node, let me just tell you. So what will happen? Let's say I am executing this node. Okay, so there is a special area where we store the state, right? So this area is called state schema that we create. State schema. So now when I will execute this node, or not I, like let's say LangGraph is executing this node, it will execute the node It will make the changes in the schema dictionary and it will save that information here. Okay, here. Now, when this node will be running, the input of this node is the state schema, not the output of this function. So this will utilize this schema automatically. Simple. Simple. So output of this is not the input of this node. This will just update the state schema, and state schema will automatically go inside this particular node, or I can say node 1, just for the understanding, for generic understanding. Let's say node 2. Make sense? So this output will not be the input of this thing. So they are simply using the state schema. Wow. And what if, let's say I have another node? Same thing. So what will happen here? You will be having state schema like this. So now this will update the information in the state schema. Let's say like this. Okay. And this is, let's say, node 3. And this will write it here. Oh, yes, that's how it works. Simple. So node 3 will automatically pick the information from here. Okay. So they never share the output and input with each other. They always share the state schema. State schema. I hope it makes sense and I hope it is clear. This specifically. Simple. Just make sure this is like the backbone of the understanding of the nodes. And this is the biggest advantage over LangChain when we just work with LangGraph. Make sense? Okay. Very well done. So now let's talk about a concept called messages. So whenever we just chat with the LLM, most of the time we deal in the messages, and you have already seen one type of message which is called AI message. When we just made the API call, you saw that, right? The messages. So now let me just share an important concept with you, which is called messages. We do not have just like one type of messages. We do not have just like AI messages. We have so many other types of messages as well. For example, first of all, we have, let's say, something called as AI message. Let's start with this one. AI message. We have this thing. Simple. AI message. AI message means the response that we get from the AI. What is AI here? LLM. Simple. Very good. Now, one more thing which is called human message. Human message. Now, human message. What is this thing, human message? Human message means the information that you provide in the form of query. Information or question that I provide in the form of query. Make sense? So that means whenever I am asking anything from LLM, whenever I am saying that, hey, I want to know this thing, that is my message because I am messaging, right? That is the human message. Perfect. There is one type of message which is very popular. System message. Now, what is the system message? This is called very, very, very high level fine tuning of LLM. Not really fine tuning, but setting the tone of the LLM. So let's say I am talking to the LLM. By default, LLM's tone is like by default, like which is set in the background. Now you can set the tone, you can set the behavior, you can just give some directions to your LLM that, hey, you are a professional content writer. Hey, you are a professional, you can say blog writer. You are a something like this. You are this, you are that. You can provide this information. What will be the benefit of it? It's not magic that LLM will become the content writer or you can say blog writer, but LLM will take this, or you can say consider this every time whenever it will be generating the response. So we can give the high level guidance towards the LLM. Okay, simple. Okay, there is one more type of message which is called tool message. So let's say you want to just create tools and you want to integrate tools, and we'll be just learning about how to create tools in LangGraph. So you can create tool, and the response that you will be getting from the tool will be the tool message. Here in LangGraph, we create functions for tools, right? So you can also consider it as function message or tool message. Simple. So these are like four major ones, and yeah, these are the four major ones that you just need to know. Okay, so let me just make a single line for all of these messages. Simple. Very good. So these are four different types of messages that we have. Now let's see what is the advantage of it. See, the example that we have just built like is actually very useful, but now we'll be just learning about some advanced things. Okay, because whenever we work with LangGraph, we want to keep the, you can say, conversation continued. We want to make sure that we are providing all the context to the future nodes. For example, let's say, let me just draw the graph for you. So let's say you have to build messages graph. What do I mean? So let's say you are a user. Okay, let's say you are this user. Perfect. So now what you will do, you will use this thing, let's say OpenAI, right? Perfect. So now here, let's say this is your one node. Okay, node number one. Now I have the schema, let's say, called messages, right? I have the schema called messages. So my messages will be like this, right? Let's say something. Okay, let's say message one. Simple. Very good. Message one. Okay, this is the initial schema. Or let's say, let me just expand the schema. Let's say we have this thing as well. Let's say input. Simple. Let's say input. So it will be your user query. Okay, makes sense. So this is my schema. So here, when I will start my application, here the messages will be empty, obviously, because messages is the AI message, right? And when this will process this node, this will populate this message. Make sense? But now when I will be going to my next node, okay, when I'll be just going to my next node, then if I take this input and I just, you can say, change it. Simple. Let's say this is changed, then obviously this will become my message 2, right? But where is my message 1? I want to access message 1 as well. Make sense, right? I want to access my message 1 as well. So in that particular scenario, I need to make sure that I am not simply overwriting it. I am doing like this, message 1 plus message 2, so that I can see the message 1 as well and message 2 as well. Now you can do it manually as well. It's not rocket science, but LangGraph has built-in features available, built-in operators available that you can use within your LangGraph code, so that you do not need to manually handle this thing. Simple. Let me show you how you can just do that. So now here what I will do, I will simply write the code for our messages. Okay, so now what we need to do, achieve, first of all, I need to just copy this boilerplate code. Perfect. Okay, so let's run this one first of all, and let me just run this code. So now I will also explain you one very small concept, but this will just strengthen your understanding of how to work with LangGraph more efficiently. So as you can see that I have created this LLM, right? And I can just invoke this LLM like this, like this. We have just learned about the messages, right? And I know that this is human message. Why? Because I wrote this thing. How LLM know? How does LLM know that this is a human message? Do you know how? LangChain is actually doing so much of work, or basically LangGraph is doing so much of work for you under the hood. When you write this thing, LangGraph will automatically convert this code into like this. Let's say, first of all, let me just bring the messages from, I will need to check the class for it, for messages. Let me just grab the class for you for messages. Oh, yeah, LangChain core. Okay. LangChain core dot messages, import system message, human message, but we just need human message, so it's good. So now do you know what it will do? It will simply use human message, like it will wrap it inside human message, and then it will write content equals to this. Okay, you do not need to do this thing because it is already doing this thing under the hood. But when you'll be just building the LangGraph application, you need to know this thing, otherwise you cannot work with messages. Okay, so if I run this thing now, it will generate the same response. Wow, what is wrong here? Must be a prompt. What did we just do? Okay, human message. I think we just need to add a list here, because it always takes the list of messages. So let me just write like this. It should, yeah, now it is running, so it should work fine now. So now we will get the same response. Why? Because I am passing the human message explicitly by myself. And always remember, we need to just pass the list. Okay, so now what will happen? It will recognize that this is a human message, but even when I do not write this, it automatically takes that input in the string format, and it will automatically convert it. Simple, very good. You need to remember this thing because it is the backbone of this current execution. So what I will do now, I will define my schema, right? Let's define the schema. Now, if you want to define the schema, do you know what I will do? I will create two keys. Okay, let me just show you here. I will create two keys, and I will not create input key because input key we already know, like we do not need to create input key. Why? Because I want to make it more complex. I want you to learn. So I will say messages, and then it will be like, let's say manual. Okay, you can say messages 1, messages 2, or let's say messages manual, but for the explanation I can simply keep messages. Okay, but in the practical you will just use two keys. So here what I will do, in the messages tab, I will write that human message, you can say messages is equivalent to human message and something. Okay, and something simple. This is my human message, and you already know that we need to pass this, right? So this will become my schema, initial schema. Okay, this is my initial schema. Now this same schema will be pass on here. Let's use this one, simple. And this same schema will be having one more message. Just guess it. What is that? It is now having one more item in the, you can say, list. The second message will be AI message. Okay, AI message. Perfect. And it will write something. Perfect. Now this will be the current state of the graph. Then this will go to the third node, and this third node will simply append its response as well, like this. AI message, simple, something. Okay, this is the flow. This is the flow. I hope you make, I hope it makes sense, not you make sense. This is the flow. This is the flow. Okay, I know it's challenging, but that's how you learn. Okay, you just need to, maybe you might be just rewatching this segment of the video multiple times so that you can understand and grasp that knowledge. Simple. We also did it when we were learning. Okay, so do not feel like, why do we need to rewatch it? So let's say I want to define my schema. Okay, so I'll simply say from, and I will be using typedict. We do not want Pydantic, just for the simple example. I will say from typing import, because typedict is like pretty much fast, so that is why. From typing I will import typedict. Simple. Now what is this thing? Oh, so now I will define the schema. I will say graph schema. Simple. Very good. And the graph schema will look like this. So do you know what? I will create two keys, not one. Why? Because see, when I can perform this thing, this addition of list manually, I do not need to rely on LangGraph for that. Why? Because see, you should rely on LangGraph for the complex things, but not for the basic things. Not for the basic things. Simple. Okay, so now what I will do, I will create one messages, because see, lesser vendor login you will be having for application, less trouble you will see in future. So just my advice if you want to take it. So I will simply say messages, which is the key, and this will be the manual that I will manage by myself, because I want to show you both the ways. Whatever you like, take it. So I will simply say message manual, and the type of this will be list, and let me just import list. Simple. And there is one more, okay, one more message, or you can say one more, you can say type that I will be just using, messages auto, because this is like managed by kind of LangGraph. Okay, kind of, not by LangGraph, but this is like automated way, not like traditional way of doing it. Okay, so let me show you that as well. So you simply need to say annotated. Let me just bring annotated as well. Annotated, and I want to import one more operator. From operator import add. Okay, so I'll simply say annotated, and then I will simply say list. Okay, list, and then add. So what does it mean? It means that I will be creating this messages key, and in this messages key I will be adding list, obviously because this is a list type, but I will also add more list into it. More list. Make sense? So let's say I want to do anything with this list, it will keep on adding those lists, and don't worry, you will actually understand it. It's very easy. I like both the ways, but I like manual way better, because it promotes readability, it eliminates vendor lock-in, it shows you what you are doing with your application. You need to see it, right? So this is the class. I have defined the schema. Perfect. Let's try to build the two nodes. So I will simply say, and let's use the previous nodes. Why to waste time here? So I will simply use these two nodes that we created here, right? Perfect. But obviously we need to make some changes. So now, first of all, we need to make a major change in the code. Perfect. Let me just remove everything, and let me just remove everything. Perfect. Simple. So let's talk about this curate post. Now in this curate post, I want to access what? Messages manual and messages auto, both, obviously, right? But under the hood, both are same thing, right? Okay, so now what I will do, I will simply take the message, let's say messages manual equals to this, messages auto equals to this. Now I will send these two messages to my LLM. Okay, these two messages to my LLM. And let me do one thing, because you will be very confused. Let me just comment it out the automated way. Let's use this first, like messages. Okay, let's learn step by step, because it will be very confusing for you. I know this. So let's say we have messages manual. Yeah, let's talk about it. So we have messages key, and in this messages key, I am storing only and only the human message. Simple. And it will be like this, in this form. Simple. So what I need to do, I simply need to send this entire list, right? This entire list to my LLM. Perfect. So let me just store the response. Let me just say response manual equals LLM.invoke and messages manual. Now I do not need to get the content. I need to get the whole response. Why? Let me just show you that as well. If I just remove this dot content, you will see the message in the form of AI message. And this time I want that. Make sense? I want that. See, AI message content, do you mean this? I want this thing. Because this is a distinguisher between my message and AI message. And when I have a list of messages, I need that distinguisher that will tell, hey, this is your message, this is that message, this is your message, this is that message. But here comes the ideology of, you can say, businessman. So now the person will say, okay, I know that this distinguisher is very important, but why do I need to spend more tokens? Because after the content, why do I need to send this information to my LLM? What is the use of it? I do not need to spend my tokens on this information, and there are so many tokens will be wasted on this particular information. Makes sense. You are absolutely right. So I am not denying on that fact. Okay. And I know your money is very, very precious. So what we can do, we can smartly play around with it. So what I will do, I will simply fetch the content like this. Okay. So I will simply fetch the content like this. Let's say dot content. But what I will do now, I will simply say response manual AI equals, I will wrap the content of the AI message into AI message object. Okay. So let me just import the AI message from LangChain core.messages, import AI message. Simple. Now I will play smart. I will simply say AI message and content equals to response manual. Boom. Now this has become the AI message object and we do not have any kind of metadata. So our tokens will not be wasted. And in this particular era, we have to save the tokens as much as we can. So this is my response. Simple. Now what we need to do? The major thing. Now we need to append this information in our list. Now there are two ways. You would have like learned about the append function in list. You can simply say state of messages manual.append, which is like coming on the screen right now as well. You can either use this, which is a very basic one, or you can, what you can do, you can simply say state of messages manual, okay, equals messages manual, okay, the previous one, okay, like this. So I know this is a list. Obviously this is a list, right? We have defined the schema. See, this is a list and I can add the new list, which is this one. This is a more professional way to write this thing, but both the methods are correct. You can just use any method. Simple. So what I have done, I have added two lists, one and second. First is already a list, so I do not need to use the square brackets. Response manual AI is not a list, it's just a response. So that's why I have to use these square brackets. Now I am simply combining both lists to create one complete list. Simple. These are very fundamental things of Python. I'm just explaining this thing in very much detail. So, so this is your state, right? So this has become this particular thing. Now what will happen? This information will go to the second node, curate post. Simple. So now what you need to do? You need to first of all fetch the current state of messages manual. Simple. Now this current state is having both the information, my message, human message, and AI message as well. Really, yes, it has both the information. Okay. So now what I will do, I will make the API call. Okay, response manual equals to this, and do the same thing that I have done here. And I will simply append or basically add this third response into the list. Perfect. That's everything you need to do. Yes, that's everything you need to do. That's it. Now we will simply copy and paste the code from here just to create the graph, because all the node names, edges name are same, right? So I can simply paste it here and I can simply show you the result. Create post is not defined because we didn't run this function. Perfect. Now let's run this. Perfect. Our graph is ready. Now let me just show you the invocation, which is the major part. Now do you know what? We do not invoke it like normally. Now we have to invoke our graph, which is graph, Pydantic graph. And let me just rename it. Why to call it as Pydantic graph? Let's say messages graph. Okay. messages graph. Perfect. So I will simply say messages graph dot invoke. Now while invoking it, I have to pass the list of message. So I will pass my schema like this: message is manual, human message, content equals to whatever you want to pass. This time you cannot just pass any kind of, you can say, text. You can pass text because it will perform all of the things behind the scenes. You can, but my recommendation will be simply pass the list. It promotes readability. Simple. Very good. Let's see the response. Wow. Dict object has no attribute model dump. Oh yeah, because we are not using Pydantic, so that's why it is saying why are you using model dump. Okay, let me just remove it. No worries, it will make our code more simpler. Let me just remove it. Perfect. So let me just run it for one more time and let's see the response. This time you will see the messages key will have a list of all the messages. Entire history of the messages is there. Entire history. Just wait. Just wait. And this is the advantage of using LangGraph. Storing entire history. Simple. Okay, so now our response is ready. And as you can see, human message, AI message, and AI message. Wow. This is amazing. As you can see, this is the key. And here we have a list of messages. Literally the list of messages. See? That's how you can just perform this thing. Make sense? You can also like use a pretty print. Okay. Just to using pretty print to display the messages in more readable format. So there's a module called import p print. Okay. And now let me just invoke it for one more time using this method. So here you will see the output in much more readable format. It is also readable, but it's not that much readable. So what it will do, it will simply print the message one by one. Okay, it's called pretty print. Very similar to pretty print in JSON. So that's how we can just optimize it. So let's wait for it to return the result. But now you can see the intent behind like what exactly we are trying to do, right? We are storing the entire history of our chat in the, what is this, man? It has not applied the pretty print. Oh, because it has simply performed the pretty print only on the JSON format, but not on the list. Okay, that's fine. We can just use stream method as well to do that. But I don't want to include unnecessary keywords right now. You will be confused. So let's stick with the basic one. Let's learn step by step. So this is the entire history, right? See, now I can see the first message, my message. Now I can see the node's message, which is node 1. And I can also see the second node message in exactly same thing that we have discussed here. See? Wow. Now I will just show you the built-in method as well. Built-in method is called reducers. Built-in method is called reducer. Reducer in Python is just like when you want to reduce the list, when you have like multiple lists and you can just combine it automatically. So if I just uncomment this thing now, okay, now I will perform the same thing here as well for my messages auto. So I will simply say, let me first of all run this. Perfect. And it will become my messages auto. Messages auto. And this is the, you can say, fetching the details. And then same thing will happen. Response auto. Response auto equals to this one. Okay. And we want to do this. Now the only change is here we are manually adding this thing. But here we do not need to manually add this. I simply need to say state of messages auto equals to response auto AI, and that is it. Wow, like we do not even need to perform plus and all. No, do you know what will happen? This will not replace the list with this one, because we have studied the fundamentals of LangGraph, that whatever we write here, it simply overwrites it, it simply updates it. But here when we use reducer, like this reducer, let me just like using reducer in LangGraph, then it will not update it. It will simply automatically add this list into the existing message key. Wow. Yes, it is wow, but I am not a big fan of it because it reduces the readability, because you can be confused, hey, I am updating the one or I am simply adding the one. It promotes readability. It promotes readability. It says, okay, we are simply updating the key, which is the fundamental thing, and we are updating it with the previous message and this new list. So everyone has its own way of writing the code. I like manual thing. You can just use the automated way. I have just showed both the ways. Second, it's all about reducers as well. You also need to know the reducers in LangGraph. Now you know the reducers as well. So I can do the same thing here as well, right? Let's say like this. Simple. Now if I say run all, now what should I see? I should see two keys. Okay, one is manual, one is automated. But now you know what exactly we are trying to do. So I like this particular method. Oh, I need to pass this thing. Okay, this will, I think. So see, there's a like very good you can say test as well for type dict. Here I have not passed the second key. Okay, I have not passed the second key, but still it will throw the error even if it is not Pydantic. Why? Because this is not due to the schema failure, not at all. It is due to because the subsequent nodes are using that particular key. So it will simply say, hey, this is empty. Makes sense? So I can simply say the messages auto is this one. Simple. Let me just now run this thing. Okay. So now you will see two things, and now it's like very, very easy. So that's how you work with reducers in LangGraph, in your state graph, whatever you want to say. Make sense? Okay. So now we'll be learning about a very quick and very important topic, which is prompts. And let's wait for a few more seconds just to complete it. It took 30 seconds. So wow, man. Usually they do not take this long. Let me be honest. Okay. So I don't know like why today it is taking so long. Maybe the model is not good enough. I can use some other models as well. Or maybe their servers are down, because we all know what's going on with OpenAI. But this is a paid model, okay? This is not a free model. So, oh man, it's over 1 minute. Are you serious? Are you serious? Yeah, it is what it is. Yeah, but we know like what will be the output of it, and I can just show you the output. Yeah, it's done finally. So both will have the same output. Nothing surprising here. But yeah, you know, both will just generate, you can say, the same thing. But here the thing is, one is manual way, second is automated way. But now you know both the ways. Simple. Very good. Now let's talk about the concept called prompts. What are prompts? If you are coming from LangChain, you already know about prompts. If you are new in the world of LangChain, or if you haven't worked with prompts, let me just tell you. So whenever we want to pass anything to LLM, let's say this is you and you want to pass anything to the LLM. Usually, just for the quick prototyping, you directly pass the input like this, right? Directly input. Hey, what is this? What is that? Blah, blah, blah. But it is always a good practice that we always pass the prompt. Okay. We always pass the prompt. And we use the chat prompt template to pass the prompts to our chat models. Okay. Prompts are basically, you can say, templates which are already there for us that we can just use, and we can fill our values. What is the benefit of it? No benefit. Then why are we learning? See, no benefit in terms of processing, no benefit in terms of, you can say, speed, efficiency, but a lot of benefits in terms of, you can say, building reliable code. Make sense? You should always pass the prompt to the LLM. Okay, so let me just write here. It should always be a prompt. And where is my prompt? Do I have any prompt? Let's say this is a prompt. No, this is not a prompt. Let's say this is a prompt. Okay. this is a prompt. You should always pass a prompt. Now let me just show you the chat prompt template library in LangChain, because templates, prompts, messages are all the part of LangChain library, but we just imported in LangGraph because LangGraph people are not very free to rebuild the same stuff in LangGraph. So they simply say import it. Simple. So I will say chat prompt template LangChain. Simple. Let's see. So here's the class chat prompt template. Perfect. So here, this is the code about it, and you do not need to worry about code because I will explain you everything. Okay, you just need to know about this class. So this class is available in LangChain core.prompts. Okay, and then you need to import the chat prompt template, and that's it. Simple. Okay, that is it. You just need to know about this thing. Okay, and then let me just see if anything is useful here. Not really. Let me just explain you in my notebook. So let's talk about that thing. Prompts. Prompts.ipynb. So if we just talk about prompts in LangGraph. Simple. Wow. Thank you for writing it. So let me just import my boilerplate code. I could have just I can also build a utility that I can just import a kind of function, but it's fine because I want you to run independent notebooks as well without utilities. So perfect. Oops. What is this, man? What is this? Oh, I didn't select the kernel. Okay. So now this is my boilerplate code, and let me just create the LLM object as well because that is also required. Perfect. So now I want to send my information or basically the query to this LLM, but I want to make the use of prompt, right? So how you can just use it? So you can simply copy it. First of all, the class that we copied here, and here I will just paste it. LangChain core.prompts import chat prompt template. Let me check if it works fine. Yes. So now what you need to do, you will simply say my prompt, simple, my prompt equals to chat prompt template dot from messages. Okay, now here you need to write a list. Okay, a list of all the types of message, and here you will use system message as well. So you will use system, and then you will type something like, say, you are a helpful assistant that helps to create social media platform posts. So you have simply guided the LLM that who are you. See, like who are you means who is LLM. Okay, then I will paste my message that I want to do. So I can just either use human or user, both are right. So I will use user or human. Okay, both works. And here I can simply say I want to do this. Simple. This is my prompt. And what is this red thing? Let me just run it. Let's see the error. I use the colon. I need to use comma with tuple. We cannot use colon. So this is my prompt. And what is the value of it? Let me just show you. If I just print my prompt, and if I just print it, you will see this is a kind of chat prompt template which has some information. See, messages equals to system message prompt template, prompt equals to this, and so many other things. Wow. Do you know what? Now let me show the real power of prompt. Prompt is actually used for making your code reusable. Let's say here the request is dynamic. Here the person is saying, I want to create a post about, and the person is also typing the value of it, right? Let's say this topic is dynamic. I can simply say topic. Simple. Now, this is a dynamic template because there's a reason behind the name. We call it as a template. Template means like you can use it with anything. So let's say I am building one application and I have this particular template. Simple. Very good. So now I have this topic, right? Now this topic is dynamic. Now what I will do, I can pass the values during invocation of this template. I will simply say my prompt dot invoke and I will say topic. I can pass the topic like this. Wow. Now if I show you the result, you will see the value. You are a helpful assistant that helps to create, this is the system message, and let's go towards right. It will say I want to create a post about, and it has automatically filled this information using this invoke method. Wow. See, automatically. Okay. And when you pass this information to LLM, it can automatically process this information. Why? Because just look at the object carefully, what it is just typing. See, chat prompt template, the chat prompt value, this is fine, but messages equals to system message. Is it similar to the thing that we have just seen here? See? See? Oh yeah. So it performs, this chat prompt template performs the same thing under the hood. So you simply need to use this syntax to automatically convert this thing into this thing dynamically, because you can just pass the values during the invocation. Simple. This is very useful. Just remember it. Make sense? Okay. Now we will just simply learn one basic thing of LangChain as well. Okay. So this is my prompt. Let me just save this response into a variable. Let's say prompt invoked, or basically you can say filled. Okay. Prompt filled equals to this thing. Let's say this was filled. Okay. Let me just run this now. Perfect. Now I want to pass this value, this prompt, to my LLM, right? How do I do it? Like, how do I need to do it? So now I can just do LLM dot invoke, and then I will simply say prompt filled, right? And I can invoke it. Let's wait. And it will simply invoke it, and it will simply generate the response. And do you know what? It will automatically parse this information. Yes. So we have got the response. And one more thing, this model is taking a lot of time, and let me just change the model. Let me just use 4.1 mini or 4.1. So, oh, this is expensive. Let's use, let's say 4.0 mini or 4.1. Let's say 4.0 transcribe. 4.0 I think was fast, and what it was, no, it was not cheap. Let me just find the quick model. So let's use this model 5 mini, and I hope this will be like much faster. Let's use this one, GPT 5 mini. Okay, so let's run this and let's see the response. LLM.invoke, prompt filled, and let's see. Not really, it is also the same. OpenAI, what happened? What happened, bro? So now this is the message. Now you would have seen that I am invoking the same, not same thing, like two different things independently. But here comes the role of chains in LangChain. Okay, so what you can do, you can literally create a chain of these two objects. Let me just tell you how. Let me just remove both the cells. Okay, perfect. So one object is LLM, which is there, which I need to invoke. Second object is this one, my prompt, which I need to invoke, right? Now I can create a chain. This is called LangChain. So I will simply say chain chain of thought, chain with prompt. Simple. Now I will create a chain. Do you know how to create a chain in LangChain? It's so simple. Let me show you. So let's say chain equals, I will first of all put the prompt, because I first need to invoke the prompt. I will simply write my prompt, and then I will use pipe operator like this, and then I will put the second object that I need to invoke. Now you can treat this thing as one node and second node. It's not actually a node, but just for the simplicity. And you know what? I told you the input of one thing, one node will travel to the other thing. So here the input, like output of my prompt will go or will travel to the LLM as the input. So now what I will do, I will simply create this chain and I will simply say chain dot invoke, and I will invoke this thing like this. So what will happen? What will happen? It will first of all invoke my prompt, right? And it will invoke it with this topic. Why? Because there's a variable here. Perfect. This will generate the entire filled prompt, right? Then that filled prompt will automatically be passed as a parameter while invoking this LLM. Wow. This is your LangChain. This is your LangChain. So that's how you work with prompts with LangChain. Simple. And you just need to know this much to just get continued with your future sessions of LangGraph that we are just going to take. Simple. Okay. So see, I told you, like, I will just make you understand LangChain like this, even if you have zero knowledge. Okay. So now let's see what will be the output of it. And output should be correct. Then only we can say, okay, we learned something. Okay. Makes sense. Makes sense. Now let's wait. So 15 seconds. Oh man, amazing performance of models. AI message. Okay. And here you can see the response. Perfect. That's your prompts. Let me just rename it. Prompts and chains. Simple. Just remember this thing. Now let's talk about the tool binding in LangGraph. Let's talk about it. Now let's start learning about the tools. Because nowadays we always hear about we can create tools, we can create this, we can create that. But at the end of the day, we need to make the efficient tools so that we can allow our LLM to make the external API calls. So far, we have just learned that how we can just make simple API calls, right? So for example, I ask a question which my LLM cannot answer. Not because it is not smart enough, because LLM doesn't have any kind of context, right? So for that particular thing, I need to provide that particular context. Simple. Okay. Now in LangGraph, how we can just create the tools? It's very simple. Tools are nothing but, okay, tools are nothing but your Python functions. For example, let's say I will write any kind of function. Let's say any function. Simple. Any function. Let's say this is you, and you created this function. Simple. Using exact Python function. Using exact Python function. Okay, simple. Now, what you can do, you can convert this function into a tool by just applying a wrapper. What? Applying a wrapper. This wrapper is called tool. That's it. This wrapper is called tool. So let's say this is your entire function, the real one. Simple. This is the real one. Let me just use a color. Let's say like this. So this is the function, and outside you have applied a wrapper, and it has become a tool. Let's say I will use icon for this. Do I have a special icon? Let's say this one. Let's say this one. So this is my tool now. Why? Because I have used this wrapper. Now you can ask me that, Ansh Lamba, what is the limit? What is the limit to create a function in LangGraph? I will say sky is the limit. Oh, wow, wow, wow. Very good dialogue. We are listening to this dialogue for the first time. Okay, but this is true. This is true. You can just create any tool, any function. Do you know what? You can build your Python function, and in Python function, you know that you can literally perform anything, because Python has like thousands of libraries. You can make an API call. You can literally perform anything within the tool, and you can use the tool object available in the LangChain and LangGraph, and then that tool, that function will be converted into a tool. Simple. Very simple. Let me just show you by creating one so that you can just understand. And by the way, before creating one, let me just show you the official documentation so that you can see how many tools we have available in LangChain LangGraph, which are strongly integrated, because obviously with Python you can literally do anything, right, using your own custom code. I am going to show you the well integrated code where you do not need to build everything from scratch. You just need to use the wrappers. So let me just show you. So if I go to tools and LangChain or LangGraph, whatever, go to tools. Perfect. So I am in the LangChain documentation because tools are the part of LangChain, and obviously LangGraph automatically because LangGraph is built on top of LangChain. So these are the tools. If I go to scroll down, okay, so here is the code for customize tool. Here is the customize tool where I can literally perform anything. Simple, I can literally perform anything. But if you want to use the well integrated tools, so here are the tools. Let me just show you the long list. So we have a long list. I think they have just changed the location. That's what they love always. So let me just go to the, I think, integrations. Yeah, and I can go to tools and toolkits, and here you have all the tools. See, bench search, Brave search, Chloro, DuckDuckGo search, all of these things are available. Some are free, some are paid, and some are API based, which is like totally dependent upon the server or service provider. Simple. So let's say I want to create a tool for DuckDuckGo search. Now what is this DuckDuckGo search? DuckDuckGo search is a, you can say, search engine kind of thing that you can simply search something the same way you do it in Google. So you can do it in DuckDuckGo search. Let's say you want to enable search with your LLM, you can create a tool on top of it, DuckDuckGo search. Wow, can we do that? Bro, I will just show you, don't worry at all. Okay, so we have a very long list. Tavily search, similar to DuckDuckGo search, but this is paid. But first 1,000 services, or you can say first 1,000 APIs are free every month. Tavily search is actually a very good, you can say, tool or function that we can just create. And then we have so many, like there's a long list of tools. See, all of these are well integrated tools. That's why I said like sky is the limit. And these are the well integrated ones. Forget about the custom ones, because in the custom tool you can literally create any API call, right? Simply make an API call, get the response, that will become your tool. Simple. Now let's get started with a very simple tool. Okay, so what I will do, I will simply go to DuckDuckGo search because I want to create this DuckDuckGo search tool. Simple. Okay, so how we can just create this? We first of all need to install this library DuckDuckGo search, okay, and LangChain community, because these are like community based tools. So let me first of all download it. Okay, so this is my terminal. Let's write the code here. UV add and perfect. Makes sense? Very good. So my DuckDuckGo search and LangChain community are downloaded. Let me just create a new script. It's called tools and binding. You will learn the binding as well. Perfect. So now I want to create a tool, and first of all let me just enable the boilerplate code. Make sense? Okay, perfect. And then LLM. Here we do not need to invoke it, so let's simply create it. Perfect. Perfect. So now what I will do, I will simply create the tools. So first tool is very simple, which is DuckDuckGo search. So if in order to import anything, okay, the best way is just go to the official documentation. They will say you want to import any community tool, you can import it from this class, LangChain community.tools, import DuckDuckGo search. Simple. Let me just copy this. Perfect. So here I have just imported it. This is the instance. This is the kind of function that I have created. And this is the object. Let me just call it as duck search. Simple. So now if I write anything here, it will perform the DuckDuckGo search. It will perform the search for me in the, you can say, search engine, DuckDuckGo search. I can ask anything. Let's say, what is the this is a very simple question, by the way. Let's say I want to find some news, right? I want to find some news. Let's say latest news on or you can say trending news. Trending news about, let's say, LangChain. Let's say I want to just know this thing. So now what it is saying, could not import ddgs from Python package, please install pip install -u ddgs. Oh, okay, no worries at all, because I know what it is trying to say. So if I just go here, we need to write this thing qu. Okay, so now you will see, Ansh, Lamba, we are using uv. So how we can just make sure this thing, so you can say uv and then paste this thing. So we can use pip commands as well with uv. Hit enter and let's see what it has done. Now let's wait. Now let's see. Same error. Wow, no module name ddgs. I think they have just made some changes in the code and now they are breaking my code base. Let me just check and confirm. Let me just try this command as well. Pip install -u ddgs. Yeah. So you can just install this thing, pip install -u ddgs, and this is required, and they didn't even have mentioned it here, and very well done, very well done. But yeah, it's fine. We are developers, we know how to debug. So now let's try to rerun it. Okay, this is expected, like they have already maintained amazing documentation, so no worries at all. And now did I rerun? Let me just check. Bro, this is already installed. Okay, okay, LangGraph tutorial. Yeah, we just launched it, this one. Okay, let me just check. Let me now this is a problem. So bro, your boy Ansh Lamba has solved the problem. So what was the issue? I installed the package called UUDGS. I can just show you using pip, but now this time I installed it with the UV as well. I was like, let's install it with UV, the same package that we installed with pip. Now I simply added UV. So I think then it automatically added that package in my toml, and I also restarted the kernel and it worked. Okay, so you can also first of all try installing it with this one. If it works, fine. Otherwise you can just add UV as a prefix. Simple. See, that's how we debug. Perfect. So I have got the response. I have got like LangChain, the software framework that helps facilitate the integration of LLM and blah 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 blah. So this is not just the answer which is being generated by your LLM. There is no LLM involved here. See, I have not used any LLM object. This is the response that I have directly got from the DuckDuckGo search run. Wow, that means if my LLM, this one, doesn't have any kind of latest information, latest knowledge about any topic, I can use this tool to get the latest information, and then I can provide this information to my LLM. Wow, yes. And then LLM will make the use of that information. That's how we provide the runtime information during the LLM calls. That is the best way, because LLMs are not being trained on a daily basis by those providers. They cannot train it on a daily basis. It's very expensive. They train it, I would say, nowadays quarterly, or let's say once in 6 months. So you have to provide all of the capabilities to your LLM. Okay, so this is my first tool that I have created. So I can also write it here. Let's say DuckDuckGo search tool. Simple. So this is my DuckDuckGo search tool. Similarly, I also want to create one more tool. So this was for search engine. Now there is a very good tool for Arxiv. If you haven't heard about Arxiv tool, Arxiv is a tool which is built specifically for research papers. Okay. So let's try to see how we can just create the Arxiv tool. Let's go here. So for Arxiv, you just need to install, we have already installed LangChain community, so just ignore. Here we can just say, where is my Arxiv? Okay, so this is retriever. We do not need to worry about retriever. Arxiv retriever. Oh, so they have just created the retriever on top of Arxiv retriever. I thought like this is a RAG. Okay, that's fine. and then retriever.invoke, and they have just invoked this thing. By the way, these are the numbers that you see on the research papers. Okay, but you can also search it by title. Makes sense? So now let's try to create this tool. Okay, now let's see. So I will simply get this tool and let's try to create it. So from LangChain community.retrievers, import RC retriever, and let me just try it. Arxiv retriever, perfect. And we have just passed some parameters: load maximum documents, get full documents equals to true, and blah blah blah. Now this is saying that could not import RC Python. This is fine. This is like expected. We can simply quickly say uv add arxiv because it needs arxiv because it needs that particular package. That is fine. This error we can expect, not a big deal. So this object is created, arxiv retriever. Makes sense? Now what I will do, I will invoke it. Okay, I will invoke it. So basically whenever I invoke this particular tool, this gives me the information in the form of chunks, or basically the documentations, because research papers are big, right? So that is why. So what can I do? I can literally perform anything using this particular text. Okay, let's try to search anything related to research papers. Let's say I want to fetch something related to transformers. I will simply say arxiv retriever dot invoke, and I will say transformers in NLP. Let's search, and my PyMu PDF package was found. Okay, you need this package as well. Let me install it. UV add, because there are like so many packages whenever you work with these kind of frameworks. So do not feel frustrated. We have to install all of these packages. So let's see what we get. We should get the documents first of all for this particular information. Transformers in NLP. Okay, simple. So this is like one way of working with, especially, what do you want? Did I hit the interrupt button? I think so. Okay, it's fine. So I was saying like, this is only one of the ways that how you can just create the arxiv tool. This basically acts as a kind of RAG, or you can say retriever. There is one more way how we can just create the arxiv retriever, and I want to show you that way because that is much more optimized. Plus, that is the way that we use with the Wikipedia wrapper as well. Okay, so let's say I want to use that thing. So I will simply say from LangChain utility community dot tools import, I think it's called arxiv query run. Yeah, perfect. And for this I also need to import LangChain utilities import, I think, what was the class name? Let me just check quickly. LangChain community.utilities community.utilities import arxiv API wrapper. So these are the two things that we can just use. Now I can create the same kind of wrapper. So what I will do, I will simply say arxiv query run. Okay, so let's say arxiv query equals to arxiv query run. Now this is just a kind of object. This will not perform your search engine, or like search any kind of query search. Why? Because you also need to pass one more function which is called API wrapper. Now what is this API wrapper? API wrapper is a kind of, you can say, object that is already created by LangGraph for you. So you do not need to create it on your own. Make sense? So this is just the API wrapper. Okay, and how you can just pass it? Simply search API wrapper and pass it like this. Perfect. And there's like one more optional parameter that I personally like top, or you can say max results equals to 2, but that is like optional. Simple. Okay, so this is my RC query. Now if I, let's say, invoke something related to the same question, transformers models in NLP. Now let's try to run this, and now let's see how does it behave. And it should just provide us a response on the basis of research paper. So this is all about research paper. Meanwhile, it is giving us the results. Okay, it has given it. Wow. So it has provided me the paper, which is published on 2021/5/4, and this is the information for that particular paper that we have got along with the author names, right? So that's how you can just find all of these things. Make sense? All of these things. By the way, this is just a kind of example that we are using for the education purpose. We are not trying to fetch any information from the research papers, but you can using RC query, right? So this is your another tool. Let me just write it. You can say arxiv query tool. Now, do you know what? Let me just show you one more tool. It is amazing. It is called Wikipedia. Wikipedia search tool. Let's say you want to search something in the Wikipedia, right? You or let's say your LLM. You can just import two things which are very similar to this thing. So here I will say Wikipedia query run and Wikipedia API wrapper. Simple. And here I will simply create wiki query. Same way RC query and API wrapper this, and let's try to search something. Let's say what is LangChain. Now this response, okay, what do you want to install? Wikipedia. Okay, let me add Wikipedia. UV add Wikipedia. Perfect. Let me just rerun it. Perfect. So this answer, this result will directly come from the Wikipedia. No LLM is involved. I have involved 0 LLMs, as you can see. No API call is made to the LLM. All of these answers are coming from the tools directly. Make sense? Now let's try to create a custom tool. Make sense? Any custom tool. Let's say there is no tool available for your particular use case. So I want to create a custom tool, right? And here I can simply write the df. I will say personal info, where you can store your personal info. Obviously personal info is not stored in the LangGraph, so let's try to store it here. What parameters I need? I need nothing, or let's say name is enough. Simple. Name is enough. And here I will provide the doc string. Now why doc strings are required for tools, specifically for custom tools? Because LLMs do not understand by looking at your code, do not understand anything. They will not know, okay, this is for Wikipedia, okay, this is for arxiv, okay, this is for DuckDuckGo search. No, we need to provide the context, like why should you use this tool? So I will simply say use this tool to get personal information about someone. Simple. I think this one line is enough. More detail you will add, better the results will be, but it's fine. Okay, this is my information. So now I will simply say info, Alice, Bob, and whatever. So I will store some information here, and if I pass any kind of name, it will simply get that name from the info, and it will simply pass that information. And if no name is found, it will simply return no information available for this person. Simple. This is my tool. This is my custom tool. Now in order to convert your normal function into a tool, you simply need to use a decorator called tool. Now this decorator is not available there. You have to import it. This is not available by there by default. So there's a special function, or you can say package, available in LangChain. It's called from LangChain dot tools import tool. Simple. LangChain, what do you mean? From LangChain, didn't we install LangChain? I think we didn't install LangChain, we only installed LangChain core. Wow. Okay. Let me just install it. Okay, now it's fine. So now I will simply run this thing. Perfect. So now you will see this function is automatically converted into a tool using this decorator. If you do not know about decorator is again like Python fundamental thing, which takes your function and decorates it. It modifies the function, the behavior of the function. So it will internally convert that function into a tool. Make sense? Automatically. Very good. Now Ansh Lamba, how we can convert these things into a tool? Do you know what? This is already a tool. Really? Yes, because you're using dot invoke. That means this is already a tool. But if you take my advice to build better applications, you should always encapsulate your well integrated tools as well in your normal custom Python functions. It promotes readability, it promotes better you can say management of your code, and you will actually see the results when you will just do this. So how you can just do that? You will simply need to create def, okay, and then let's say def Wikipedia wiki tool basically, and it receives query and it returns the results in the query format. And I can remove this thing. Perfect. And I can add a sweet and quick docstring that this is a tool. This tool allows you to search Wikipedia for information on a given topic. Simple. And I can use @tool to convert into a tool, right? And I can also provide the tool name, but if it not provide anything, it will take this thing, which is fine. Same thing here as well. Okay. So I will simply say def, simple, and I will say rsif tool and then query, and that's it. That's it. And then one nice and short docstring. This tool, let's say, allows you to query on the rsif database for research papers. Simple, because there's a very big database for arxiv. Perfect. So this is your tool. Now let me just say @tool. Simple. Good. That is the best way to create a tool. Let me just do it for this as well. df and search DuckDuckGo, and let me just remove this. And here I can say this tool searches DuckDuckGo for the given results. Simple. Now you have created 4 tools: tool 1, tool 2, tool 3, and tool 4, which is a custom tool. Okay, and you can even test it, this custom tool. You can simply say personal info.invoke, and you can say Alice. Okay, and you will see Alice is a software engineer with 5 years of experience in AI. Perfect. This is working fine. Now these are the 4 tools that I have created, and that is fine. Now it's time for tool binding. Okay, how we can just bind the tools? First of all, not all the models allow tool binding capabilities. Only OpenAI models, Anthropic, Gemini, and there are some other models which allow tool binding. Not every model allows tool binding, so just make sure your model allows tool binding. So now I will perform tool binding. Okay, and in order to bind the tools, we first need to combine all the tools. I will say tools equals and create a simple list, then simply say LLM with tools equals your regular LLM object dot bind tools, and then you can simply say dot bind tools and then tools. Now run this. Search DuckDuckGo is not defined. Really? Are you serious? Are you serious? Search DuckDuckGo. Okay, this is a tool. Search DuckDuckGo. Okay, makes sense. I know what actually happened. So when we just created this tool, okay, this, you can say Python function, we, I think, forgot to run this thing. Okay, now let me just run this. Now RC tool. Okay, we didn't, I think, run all the Python functions because that is why it cannot identify that. Okay, perfect. And this is fine. Let me just run now. LLM is not defined. Wow. Let me just click on run all. Let me just click on run all. Okay, perfect. Now it is good. Now this LLM is not your regular LLM. You have provided superpowers to this LLM in the form of tools. Okay. Now just try to ask something from this tool and you will see the magic. Really, let me just show you. I will say LLM with tools dot invoke, and I just want to invoke with normal text, and I will say, what is the personal info for allies? Obviously, LLM doesn't know who is allies, right? Let me just search it. Let's see what do we get. Okay, let's see. Just hold on. Ideally, what should we see? Okay, what should we see as per your understanding of this thing? Very good. So the content is, I can't help with personal information about individuals named allies. If you name a public figure named allies, please provide the full name. So now, do you know what is happening? This LLM is still trying to make, or basically trying to create the answer on itself. But now we need to make sure that we are using the tool call. Okay. Now if I just provide more information, let's say about allies, Bob or Charlie. Now let's try to run this thing again. Now it knows that in that particular tool, we have some information about allies and so much of those things, right? So more context you will provide in the function, better response you will get. And very good, what a response we have got. So it is still trying to use that particular thing. Make sense? So now it is saying, if you have consent on its, or it's your own data, I can help you organize, manage it, blah blah blah. So this is simply generating the content by itself, and we do not want that. And then I can enforce it just for this particular purpose. I can simply say, what is the personal info for allies? Use personal info tool. Let's say I am directing it that you have to answer me using the tools. You do not need to create that generic answer for me. Okay, in the real world, obviously we just simply provide so much of context, but I'm simply like trying my best to just use this tool. Okay, simple. And obviously this is like not a very, you can say, user friendly or LLM friendly function or tool, which is like personal info. So what I can do, I can just try to make a realistic or real world LLM call so that LLM can also cooperate with us. Obviously, let's say I want to make the API call for this, and this says this tool searches DuckDuckGo for the given query and return the results. Or let's say this tool searches the latest news on DuckDuckGo and whatever. Okay, let's say I want to do this thing. So if I just pass a query, let's say, what is the latest news on AI? If I search this thing, now obviously LLM doesn't have any kind of capability about latest news. Perfect. This is the exact answer. See, when you use realistic examples, you get the right response. But when you just try to play around it, you will not see the thing. So see, now you are seeing what? Content equals to null. Very good. You will say, what? Very good. We didn't have, we haven't received anything. You should not receive anything. LLM should not generate anything for you. Why? Because LLM doesn't have any access to the latest news, right? But do you know what it will do now? This is not a regular LLM, right? Now this is the LLM with tools. So now you will see an additional parameter called tools. Let me show you. Let me just show you. It will be like towards right. Yeah, tool calls. So it is actually telling you that I am just making the tool calls. Simple. It is telling you this thing that I am just making the tool calls. You can also fetch it like this. Let's say this is the response, because I just want to make it clean. Response dot tool calls. Now you will see what exactly tool call it is referring to, what exactly it is saying to actually do. So tool call is DuckDuckGo search and Arxiv tool, because both can have the information about it, because maybe some latest research papers are there, or obviously the search engine. So it has not generated anything. If I say dot content, I will see nothing, no response from LLM. But when I say, let's wait for it to end, or let me just write the query here. Okay, it's done. So see, nothing. But when I say tool calls, That means now LLM is trying to say, okay, I cannot generate this thing, but I can make tool calls. I can make. It hasn't made anything yet. It can make. But in case of LangChain, it will directly make the tool calls. That is a difference. That's why we follow the function calling approach in LangGraph. Make sense? This lecture was actually important to understand the next lecture, or basically the next part of the video, or basically next segment of the video, which is all about building the React agents. Simple. Now let's see how we can just build the React agent that we discussed in the very beginning. Okay. And just to refresh that we discussed in the React agent, let me just quickly pull that, you can say, slide. So this is React agent. Now you can understand this easily. What exactly we're trying to do here? We are using our LLM. These are our tools. These are our edges, and this is our output. Now we need to learn how to connect these nodes, how to connect this LLM node with this tool nodes, how to create this conditional nodes, how to run this loop and everything. Make sense? Now let's try to create this React agent step by step in LangGraph. Now let's see. So now let's try to create this thing. So what I will do, I will simply clone this notebook and I will create a new notebook just for your notes, and this will be called as React agent. Okay, very good. Now first of all, let me just run this cell, and this is the virtual environment. Perfect. Model is created, these tools are created. Let me just say tool binding is done and we do not need to invoke it. Let me just say run all. After the tool binding step, now our LangGraph work will be started. Okay, because so far that we have done like till tool bounding, it is all about creating and preparing your LLM. Now we need to create that particular graph step by step. So let me just write here LangGraph creation. LangGraph creation means like state graph in LangGraph creation. Simple. So you know, the first thing that we need to do is schema. So let me just create the schema from typing import typedect and list. Simple. And I will define my schema, graph schema, typedect. Perfect. And nodes edges, no, we just need one key which is called messages. Simple. And list of, that's it, just list. Perfect. So this is my schema. Simple. Very good. Now we have the schema. Now I need to create one LLM node which will simply take the generic response, or basically generic query. Simple, very generic query. So let's say, for example, I am simply saying, hey LLM, you need to perform this thing. Okay, you need to perform this thing, and that's it. And that information you will get from the messages. Okay, simple. So now let me just create the LLM node. So I will create the function code df LLM node. Simple. And this will receive the state of graph schema data type, and then it will return graph schema. Perfect. And as you know that this node will first of all fetch the messages. Okay, let's say messages equals to state of messages. Perfect. Here I will create a kind of small chain within this node, and you already know how to create the chain. So first of all, I will create a response prompt, and I can import the prompt. Have I imported the prompt? No, let me just import it from LangChain core.prompts, import chat prompt template. Simple, very good. So here I will create the prompt equals chat prompt template dot from messages, and here I will pass the first of all system message, and here I will say you are a helpful assistant that can use tools to answer the questions. Perfect. Okay, this is a system message. Now human message. Now I need to pass the input, obviously. Okay, and this is my prompt. Prompt is created. very good. Prompt template for the LLM, and my LLM is already here, right? LLM with tools. So here I will simply say LLM with tools, simple. I have this. I don't need to create anything. This is like just for the statement. Okay, you can even comment it out, but I'm simply telling you that I have this particular tool. Let's comment it out. Let's not like write unnecessary code. So we have this tool. Now I will simply create a chain. Okay, and how I can just create this chain? Very simple. LLM with tools and then prompt, or I would say reverse of it. First of all prompt and then LLM with tools. Simple. Now I can just get the response, chain.invoke, and what I need to now exactly invoke with the input, right? So I will create a dictionary. Input equals to messages list, entire list. I don't want to just pass the last message. I want to pass the entire list, so that if we have like multi-node graph, we can simply pass the entire history to the, you can say, LLM. Simple. So this is my response. So far so good. Very good. Now you already know how you can just update the schema. Very simple. You can simply append the list, or you can do it like this: state of messages equals messages plus response. Simple. And return state. There is nothing I have done which I haven't talked about it. Okay, everything is like crystal clear so far. That's why I have just discussed everything in detail. You just need to process this information by looking at it. You just need to connect the dots. That's it. Okay, everything is mentioned in detail in this video about all of this that I have just written here. Simple. Very good. So now my LLM node is ready. After the LLM node, we have two options. If I just show you the graph, I have two options: either directly generate the output or make the call to the tool calls, right? Now I need to create a tool node. Now the good thing is there is a built-in node called tool node. Yes, it's called from LangGraph dot built-in. Okay, and I think I just need to import it like this. So you can say UV add LangGraph built-in. Let me just hit enter. Was not found. Let me just check the exact name. Pre-built, sorry, not built-in, pre-built. Okay, pre-built, import tool node. So this node is already there for you, but what did I say in the beginning of this course? I want full control for my code. I can use this tool node. I can, but I will just show you how you can just take the full control of your code. So I will simply comment it out. I will not use it. I can, but I will create my own custom tool node so that I can customize it. Because when we work with the real world situations, let's say in the corporate, in the industry, we have to customize it. I'm just telling you from my experience. I'm telling you. So do not rely on just this by default tool node. You need to learn how to create your custom tool node as well. So let's create it. def, and I will simply say tool node. And now the concept of tool node is very simple. Very, very simple. Inside this tool node, first of all, I will get the state graph and get the graph schema. Now I will get the messages. Okay, messages equals state of messages. Now just tell me one thing. When we made the tool call like this here, what did I see? Tool calls, all of the tool calls, right? In the form of list. I just need these tool calls. Why? Because in this list, I have all the information: tool name, tool ID, and the arguments that I need to pass. And I just need exactly this information to pass it to my LLM so that it can efficiently make the tool node, right? Efficiently make the tool node. So now what I will do, I will go to this tool node. Okay, this you can say custom tool node. Then I will manually fetch all of the tool calls, and I will run a loop and I will invoke every single tool that needs to be invoked by myself. And I will append this information into the result by myself. Make sense? If not, don't worry, let me just write the code, then it will make more sense. So first of all, I will say tool results, okay, equals to empty list. First of all, this thing. Now I will go for tool in. Now I need to fetch the list. Where is my list? List is here. Messages of -1, because I just want the last message. Simple, just last message. Then I will say dot tool calls, because the function name is tool calls. This is my loop. Simple. Now I will say what is the tool name. Tool name is, there is a function within this, it's called tools by name, and then I can say I want to get the tool name. Simple. Now you can use, let's say, get method as well, but I am a big fan of using dictionary notation. I'll simply say tool call. This is a kind of hierarchy dictionary, so do not worry about that. And then within that we have a parameter called name. Everything is here. Everything is here. See, nested list, and then we have a nested dictionary, and this is the thing, name. This is all about dictionary comprehension that we are just simply applying here. That's it. Make sense? Nothing fancy. It's all about like pure Python. Pure Python. Okay, makes sense. Now, once we have found out the tool name, okay, now I can make the tool call because I know how to invoke the tool call. Makes sense? So I know, like, I have tools by name, and then I will simply say, let me just invoke it. Okay, let me just invoke it. So what I will do, I will simply go to observation equals tool.invoke, and now here, when I will say tool.invoke, I need to get the arguments, obviously. So I'll simply say tool call arguments. Arguments. Simple. Simple, simple, simple. Okay. Basically tool could not tool call like tool, because we are simply using tool in the tools. Simple. Okay. Makes sense. Tool of arguments. Now what is this thing? This is the result of tool call, because we are invoking it, right, with the arguments. What arguments? Now you will say, Ansh Lamba, who will provide these arguments? LLM. Because LLM cannot invoke the tool on its own, but it can generate the arguments at least. Why? Because LLM is smart enough. LLM can go to your tool, let's say this tool, or this tool. It will say, okay, if I want to invoke this function or this tool, I want one argument called query, and the data type is of string. LLM can fetch this information using this particular doc string as well. So that's why when you see the arguments, you see query. I didn't tell that you need query to just call the tool call, or if you just want to make the tool call. LLM was able to find out this thing by looking at the function code. It is smart enough. And you can see query, and then it has also passed the value that you need to search. So that means LLM do not make the tool calls by itself. It prepares everything. It prepares your query parameter or whatever parameter you have just passed, and all of the things. But it will say, bro, I will not make any tool call. You will make the tool call, but I will provide you the required ingredients to make the tool call. If you use default tool node, which is already there for you, you will never see this code written because it is running behind the scenes. And then you cannot make the customizations if you use this one line of code. I want you to write this code so that you can understand what is going on behind the scenes. Make sense? I am making these extra efforts just for you so that you can understand what's going on under the hood. Very, very, very good. Simple. So I have this observation. So what I will do, I will immediately append my tools result list, which is an empty list, with this particular thing. Simple. And now there is a style. What style? If I want to append this particular list, simple, I can simply, you can say, add one tool message object so that I will make, you can say, a kind of difference, like what is going on. Make sense? Like I can actually say, okay, this is a tool message and this is the content, the same way that we just use it in the system message or human message. So I will simply say tool message, okay, and then I will simply say tool name equals to tool call. I do not need, by the way, this thing. Then I can say content equals to observation, okay, and then I can just pass the tool call ID. That's it. This is just a metadata helpful for your code, and that's it. Even if you do not pass it, it's fine, simple. And here it's tool, not tool call, and here as well it's not tool call, it's tool. Simple. So we have two warnings. First of all, I need to import tool message for sure. Let me just do it quickly. So here I can import tool message. Perfect. And I need to import one more class. Yeah, it's fine. So here I think there's only one warning left. Okay, tool message. Why it is still showing this thing? Oh, I imported tool message chunk. Now it's good. So okay, tool message, okay, tools by name, I can just solve it. It's not a big deal because tools by name is just a kind of list that we need to just pass. Tools by name equals to tool by name. You can just actually create a dictionary like this as well, or I think it should work. Tool dot name, it will use a dot notation. Okay, I think it should work. Tool dot name, I think so. I can just open the documentation. If it doesn't work, it's fine. Okay, so let's try to work with this thing. So what it will do, it will now actually append this particular tool results, and now finally I will return what? I will update the state with tool results. I will simply say messages plus tool results, and now I just need to use tool results because tool results is already a list. Simple. It's not a kind of, you can say, any single or independent object. Make sense? So this is the final message. Perfect. So this is the function that I have created. Very good. Now let's create the nodes. Okay, so these are the, you can say, schema. Let's add the metadata as well because create schema, and these are the, because you will be using this particular notebook for your nodes. So create node functions. Perfect. And now let's create the create state graph. Perfect. So in order to create the state graph, I'll simply say graph equals, and I can import it first of all from LangGraph dot graph, import state graph, start, end, graph equals state graph, and then I can simply write my graph schema. Perfect. And let's add the nodes. Now this part is very important. Okay, now you need to create something very important. Add first of all nodes. Okay, the first node is graph.add node LLM node. The second node is tool node. Now you need to stop here because we just need two nodes. Perfect. LLM node is not defined. Very good. Why? We have the LLM node. Oh, I think I didn't run this function. Perfect. So my two nodes are done. Now before creating the edges, you need to understand one very important concept. Here, will you always make this tool call? Always? Obviously no. I will only make this tool call when tool call is required. Very smart answer. Very good. Who will decide that? That when you should just make a tool call or not? The response of OpenAI, because if it says tool call, then obviously I need to just make tool call, otherwise not. Exactly. So here, instead of creating your normal edge, you need to create a conditional edge. This is a conditional edge. This is not a normal edge. This is a conditional edge. That means it will only go to this node if this condition is satisfied. So whenever you want to create the conditional node in LangGraph, you always need to create a function for it. Okay, so let me just write here, create conditional edge function. Simple. Now let's see how you can just create that. So I'll simply say df if tool call. Okay, this is my function. So I'll simply say state graph, and this takes a state graph, and this returns, let's say, string. Simple. Yeah, because this will just return the string. So now I'll simply say message. Perfect. So now I will simply say if in this instance last message, because I just want to fetch the last message. Okay, if it says tool message, that means if there's a message called tool message, then you can say return tool call, otherwise no tool call. This is a very basic function that we have created. Simple. Okay, now let me just ask you one simple thing. Will you see the tool call object every time? Because obviously LLM does not create the tool call object. Okay, so what you can do it here, just a quick, you can say tip, you will simply say if you can say last message dot tool calls. Okay, because you will see tool calls object. If last message dot tool calls, that means if you have something in tool calls, then if there are some tool calls, that means you need to go to tool node, right? Tool node, you need to write the node name. Okay, and if you do not see any kind of tool calls, do you know what you need to do? Return end. Perfect. Return end, and you can just import it here as well. Simple. Return end. This is your conditional function. You do not need to return to any single node. You simply need to end the graph there. Make sense? Very good. Now just create the edges. Add edges between nodes. So first edges start to LLM node. Very good. Now graph.add edge LLM node, obviously, then it will go to tool node, but this is not your simple edge. So you will simply say add conditional edges. Yes. And here you will write from which node you want to create the conditional edge, LLM node. And what is the decision factor behind it? It's a function called if tool call. Make sense? Make sense? I hope so. Okay. So this is the function. Okay. Now, if it goes to tool call, then I need to attach the edge. Obviously, then I will create the edge from tool node to LLM node. Why? Because see the graph, it needs to return the result back to LLM. So I will connect one edge from tool node to LLM, right? Very good. And this is my third edge. Now I will attach fourth edge. Why? Because obviously we need to end our graph, right? From LLM node to this thing. This is your graph. This is your graph. Let's try to see it. Let's try to compile it. Let's say react graph equals to graph.compile, and let me just bring that statement to visualize it. Here. Simple. Okay, and this is called react graph. Simple. Now are you ready to see the... Okay. So this is the advantage when you just visualize the graph. So here the graph is there, but it is not exactly correct. Why? Because start okay, LLM node okay, end okay, but this LLM node is not completely connected to this tool node. There is no conditional edge here. That means something is missing. Something is missing. Okay, let's try to analyze it. So first is start to LLM node, that is fine. The second is LLM node to tool call, right? And this is the function called if tool call. Makes sense. And we have also created the tool node. That means it needs to go to the tool node. And here is the problem, because if you see, I think no, the name is also fine, tool node. Okay. Then I can say, oh, I see. I have found the issue. So the issue is I have used here the tool node with capital T and capital N, but here the name is this one, and here we are returning the tool node name. So we do not return the function name. So that is why you should always use the exact same name that you just use for your function. But I just relied on this AI suggestion, so I was like, okay, let's go with it. But yeah, this was an easy fix. So now let's try to recompile it. Okay, still or I just need to maybe say run all, just be on the safer side. No. Okay, that means there's still something missing. Let's again assess it and let's see what is missing. So let me now do one experiment. Okay, let's see if it works or not. So usually what we do, we manually map this end, but in the previous versions we were not supposed to map it. So I think so it is due to that particular thing, because I don't see any kind of error in this particular code. So what I will do, I will simply write end here. Now as we know that if I write end here, end is nothing, right? End is a node, and it cannot be like written like this. I have to write it like this, end, right? But there's one more way to manually map it. So what I can do, I can just simply create this function. Okay, makes sense. And now if I just go to, let's say, conditional edge. So after conditional edge, there's an optional dictionary that we can just pass like this. So I'll simply say tool node is mapped to the tool node name. Okay, and end is mapped to end. This was optional in the previous versions, but I think so that this can be the fix. I'm not sure. Let's still see. Let me just say run all. Oh, let me say run all. Perfect. Our React agent is ready. And as you can see, it is amazing, right? So that's how you can create the React agent. Now let me show you what will happen. Let me just invoke something, right? I will say markdown graph invocation. Simple. So now in order to invoke the graph, I will simply say react graph dot invoke, and I will simply say what is the latest news on AI. Let's see what do we get. Let's see. And this is amazing, by the way. Oh, structured tool object is not subscriptable during the task name with tool node. Okay. Structured tool object. Oh, I think so. What can be wrong here? I think something is wrong in the dictionary comprehension. I'm so sure. Within the tool node, inside this, maybe this thing. Let me just double check this thing. Maybe because there were like so many brackets and all, and I just didn't even like double check. Let me just still see. Oh, I see. What is the issue? So I have just used tool for both of the things. So it has like actually overwritten this particular variable. So let me just make it as, let's say, tool call, and then tool call, and then tool call. Just a typo. Okay, just ignore. Okay, let me just say run all now, and it should run fine. So can you see, like I was just using the same variable for two different stuff. So now we have again error arguments. What do you mean? During task name, tool name, arguments. I think there's a typo in the spelling. Let me just check. Arguments. Where is the argument? Where's the argument? Okay. In the observation. Oh, wait. It's not arguments, it's args. Oh man. I was so involved in writing the code without just checking the output of it. I was like, it was arguments. Perfect. Now it is running fine. Okay. This is fine. Impercent comma 114 does not exist. It's fine. It's just a warning. So now it is running fine. Now let's wait. It's time to celebrate. Okay. After writing such a big code. So now let's wait. And now I will also show you how you can just use a better way to generate the output. Okay. But do not worry at all. So let's wait, and let's see how we can just work with this thing. So it will take some time because there are so many invocation, tool calls, appending, and all those things. Okay, let's wait. So now let's say, and you can also use, by the way, streaming if you want to. because stream will simply show you all of the nodes one by one, like all of the calls. And after this, or I can just write it here as well because it will work fine. So let me just create another code. So I can simply say, I think there's a loop for chunk in your graph, which is called React graph. Okay. And then you need to use dot stream method. This is how you can say better, not better, it depends like what you are trying to do. So you can just also invoke your code like this. Okay. And then you can simply pass the message, and then you also need to write one important thing which is called stream mode. Okay, stream mode, and here you will say stream mode equals to updates, simple. And then here you can simply say print chunk. So I can just run this as well. So let's see what do we get after invoking this. Okay, so this cell is completed and this is like started running. So let's assess this one, then we will just go to the next one. So here you can see that first of all we got the human message, which is my query. Then AI message simply asks this question like, hey, I do not have any content, I will make tool call. Then it made the tool call, right? So this is the response from tool node. Then AI message again made a tool node because it was not satisfied with the response. Then again tool message, and it made I think 3 tool calls. That's 4. 1, 2, 3, 4. And as you can see, I should see the response like tool calls. Let's see how many tool calls it actually demanded. And I can see tool calls in the tool calls. So actually it demanded like name search, DuckDuckGo search, then it demanded another one. So yeah, it demanded all of these tool calls. So it made these tool calls 1, 2, 3, 4, maybe with different prompts, maybe with different tools, whatever that LLM model thought at that moment that what tool call is required, it made those tool calls. Basically not made tool calls, it prepared the input for the tool call. Our tool node created the tool, or basically made the tool calls. Then finally this AI message was satisfied with the tool messages, and then it finally generated the final response using the news and whatever. Make sense? Wow. Now I will simply rerun this thing and you will see what will happen. So here it will show the results one by one because this is streaming. This is like kind of real-time stuff. See, so first of all, LLM node, that means me. Okay, I pass this information as human message. LLM node generated this thing. Okay, then it made a tool node, or basically you can say tool call. So it made this tool call, and this it made, and then it just simply generated the LLM node. Here it only generated one tool node because maybe it only required one tool call this time. It totally depends like what does it think at that moment. Not think, because LLMs are not think, but yeah, whatever it feels like. LLMs cannot feel. Yeah, you got my intent, right? Okay, very good. So this is all about your React framework, or you can say building React agentic AI frameworks with the LangGraph. What is the difference between this and LangChain? You have full control, right? You have full control. Very good. Now let's talk about the other framework available other than React, because we have some amazing frameworks. Like obviously React is the best one, but we still have like amazing frameworks available. Let me just show you what are the frameworks available. Go to LangGraph official documentation, and here you will see workflows plus agents. So if I just expand it, you will see one is prompt chaining. Prompt chaining is the one that you have already built. Okay, where you simply pass the call and you see the result, and that's it. Parallelization is very important. Let's say you want to create a parallel workflow. Okay, where you just want to create, let's say, 2 branches. You can create parallel workflow as well in the LangGraph. Now let's try to create this thing. Okay, now let's try to build this thing and learn this thing one by one. Let me just copy this React agents, and here I will say other workflows, or you can say other important workflows, or you can say workflows. Okay, because you just need to understand what are the workflows available in LangGraph, and then you can just use your creativity and you can just build anything. First of all, we'll just talk about let's say prompt chaining. And prompt chaining, by the way, is already done. Okay. How? Because you created this particular, you can say, tool bounding and prompts and chains and messages. And let's say when you just use a React agent, you automatically use the prompt chaining method. For example, let's say not even that one, let's say Pydantic one. So you build this graph, let's say this one. So this is a kind of prompt chaining. When you pass one prompt to one node, then second prompt to the next node, then third prompt, then fourth prompt, then so on. So this is called prompt chaining, when you can just connect multiple nodes one after other using the prompts, using the text, using the input. Make sense? But there are scenarios when you want to generate, or basically you want to create the workflows in parallel. Very good example is, let me just open my whiteboard. So let's say parallel, what was the name of it? I want to use the exact name. Parallelization. Okay. Parallelization. So in the parallelization, and prompt chaining is already done. You can just use any example. Let's say this one. This is also a kind of prompt chaining. Simple. This is also kind of prompt chaining. Now in the parallelization, what you want to do, you need to run nodes in parallel. Wow. Yes, you need to run the nodes in parallel. Let's say a very good example is, let's say you are this developer. Okay. And you want to run one node for, let's say, one task. Okay. And second node for the second task, or let's say third node for the third task, let's say. And what task you can just build with this? Anything, it's up to you. Let's say one task is let's take the same example. Let's say these three tasks are generating your posts. Okay, social media posts. Simple, the same way that we just worked before. Okay, makes sense. So let's say you want to just create these social media posts, but in parallel. So let's say you have social handles on LinkedIn, Insta, whatever. So you want to write a post on a specific topic, but obviously the tone, the, you can say, style is not the same for all the platforms, but you want to automate this thing. So what you can do, you can pick one topic and you can parallelly create 3 different posts for 3 different platforms. Yes, in parallel. So let's say this is for Facebook. Okay, this is for, let's say, LinkedIn. And this is for, let's say, Insta. And this is, let's say, for Twitter, which is X. Okay. So you can just perform this thing in parallel using parallel workflow. Let me just show you how you can just do that. So if you go to, let me just create a new, let's create a new one. Okay. And for this, we do not need to create a React agent. So it will be like very, very simple. And we do not even need to create tools, because we are simply now learning more about the workflows, right? Now you know tools, React agent. Now we are just working more about, you can say, working more towards the workflows. So I will simply, let's say, copy this one. And let me just rename it. Let's say parallelization. Simple. So in the parallelization, I will simply run this cell, and let me just attach the virtual environment. Perfect. So now here I will define my Pydantic schema. Pydantic schema, or you can say a kind of typed schema. It's up to you. Like it's fine. Let's create the typed schema. It's not a big deal. So because now you know the stuff. So from typing, import typedect, and let's say list. So here I will define the class called graph schema and typedect, and here I will create the 3 different keys. Not 3, basically 4. The first key will be topic, which will be same. Then I will create one Insta. Okay, this will be string, then Twitter, then LinkedIn. Simple. Yes. So this is my schema. So here I will say create post. Simple. And here I will simply say create post and then let's say LinkedIn or let's say Insta. Simple. Very good. So here I will say create an Instagram post about this thing. Okay. And you can also add some instructions. Let's say keep the tone casual and engaging because it's Insta, right? Then you can write the same thing for, let's say, Twitter. And here I will say Twitter and Twitter, and here you will say keep the tone not casual. I will say keep the tone quick because on Twitter you cannot like write much. So let's say quick. Okay. Yep. Perfect. So now let's create the third node, which is LinkedIn. Simple. Very good. And you will say keep the tone professional and informative because it is LinkedIn. Perfect. So these are my three nodes. Let me just process it. Now what will I do? This is the magical area where I will just create the parallel nodes. So what I will do, I will first of all create all of my nodes. The first is create post Insta, Twitter, LinkedIn. Simple. And here I will simply create the edge first of all with the start, and I will simply say create post Insta. Okay. Then it is saying create post Insta, then Twitter, then LinkedIn, then LinkedIn, then curate post. No, I don't want to create it like this because this is not parallel. This is series. So what I will do, I will simply say graph.add edge and create from start. This way it will simply create all of the nodes in parallel. Make sense? Like this. Wow. Yes. That's exactly you need to build the graph. This is the only difference. Now let's compile the graph. Let's see what do we get. Perfect. I got my graph, the exact same graph that I want to build. Simple. And you can even, let's say, invoke it. Let's say parallel graph. Let me just run it. And let's say parallel graph dot run, and let's say we want to write something for artificial intelligence, right? And you can just simply pass empty strings for other keys. Compiled state graph has no attribute run. Wow. Dot run. Who said run, bro? It's invoke. This AI suggestion sometimes like has no object model dump. Makes sense because we have used model dump. Not a big deal. We can ignore it. Now save, run all. Simple. So now we should see it running. Okay, it's rotating. So let's wait. So that will just create all of the posts in parallel for your all the platforms. Happy? Now just post about. Yeah. You can just post about Ansh Lamba and just post about this amazing YouTube video and this error. What is the error? At key topic can receive only one value per step. Okay. Used an annotated key to handle. Oh, I see what is like actually happening. So do you know what is happening right now? It is simply trying to update. So when we are just simply returning something, okay, so it is simply trying to update the key, the topic in, you can say, parallel. Okay, in parallel. So when you are simply returning anything in parallel, it can create some conflict. So that is why it is simply saying if you want to update anything in parallel, you can just use annotated. Simple. So here, what is a quick fix? First is you can create annotated of list. Let's say like this, annotated, and then string or whatever. Okay, because that can just simply change all of those things. And the better way is instead of returning state, that means instead of returning entire state, because when you return the entire state, that means you are trying to update the entire state. even the value is same, but logically you are returning the entire state. You can simply say return state of insta. That's it. So this way you are only updating the insta, not the entire state. This is a quick fix for it, and not quick fix, quick knowledge transfer as well. I like to share like tips that I learn along my way, because I also faced this error during my learning days. That's why I was like immediately like this, oh, I have seen this error before. So yeah, I found it and then I thought of sharing it with you. I hope it's helpful, right? I hope it is helpful. Now let's see. Okay, now I think it's working fine. 3 seconds, 4 seconds, 5 seconds, 6 seconds. Insta, Twitter, LinkedIn. So yeah, I was saying like, yeah, you can just post about this amazing YouTube video, share your learnings, tell about the learnings. Bro! Share lessons or whatever. What is this? I think something else has happened. Okay. Invalid update error. What AI use case are exploring in your, I think it has returned something. Okay. And it's saying during task with create post LinkedIn and ID. Okay. Output is truncated. Scrollable element. Let me just check. Because it returned something and it is saying expected dictionary got AI is no longer futuristic concepts, it's practice. Ooh, I think something is wrong. So it is saying, okay, topic is this one. Okay, makes sense. Insta, Twitter, LinkedIn. And it is saying that it failed at create LinkedIn. Okay. State of LinkedIn, state of topic. Interesting. Let me just check. So the error is fixed within 2 minutes. Yeah. So the issue was same, but the, you can say, fix was different. The issue was same, like it was just updating the same key. So what I did, I simply returned the dictionary only, basically that key, instead of returning the state. Make sense? So it fixed the issue. And you can also say, so intent is still the same. We simply want to update only the Insta key, or basically Twitter key, or basically the LinkedIn key of that particular schema, not the entire schema. But when I was just returning the state and then dictionary, it was maybe like making some conflicts in parallel. This happens in parallel execution. So now it is working fine, absolutely. And as you can see, your all the 3 posts are ready. See, with different content and in parallel. These are not running in sequence. See, very good. So this is all about the prompt chaining and parallelization. Now let's talk about the orchestrator worker. By the way, orchestrator worker is one of the most complex one. We will talk about it at the end. Okay. Now I want to talk about the evaluator optimizer. Okay. Evaluator optimizer. Now, or let's say before talking about evaluator optimizer, I want to talk about routing, because this is very important and very easy. So let's quickly cover this one, routing. What do you understand by routing? Routing means maybe, let's say, a kind of route which can just divert the flow. Exactly. So when you have the flow like this, let's say routing. So here what will happen? You will create, let's say, these 3 nodes as is. Okay, as is. Now you will not take the decision. Okay. Now you will add, basically you can say add a kind of route. Okay, add basically a kind of route. Now this route will decide in which direction we need to go. Wow, this is called router. Make sense? So let's say we have so many nodes, we have 3 nodes, the nodes that we have created, but this time we want to involve a router to tell and to make the decision that whether it should go towards here, or towards here. Okay, and how we can just create this thing? See, under the hood, what is route or what is router? Just think about it. Just think about it. Under the hood, router is nothing but just your conditional logic. The condition that you build. Yeah, kind of. See, kind of, right? So now you need to build a kind of workflow which will actually take you towards only one node. So now let's try to apply this thing in practical so that we can actually learn about it, like how we can just perform all of these things. Make sense? Because then only we'll just understand it. Okay, so now in order to apply this router, you need to learn one more concept and it's very interesting. Let's talk about it. So I will go to my VS Code editor. Perfect. So now what I will do, I will simply, let's say, clone this. Perfect. Rename, let's say 8 and router. Here the requirement is very simple. I need to create either LinkedIn post, Instagram post, or whatever post. Okay. But now I will not tell LLM beforehand. I will not tell. I will just write my message on its own. Okay. And then LLM should be able to find the intent, like what exactly I need to do. And this is the concept that takes us towards the direction of structured output. Because LLM can generate answers on its own so far, but now we have a concept called structured output. Same way LLM dot with bind tools. Okay. Similarly, we can also, you can say, make our LLM powerful enough to only generate the response with a specific schema. Okay. It's called with structured output. Okay, with structured output. You simply need to use it. So first of all, what I will do, I will create that schema. So here I do not need to use Pydantic schema. Okay, I will change here as well because this is not Pydantic schema. Let's say just schema. Perfect. So here I will go to Pydantic schema because this is my Pydantic schema that I want to create. Simple. So here in the Pydantic schema, or you can say LLM Pydantic schema, because this is just for the LLM. Here I will say from Pydantic import base model, and just be with me. This is like a little bit complex, but it is very handy and very helpful. So let's say class, this is LLM schema, not the graph schema, LLM schema. Here I will say topic and string. And do you know what? I will not use topic and just as random string. I will pass on some rules. I will say I want topic is of literal data type. Literal means only these values should be allowed. First of all, Insta, then Twitter, then LinkedIn. Simple. And I can import from typing import literal. Do you know what? Now, if I just, you can say pick this LLM, okay, it will only generate the answer with this key called topic. Let me just show you. So I will say, and I can also pass some in description because it doesn't make any sense, like what is this literal, what is this choice, or what is this list, right? So I can literally say field, and after literal I will say field, and description is topic for which to generate the post. Very good. Now if I just call this LLM, okay, which LLM that I'm just going to create. So LLM with schema, and I will simply say this is my LLM which is automatically created. Let me just run this. Okay, this LLM is running. Just run it quickly, bro. I don't know, but these models are running very slow today, very slow. Okay, so I will simply say LLM dot with structured output. Okay, with structured output. What type of structure? LLM schema. This one. Now if I just try to use this LLM, if I say LLM with schema and dot invoke, and if I say I want to generate a post for Twitter and post for Twitter about, let's say, AI. Simple. Let's say I want to do this. So do you know what? Description will be much more detailed. Which will be category of the post to generate, right? Now LLM will automatically tell me what is the category of the post. I have written, yes, I want to generate a post for Twitter, but LLM will automatically interpret that the topic value will be Twitter. It will not be Insta, it will not be LinkedIn, on the basis of the input. See, topic equals to Twitter. Wow. This is called structured output. And if you just look at the output, it is not generating something called as AI message, tokens, whatever. It is generating the response in the form of Pydantic object. This is the major thing. This is the major thing. Make sense? Very good. So now we know that we can just create our LLM with the structured output, right? Very good. So we will create, you can say, two objects. One is LLM with schema, right? And one is simple LLM that we need to just use to generate the content, and that's it. Because this LLM with schema will only be used when I just want to generate this particular value, and that is it. There is no other use of this particular schema. Simple. And this is my state schema. State schema, perfect. State schema is very, very simple, and here I can simply say post, because there will be just one post. Simple. And there will be no topic, by the way. There can be topic, okay. There can be, but I don't think so. I should just pick the topic. I will simply say input. Okay, input, that means whatever I want to input. Post is the real post, and I can create one topic key that will be populated by LLM. Okay, perfect. No, we do not need to use literal. Perfect. So what I will do, I will say create post. Perfect. Create post Twitter, create post LinkedIn. These are like as it is. These are like, there's nothing wrong in that. Makes sense? There's nothing wrong in that. Only one thing we need to change here. I do not need to pick the topic like this. Okay, what do I mean? Here I can simply ask LLM to generate the topic as well. For example, currently we are simply finding the topic, right? Like which topic you want to use or whatever. Let's say I will change it to category. Okay, I will change it to category. Simple. And here I will say generate one topic as well. Topic of the post to generate. Simple. Now let's see what it will return. So it will automatically curate the topic which can be easily be used by LLM to generate something. This is a kind of, you can say, query curation. We are just learning very deep concepts, but this is important for you. Okay, so one thing is like just scratching the surface. Other thing is going deeper and learn the real skills. So we are learning the real skills. So as you can see, category topic, category Twitter, topic is AI. Perfect. Perfect. See, that's how we can just work with the query curation. Simple. Very good. This also saves the tokens, right? real world lessons. Okay. Okay. So now we have this particular thing: create post Insta, create post Twitter, create post LinkedIn. Very good. Now I need to create one node, which will be the decider node. So I will say def decider node. Now this node, what this node will do, let me just tell you. So this node will first of all take the, you can say, user input, or let's say state. Simple. So I need to take this input, let's say input. Now in this input I will pass it to what? LLM, right? And which LLM? LLM with schema. Very good. I wanted to see like if you are just following along. LLM schema. Simple. Then you can say dot invoke and user input. Simple. And then dot category. Why dot category? Just tell me why dot category? Because this is a Pydantic object. Pydantic object. Simple. You can say Pydantic object. It's enough. So now you have the category. Now you can update the category, right? Update it. Simple. Simple. Over. It's done. Return state. Simple. Now what will happen? Now what will happen? We have the state ready and we have got which category we need to pick, right? And these are the nodes. Let's create the nodes. So I will simply run this function. all the functions. Graph schema is not defined. Okay, let me just run that as well. Okay, so this is also done. Now we simply need to create the schema, or basically not schema, like state graph, right? So here I will simply get rid of these things first of all, and let's try to create the add node. First of all, I will say add node, decider node, create Insta, create post for Twitter, LinkedIn, whatever. These are the major nodes. Now if you just look at our requirements, this will be the conditional edge, right? Let me just make it dotted. These will be the conditional edges, not the direct edges, because you cannot run all of the edges. This will be conditional. So let's try to write the logic for the condition, right? So here what will I do? I will create a new function. I will say df condition. Okay, and then I will not boolean, basically I will simply say string. Simple. And now you have built the React agent, so now you know how to do it. So I'll simply fetch the category. Okay, and perfect. So if the category is Insta, then go to create post Insta, create post Twitter, or create post LinkedIn. Simple. You know what we are doing right now, because you know how we build the React agent. What is a condition, right? Very good, very good. So now let's try to write the edge. So first will be decider edge, so like decider node start to decider, then graph dot add edge, decider, not decider, basically now add conditional edge, because now conditional edges will be coming into the picture, right? So this is decider and decider, just the name of it. Okay, I can also say condition just to stay consistent. Okay, condition, and this will be my condition function that I have built, right? I do not need to apply mapping because I'm not applying any kind of mapping there, so that is fine. Simple. Good. So here once we have the conditional edge, then I will say graph dot add edge, and I want to create an edge from condition, not condition, basically from decider, right? See, so decider node is here. Oh, where is the decider node? Decider node is here. Now we need to make sure that this decider node will be connected to this one, and this one. Simple. Okay, so let's try to build that. So decider to, you can say create LinkedIn. Simple. And graph dot add edge, this one, and then same thing, end, because you also need to end it. Simple. Very good. So that is it finally. And now I can simply run this thing, this graph, by compiling it. Simple. So let's say route graph. I know this was like complex one, but I want you to learn complex thing. Everyone knows the basic stuff. This is the thing that you need to learn. Simple. Graph.compile, because if it would be so easy, everyone would have done that, right? Right. So let's try to run this. So condition is not defined, obviously, because we didn't run this function. Let's run this function, and let's run this. Found edge starting at unknown node, create post Twitter. Okay, don't we have that node? Create post Twitter. Which node? Okay, so we have create, oh, we do not have create post Twitter, we have create Twitter. This AI recommendation sometimes is like, oh man. Simple. Now it is saying add condition. Now what do you want? So the condition is, where's the condition? Okay, add conditional edge condition. So this is the condition. Okay, this is fine. And condition. Okay, let me just read the error message. Found edge starting at unknown node condition. Obviously, who started the node at condition? We cannot start the node at condition. Add conditional edges. Oh, this is not condition, this is decider. Again, see, AI recommendation. So you should be smart enough. Wow, so this actually worked fine. Now you can see that our decider node, okay, is connected to Insta, LinkedIn, Twitter, and then all are going to end. Simple. I know this was a big one, but you finally did it. That's a very good thing. Okay, that's good. So now You can do one more optimization. If you just look at the graph, you are seeing the solid lines instead of dotted lines. Do you know why? You know the answer. That's why I written it. That's why I wrote it here, so that you can just understand it. If I say add edge, and if I am just creating this solid edge, obviously it will create the solid edge. It will not remain like a conditional edge. So you do not need to create any edge from decider, because that logic is already handled here. That logic is already routing it here. Make sense? Let me just rerun it. Now you should see the dotted lines. Wow, it has removed something. Wait, decider. Instead, let me just see what did we actually removed. Maybe we removed some extra stuff. I think everything is fine. It's just about this thing because it is writing create post, the previous error. I think now it should be good. And okay, now we can just remove it. Now it's working fine. Perfect. What? Okay, I think I didn't save anything. Okay, let me just fix it. I think they have actually made this particular change for all of the mappings. It was not there before, but we do not actually need to worry. So the same thing that we saw in the React agent thing. So we have to provide the mapping like this. Earlier, when we used to work with the previous versions, it was optional, like we can provide the mapping. So yeah, this is the thing. So I can also check the documentation, but it is not written there. So earlier when we didn't have this particular upgrade, so if we just write the exact node name, it was working fine. Like you do not need to again mention it in the mapping, but I think they have just made it mandatory, but it's fine. It's their package, whatever they want to do, it's done. We are developers, we know how to debug, and that's it. Okay, so this is done, by the way. So you have created this dotted lines, okay, and this is your graph. So now what will happen if you just want to run it, and if you want to, let's say, invoke it with the initial input, and the input you will simply say, I want to generate a post for Twitter about AI. Simple. Rest of the things will be automatically generated, obviously. So you do not need to pass any kind of topic. Why? Because AI will do it. Then you can say category, and category will be again empty. Perfect. Makes sense. And then post. Perfect. Now let's try to invoke it, and let's see. Invoke. What is it saying? During task decider, and during task with name decider. Okay. Graph. I want to generate a post for Twitter about AI. I first of all need to check the schema if it is fine. So the schema for our state is, oh, we just have three things: input, topic, and post. Okay. Input, topic, and post. We do not have any kind of category. Input, topic, and post. But why? We should have like fourth thing as well, category. I think we just forgot to add. Let me just add it quickly. Category. Yeah, obviously otherwise it will throw the error. So let me just say run all. And now let's wait for it to run. Okay, now it is running fine. Let's wait. So bro, there were so many silly mistakes in this particular code. So I have just fixed it quickly. So first of all, we used LLM schema instead of LLM with schema, and we wanted to use LLM with schema, obviously. So just a typo. Second thing, if you just notice one thing, we forgot to pick the topic from that particular response, which is a common sense, right? So we forgot that as well. So I just simply added it, and now it is absolutely good, absolutely amazing. I haven't run this code, but I wanted to show you before running the code because I was seeing that error. And one more thing, I have also returned the post instead of returning the LinkedIn and blah blah blah, because as you know, in the parallelization we had this Insta, LinkedIn, Twitter, but in the router we have only the post, the same post, you can say, the key, right? So let me just run it in front of you so that you can also see. Yeah, let's wait for it to run and complete. So now let's wait and see if our error is gone. And meanwhile, we can just talk about the other frameworks as well, other styles, or you can say other kinds of frameworks. So this is this one. So now we will be just looking at this evaluator and optimizer. This is very important, but before that, let's talk about orchestrator or worker, because this is very fun and this is actually very amazing. Orchestrator worker. and this will just test your multi-threading, Python multi-threading skills. Don't worry, we will just talk about it. And by the way, this ran fine. Very good, very good, very good. So yeah, there was some silly mistakes in this particular code. So if you're just watching this particular segment, so just make sure you are using the my updated notebook, or you can say Python Jupyter notebook, which is updated here. So there are some silly mistakes, okay, that we just simply updated, and now it is running absolutely fine. Simple. Okay, very, very, very good. So now let's talk about this amazing architecture. It's called Orchestrator-Worker, and let me just tell you, this is a kind of advanced architecture, but nowadays, not nowadays, since the beginning, if you want to work with any kind of agentic, you can say, framework, then this is the one that every organization, every single organization uses. Why? Because let me just first of all explain the architecture, then you will automatically get the answer why. So let's say you are a user, okay, let's say you are this user. Simple. Okay, now this user can submit multiple tasks in the single prompt. I want to get this, I want to do this, can you please do this, can you please do this, enter. Obviously, right, you can submit multiple tasks in single prompt to the LLM. Simple. Very good. Now obviously LLM can perform these tasks in one go using the prompt, because LLMs are like advanced enough nowadays. But what if in your query, in your question, you want to perform specific tasks that LLM cannot do alone? Maybe LLM might need to make some API calls, some tool calling, or even forget about tool calling and API calls. We know that our LLM can handle tasks in parallel, but if we want to generate the accurate answers, the good answers, we need to just submit the tasks one by one. Make sense? Yes. Here, when I said one by one, that doesn't mean that I have to just submit one task, then wait for the answer, then second, then third. No. I meant to say that we need to submit the independent tasks in chunks. Make sense? For example, I'm saying, what is 10 plus 10 and what is the temperature in Dubai right now? So obviously these are two different tasks, right? I need to submit these two questions separately. In parallel? Yes. In series? Yes. That is a different thing. We can just submit those questions maybe in a series or parallel. That's not a problem. But the concern is I want to just make different requests, right? So okay, here comes this architecture, and this is a kind of architecture that we use in the real world. The above architectures that we have learned are just the micro components of the bigger architectures. We can use routing in our big architecture. We can use parallelization in our big architecture. That is just like small components. But orchestrator worker is a kind of complete architecture, and obviously an advanced one. Earlier I was thinking like, should I just teach this as well? Because this is a kind of very advanced topic. But I know it will require some extra efforts, but it will be worth it. And just hit the subscribe button right now, okay? Just hit the subscribe button if you find this topic helpful. Make sense? Okay. So now let's talk about it. So what will happen? I will submit my query to the LLM. Let's say this is the LLM. That's the same thing that we are doing so far. Simple. Okay. So this is done. This is not a big deal. We know that we can just do this. Simple. But now I do not want to directly submit my query, which has like so many questions within, right? You can say so many questions in a query, right? So what I will do now, the real work will be started. Okay, what kind of real work? Let me just show you. So first of all, I will send this query to the LLM, and do you know what? This node, this LLM node will be called as orchestrator. And do you know what this node will do? This node will not execute anything. Okay. This node will create the list of tasks. This node will create the list of tasks. Okay. Simple. Okay, this will create the list of tasks. That's it, because this is an orchestrator. This cannot perform anything. This will simply orchestrate. This is responsible for the orchestration. Simple. So this will take your query and it will generate the list out of it. Wow. How? Obviously, we'll just see how. So this will create the list of tasks. Make sense? Then comes the worker node. Okay. Then comes the worker node. So let's say this one. So this worker node is very special. This worker node will perform obviously all the tasks. Common sense, because we need to perform the tasks. So like we need to execute the tasks. But now do you know what? This worker node, this one, will not perform tasks in one go, or let's say perform task one by one by one. No. This worker node is special. This has multiple threads. Okay. This has multiple threads. So let's say thread 1, thread 2, thread 3, and these threads are dynamic. These are purely based upon the number of tasks that we have in the list. Let's say in our list we have 3 tasks, so it will create 3 threads. If it has, let's say, 10 tasks, it will create 10 threads. If it has, let's say, 20 tasks, it will create 20 threads, and it will perform the execution automatically, parallelly, to save the task, like to save the time. So this node is called my worker node. This entire node. Simple. This node is called worker node, which is having threads, right? Okay. Now you will say, Ansh, Lamba. Yeah. This node can perform these tasks, right? Yeah. So how to perform this task? Like what will be the execution thing that we need to execute? Because we need to execute something, right? Exactly. So when this will create multiple threads, it will create threads on top of a specific function. So this will be having a kind of function. Simple. Let me just write. Let's say function. So this will run the threads for function in parallel. Wow. Make sense? And then once everything is completed, okay, once everything is completed, then we can have a kind of collector task as well, or you can say collector node as well. So this will simply collect all of the results of task and it can just generate the output to you. Okay, it's like optional thing, but it's good to have thing. So let's say this is a collector. Okay, so this is called collector. That means it will collect everything. Simple. So I can say this will collect the results of task. Perfect. Simple. And then finally you will get the response back by this collector. Simple. This is the entire architecture, and this is a complex one. Okay, you have to be very careful while building this. So this is the architecture that we build in real life. I hope it makes sense. Okay, so this is the architecture now we are just trying to build. Make sense? Let me just open my VS Code. Let's try to do this. Yep, perfect. So now, first thing first, let me just create a new notebook. And let me just say Orchestrator-Worker.ipynb. And yes, you might be watching this segment of the video multiple times because this is actually important and this is a little bit critical. Okay, and obviously complex one as well. So first of all, what you need to do, just import the boilerplate code. Simple. So let me just import the boilerplate code from here. simple code and select kernel. This is the kernel. Run this. Perfect. Let's create the LLM object. Let me just get the code from here. So okay, perfect. My LLM object is also created. Now you need to create a special node which will create the list of tasks, right? So you have already worked with a scenario where your LLM just generates a kind of schema. If you remember in the routing part, we learned that we can create a special LLM object which will generate the specific, you can say, output, right? So here, do you know what we will be just doing here? So here I will be creating a kind of Pydantic schema which will generate the list of tasks. Simple, because I want to use that thing, like what are the list. Make sense? Okay, so what I will do, I will simply say Pydantic LLM schema. Simple. So here I need to generate the schema for the, you can say, LLM, because see, when we will be just creating our main schema for the graph, obviously we need to have tasks. That is the common sense. Who will generate that task key? This Pydantic LLM. Makes sense? Because we need one LLM which will only generate the output in the form of specific schema, because we need a list, right? Very good. So let's create the object. So I'll say class LLM output is, or let's say LLM schema base model, and here it will be, let's say, tasks, and this will be list. And let me just import from Pydantic import base model, from typing import list, and I also want to import field because I want to provide some description, because LLM can better understand the things than field description. A list of tasks performed by the, wow, very good description. So now it is created. Now I can simply create LLM with schema equals LLM dot with structured output, and this is the LLM schema. Perfect. Now let's try to test it. I will simply say LLM schema or LLM with schema dot invoke, and I say what is, not what is, let's say, yeah, what is the capital of France and what is the population of France? That's a two different question, right? Let's see what do we get. We should see a list with two tasks, right? Let's see. Yes, what do we get? No, it has just created the one, so I can just be more specific, or we do not need to be more specific here because this is just a data type. We will be more specific when we will be calling this LLM with a kind of, you can say, template, right? Because we do not need to call it this thing. We just need to test it here that it is returning a task list, and that's it. The task items within the list, we will be just manipulating it during the invocation in our graph, right? So that is fine. We do not need to be very specific here because this is just a description for the list, that it is returning the list. Simple. Okay, so this is fine. So our Pydantic LLM schema is created. Simple. And our LLM object is also created. Now let's define the schema for our code. So I will say graph schema. Simple. And here I want to create, let's say, graph schema and type det. Perfect. So here what do I need? I need, first of all, tasks. First of all, tasks, obviously. So tasks will be of list string. Then what do I need? I need, let's say, because that's the only thing that we need, and obviously query by the user. Okay, query is string. So these two are the mandatory tasks that we have. Then We will also create one more, you can say, key, that is called results, and this will be also a list. Why list? Because we will be having multiple tasks, right? So let's create a list of it. Simple. And just as you can say a kind of optional key, we can also say summary. Let's say we want to provide the summary as well to the user, that hey, these are all of the answers that we have provided as per your questions, and it will look good and it will be like more professional. So this is the graph schema, right? Class graph schema, and this is the schema. So I have created this thing, type it is not defined. Let me just run this. Perfect. So my graph schema is ready. Very good. Now I need to create the worker node. Oh, sorry, orchestrator node. If I just want to see my chart, orchestrator node will create the list of tasks, right? Let's try to create this. So I will say creating, let's say, worker node, not worker, orchestrator. Simple. Okay. So now what I will do, I will create a function df, and you can say orchestrator node. It will take state, obviously, of graph schema, and we will generate the graph schema. Okay. Yeah. So first of all, I will get the input, right? First of all, the input that I want to perform. So I will say query or user query equals to state of query. Perfect. Fetching the user query. Simple. That is the first thing. Fetching the user query. Perfect. Now what I need to do, I will generate a prompt, because I want to be very specific, because I want my LLM to generate the accurate answer. And obviously, whenever you want to generate accurate answers, we should always use prompt, because prompts can guide LLM better. So here I will create the prompt. Create the prompt for LLM. So I will say prompt equals chat prompt template dot from messages, and we do not have chat prompt template. Let me just call it from. Perfect. And dot from messages, let me just create the list. Perfect. So here, let's see what it has written. You are an orchestrator that breaks down a user query into tasks for the worker. Very good, very good. That is a very good system message. And let me just modify the user message. So user query is this. Perfect. Please break down this task into a list of tasks for the worker to perform. No, I will be very specific. I will say, please generate one prompt per task for the worker to complete. Very good. Let's try to use this prompt. Okay, and let's see how does it behave. So okay, this is the thing, user query. Okay, and user query is here. So this is my prompt. Simple. Now when I will be calling the LLM, I will simply pass this prompt. Simple. I can simply say now I have two options. I can also invoke my prompt right now, so because I obviously need to fulfill this thing, which is user query. Okay, and then I can simply call the LLM, or I can create a quick, you can say, chain. Okay, quick chain. So let's create a quick chain, because now we know the fundamentals of LangChain. Quick chain, or let's say create the chain. So chain will be first of all prompt, and then LLM with schema. Why did I create chain? Because I don't want to use dot invoke two times. This chain will just do the work. Okay, so this is my chain. Now I can simply invoke the chain, and that's it. So I will simply say chain dot run. No, I don't like dot run method. I like invoke. Okay, query equals to user query. Perfect. So now this response should have the task list. Yes, the task list. Update the task list. Perfect. And we have got the response, and it has performed response dot tasks. Response dot tasks. Yes, because this will be a kind of dictionary. I think it should be response of tasks. Let me first of all check, because obviously we need to test it because we haven't tested it. So let's try to test it first of all, because I do not know if it will work or not. Like obviously I know it will work, but this prompt needs to be tested. Okay, so now here I need to pass a user query. Now I will simply say user query trip for Paris. So let me just provide any random thing. What is the capital of France and what is the population of Paris? Let's say, yeah. So we need to make sure that this response will generate the list, right? Let's see what do we get when we run this. Let's see. This is a testing phase. Perfect. Very good. This time you can see the tasks list is actually a kind of list of two items, different items, right? Wow. And this is the first one. Okay. And this is the second one. Very good. Very good. And if I just say response.task, because this is a Pydantic object, obviously, because LLM with schema is a LLM which is bind with structured output. Perfect. That's exactly I need. Very good. This is tested and this is working absolutely fine. Perfect. So this is good. My orchestrator node is done. Now let's create the worker node. Okay. And worker node is very, very important. Obviously orchestrator node is also important. Worker node. Now just tell me one thing. If I just go back to my architecture, I need first of all two things. First of all, the worker node, which will generate the parallel threads and the function as well, obviously, because I need to generate the threads for the function, right? So first of all, let's create this quick function, which is nothing but just the LLM call, and that's it. Okay. So I will go here and I will create the, you can say, this will be, let's say, execute function that you want to execute. Simple. So I will say def execute. Okay. And I will take state, not state, basically I can take query and then string. Simple. And this will, yeah, that is fine. So now what it will do, it will simply execute the task and that's it. It will simply send the call, or basically make the call to the API, LLM API, and that's it. That's it. And that's exactly we need to do, right? So I'll simply say LLM, or let's say response equals LLM.invoke, simple LLM, not LLM with schema, because this is like real execution, not the generating the task. So I will simply say, please, what, not please, simply send the query. What is please? LLM will generate the thing. Okay. So LLM.invoke and query equals to query. No, we do not need to say query because we can directly say dot invoke. Simple. Because see, this list will be having our tasks, right? Or we can just, let's say, be a little bit polite. We can say, please execute this task. Simple. Simple. Okay. We can say this thing. Please execute this task. And we can just return the response. Perfect. This is my simple function, execute function. Now we'll be creating the main executor node, or basically you can say worker node, which is generating the parallel threads. And for that, you need to have a very good understanding of thread pool executor that we use in Python. Again, Python fundamentals. Make your Python skills strong if you want to grow in today's era. Everyone wants to learn LangChain, LangGraph, blah, blah, blah. Learn Python first. Learn Python first. It's all about Python. Okay. At the end of the day, it's all about Python. So now I'll be just using thread pool executor. If you do not know about multi-threading and thread pool executor, you can just go and just learn about it. It's a very good feature in Python, or not in Python. It's available in every programming language. Like how we can just generate parallel threads and we can execute our code in parallel. It is different from asynchronous behavior. Do not get confused. This is totally different thing. We are data engineers. We know it. So it's not about data engineers, bro. Like if you are a programmer, you should know about this thing, which is called parallel threads. Okay. So for that particular thing, I would need to, you can say, import one library, which is called thread pool executor from concurrent.futures. Simple. So let me just do that. From concurrent.futures, import thread pool executor. Simple. So now this thread pool executor will do the real work. So I will say def worker node, and I will take the state of graph schema. Perfect. And here's the thing. First of all, I will fetch the tasks that I want to perform. Perfect. And I will create an empty list of results. Very good. Then this is the thread pool executor. I will open my context manager. I will say with thread pool executor, okay, as executor. So this is fine. This is fine. Like this part is fine. But you know what? When we define this thing, we do not know like how many executors we need, or basically how many workers we need, right? And what did I say? I will create the dynamic workers, right? Let's say there are 3 tasks, so 3 workers, 5 tasks, 5 workers, 7 tasks, 7 workers, and so many other things. So what we can do, instead of using the default workers, I will simply say workers, or you can say max workers equals length of task. Okay, length of task. So now if in my tasks list, if there are 2 tasks, then 2 workers will be working in parallel. If 3 tasks, 3 workers will be running in parallel. 5 tasks, 5 workers will be running in parallel. Simple. That's how it works. Now I will use the map function. Like there are multiple ways to use thread pool executor. My way is I will simply say results, okay, or let's say results futures, because that is the kind of naming convention we use, results futures, equals to, I will use executor or let's say map function. So map function, what this map function will do, let me just tell you. So let's say you have a function, okay, this is your function. You can map this function to the entire list. So that, let's say 1, 2, 3. So this map function will be applied to this, and to this. Again, Python fundamentals. Okay, so you need to know that how we can just apply the map. Okay, so I will simply say executor.map. Okay, and what I need to map, like which function? The function is execute that we just created here. See here. And to which list I want to apply this? Tasks, obviously. Simple. So now do you know what will happen? This tasks list will act as the input for my execute function. Oh, so whatever I have written in the tasks, in the, you can say, in this particular thing. So let's say if my task is having 1 item, 2nd item, 3rd item, right? So that item will become the input for my function. So just be very careful if you just want to use this feature in future. Okay, maybe in any other workflow, just make sure that the item should match the data type of this function. If let's say in my list I am having dictionaries, I can have dictionaries, right? Dictionaries of a list of dictionaries. Then this data type cannot be string. This will also be like dictionary, and then you can fetch the values from that dictionary. Again, high level things, so do not worry about that. See, you will learn gradually. Do not feel like you do not know the things. It's all about time, it's all about practice, it's all about playing and experimenting. Okay, so it's fine if you do not know about the things. You are landing on the perfect channel. Just subscribe to this channel, you will know everything. Okay, so results futures are here. So what will happen now? Now all of the threads will be running in parallel. Yes, and now I can just save the results of every task smartly. Do you know how? Within the context manager, I will simply say for result in results future. Okay, and then I can append my this empty results. Okay, because we have to do it in the context manager. Otherwise, once this context manager is you can say completed or executed completely, then it will not save the results. It will simply release it. So we have to store it immediately within the context manager. This is the code, and then I can simply update it, return state. Simple. This is the code that we need to build. Simple. Wow. Okay, this is the 90% of the work. Now 10% of the work is like collector node, which is the optional thing that you want to, let's say, collect all of the things, and you want to say like what you have done and blah 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 blah. Right, let's do it because that is also a good feature to know. So let's say your results is also populated with the AI messages, right? Obviously. So what I will do, I will create one node and I will say collector node. So this collector node will do nothing. It will simply say collector node, and this will take this, and this will say, I think it suggested a good thing. Results, okay, results we can just fetch. Prompt, you are a collector that summarizes. Yes, exactly. So this prompt is a good one. You are a collector that summarizes the results from the worker. Very good. And here are the results. We can just pass the results list and please summarize these results in a concise manner. Perfect. And then we simply need to invoke the LLM, and that's it. So our summary is also created. See, so now our all the keys of the schema are generated. Simple. State. Perfect. That's it. That's it. That's it. Now, finally, what? Simple. Now that you can say favorite part, crafting the graph. Now, I will simply say creating graph and executing. Simple. So here we can say graph. Let's say from LangGraph.graph import state graph start end. Very good. And bro, if you understood this concept, then obviously tap your back, because this is not an easy one to understand. And yes, I put my best efforts to explain the things. You put double extra efforts to understand it. So it's a good win for you and you should celebrate it. Okay, simple. Let me be honest with you. This is not a very easy thing to understand. Okay, very good, very good, very good. So now let's build the graph. So graph equals to state graph and graph schema. Perfect. Graph dot add edge, not add edge, add node. So first of all, I will create the node for orchestrator. Bro, order pizza. Do you know what? I am hungry. Orchestrator node, and the function is orchestrator node. Perfect. Then I want to create worker node. Yes. Then I want to create collector node. Yes. Perfect. Now let's create the edges. So it will start from orchestrator, then it will go to worker, and then collector, and then end. Simple. And then let's say compile complex graph equals graph.compile, and let's see that particular thing, the visualized graph, just to make sure like our graph is fine. So this is the code for it. So here we can say complex graph. Perfect. Orchestrator node is not defined. Very good, because we didn't define it, like we didn't run this. Let me just run, let me just click on run all. Simple. Perfect. Perfect graph. Perfect. Now the beauty of this graph is it looks very simple, but we know that what's going on here and what's going on here, right? So well done. And now let's try to execute our graph. Simple. So I'll simply say complex graph dot invoke, and then I can say first of all query. I will say query what is the capital of France, what is the population of Paris. Let's see, and let's add one more thing, and what is the capital of Germany and what is the population of Berlin. Wow. Let's perform all of these things. So we have query ready. Now what do we have next? We have, I think, tasks, and we do not need to pass anything, so it will be like empty list. Results will be empty list. Summary will be empty thing. Simple. Now let's try to invoke it. Now let's see what do we get. So we should see first of all tasks as well. We should see results as well, and we should see obviously summary as well. So we should see everything. And let's wait. There are total 4 tasks, by the way. Yeah, ideally there are 4 tasks. Let's see how many tasks LLM has generated for us. Okay, let's see. So here I've got the error. Congratulations. Input to chat prompt template is missing variables. Really? Let me see what is missing. So let's go to our collector node. Okay, So in the collector node, we have passed the results. Okay. And oh no, we have just passed the results here. Okay, then what is missing? Chat from template or from messages, here the results. Okay, so everything is fine. I think I know the issue. Maybe it has not generated anything in the results, maybe. So what I will do, I will generate the stream, because only then I can see like what is happening. Okay, so let me just generate the streams. So where is the stream? Let me just get the stream code, because I want to see what is the output of results, because only then I can just debug anything. I cannot just go inside and see. So let's try to run the stream just to better understand what's going on. Okay, and here I will change this input with the previous one, with this one, and now let's see what's going on. Perfect. Chunk in complex graph. Let's try to see this. Let's see what exactly our each node is generating. That's why like streaming is very helpful for the debugging as well. So orchestrator node has created 4 tasks. Wow man, this is amazing. So very good. And yeah, very good. So now next worker node will generate the thing. Let's see what it generates. Oh, okay. So worker node has completed the work, which is tasks is generated. Okay, query is generated. Okay, like query is obviously there. Okay, results is there. Okay, results is generated. Oh, that's good. Paris. And then we have a long metadata that we can just remove, just an optimization thing. That's not a big deal. And then it has generated, let's say, do you mean Paris, France, this. Okay, so we have, the main thing is we have results as well. Like if I just check my state, so I have results. So it is saying input to chat prompt template is missing variables, refusal tokens usage, and refusal during task collector node. So let me just see the scrollable element. So what do you want, bro? Everything is fine. Why are you just throwing the error? So for I chunk, okay, results, summary. Okay. So here if I go to my collector node, so here we have the results. Okay, that is fine. We have the results. Let me just check. So bro, I fixed the error. Do you know how? It was a very quick one, and I don't think so like it should throw the error for this one. I also didn't expect this, but then I debugged it and it worked fine. So what was the issue? So when we just saw the output, you saw that we were generating so many metadata as well, right? Along with the each call. So what I did, I simply returned only the content from the execute function. See, earlier it was just response, and then I have just corrected it with the response.content, and now it is working fine. Simple. So that means in the list we do not need to pass the unnecessary columns or unnecessary tokens, right? So now let's examine the output. So now you can see that, and we can also see this thing and this thing as well. So now we have got the final thing. So we have tasks created, 4 tasks, right? Perfect. We have the query that we passed obviously, and here's the result. What is the capital of France? Paris. And population, this thing. Then Berlin, and Berlin ki population, this thing. Simple. And then summary. Wow. Then summary. So you have everything everything that worked in parallel, first of all. Then you submitted all of the tasks independently, and this way you can implement the worker orchestrator, you can say, architecture with ease without any kind of issue. Okay, and just to be more professional, if you do not want to write this AI message, you can simply say .content, and you know, or you already know this thing, right? So let's say you want to say summary.content. Simple, not a big deal. So this architecture was a big one, and now you have mastered this one. Very well done, and proud of you. So now let's talk about our other architecture, and it's called Evaluator Optimizer, and it is also called as Generate and Critique. It has like so many names, but let's use the name which is written in LangGraph. But I'm simply telling you, if you just see this name, let's say critique or I think there was a very popular name. It was called as, let me just check because I wrote it somewhere. Generator-Evaluator. Oh yeah, Generator-Evaluator. So this is called Evaluator Optimizer. You can also call it as Generator-Evaluator. You can also call it as Generator and Critique. Okay, there are so many names, but the concept is absolutely same. Okay, because do you know what? Let me just explain like what will happen. So let me just take you to my whiteboard. So I will simply say Generator-Evaluator. That's a good name. Generator-Evaluator, because I want to use those terms which you can understand better. Generator-Evaluator, simple. So now what will happen? You will go to this, let's say, node, okay, with some query. Simple. You asked something. Okay. Now what will happen? Now obviously this LLM node will generate something. Yes. But here, let's say this is a generate node. Noida. Generate node. Okay. So let's say this is generate node. So this will only generate the tasks. But there should be someone who can evaluate that the generated answer is correct, generated answer is good, generated answer is like ready to go. So there should be someone, right? So yes, we can create one more node and we can call it as, let's say, evaluator. Okay, generator and evaluator. So this will do what? This will evaluate the answer generated by this node. Okay, yeah, this will evaluate the answer. If the answer is good, then it will simply say, okay, I am satisfied with this thing and it's good to go. Simple. Okay, but if the answer is not good enough, let's say it's not good enough, so it will simply send it back to this generate node. Hey, just correct it because it is not good. Simple. This is the entire architecture for this generator evaluator. Simple. Now you can just ask this question if you are smart. Okay, and I know you are very smart. This can end up in the infinite loop. Let's say our evaluator node is like very strict. It is like every time saying, hey, this is not good, hey, this is not good, hey, this is not good, just like your favorite class teacher whenever you submit the homework. So in that scenario, it will never generate the final answer. Kind of, yes. So in that scenario, just for the safer side, or you can say just to add a guardrail so that we do not enter into the infinite loop, we can create the maximum iterations. Like we can set the maximum iterations number. So maximum iterations number will be, let's say 3 or let's say 10. So yes, evaluator can reject the answer, but not more than 10 times, right? Not more than 3 times, not more than 4 times, like this. Make sense? So that's how you can say generator evaluator or generator critique, because this can act as a critique. Okay, this can act as a critique. Okay, or you can say it is a kind of, if I like this word generator evaluator because this is a good one, like this is a better way to understand this thing. Okay, so now what exactly we need to do? We will just use the Pydantic here as well. Why? Because let me just tell you. So let's say my query is, let's generate a joke. Okay, so generate node will generate a joke, obviously. Now evaluator will consider the joke as funny or not, or funny or not. Make sense? Okay. Now you will say, how evaluator node knows that joke is funny or not? Obviously, we do not have AGI for now. So now we can just add some hints. Let's say if there is a punchline, if there is an exclamation mark, because whenever you are just writing a joke, you have to make some pauses within the, you can say, between the joke statement or whatever. Okay, if you have ever made any joke. So you have to just take some pauses, and while you will be just writing the joke, you have to demonstrate that you are taking the pause. So let's say I will say add some exclamation mark. I will add some generic rules so that evaluator can better understand the joke. Simple. And then it will provide the feedback on the basis of it. Or you can say, it will simply say, okay, this joke is this joke, this joke is good. Simple. So it can simply say funny or not funny. And then it can simply provide the feedback. And this feedback will go back to the generate node. Simple. And then it can improve the joke. Simple. And the maximum iterations for this will be, let's say 3 or 5, let's say 5. Simple. So now let's try to create this thing in our VS Code editor. So let's try to do this. So what we need to do, first of all, let's try to copy this, and let me just say 10. Generator-Evaluator. Okay. Generator-Evaluator. Let's see. So first of all, this is same. Let me just select the kernel and LLM. Now let's change the Pydantic schema. So here we do not need to create any tasks and all. So here I first of all need to create joke flag, or you can say funny flag. Okay, funny flag. This will be not boolean. I can simply say boolean, but I want to keep it as, let's say, literal. Literal is a better way to work with it. And literal of string. Simple. Let me just pick the literal from here. Simple. So literal of string. So this will do, what's wrong with you, bro? Literal of, oh, makes sense. Literal of funny and not funny. Simple. Very good. Funny and not funny. And you can provide some description whether the joke is funny or not. Simple. Now what I will do, I will simply attach this with our LLM. Simple. Now we do not need to test it here because we have not provided any kind of instructions like how to judge that it is a funny or not. It is just the way to tell LLM that you just need to generate the output with this particular key in it, and obviously either this value or that value. But obviously if you will just try to test it, hey, LLM with schema dot invoke, and we will write a joke and you will see, let's see what it will return. It doesn't know like how to say funny or not funny. For that particular thing, we have to provide the prompt, right? So that prompt will be provided during the invocation. Okay. Or if you just want to test it, you have to provide the prompt within the query. So you will simply say, please evaluate whether this joke is funny or not. Here is my joke, right? Because what is this thing? Oh, I think I accidentally clicked on Control S. Okay, so this is fine. Okay, Pydantic LLM schema is fine. Now let's change our graph schema. So here the graph schema will be having some things. First of all, joke. So first of all, topic, on which topic you want to create the joke. Then joke. Then what should we just create? Funny flag, obviously. Then we need to have, let's say, feedback, obviously, because it will generate the feedback as well. And here it will generate the feedback. Feedback string, feedback on the joke. Very good. And funny flag. Okay. Then max iterations. Max iterations integer. So this is my schema. Simple. So now let's create, and let me just delete all of these cells because we will be just writing our own nodes. Perfect. So our schema is done. Now let's try to create the nodes. Perfect. So here what will I do? I will create the, first of all, generate node. Simple. And it will take the state, and state will be graph state, which will return graph schema. Perfect. So here I will say generate a joke. Okay, you are a joke generator and not evaluator, obviously. Here I can actually simply say response, or let's say topic equals to state of topic, and I can say LLM or response equals LLM dot invoke create a joke about the following topic, and I can say topic. Now this is a little bit critical moment here. For the first time, if you're just invoking this function for the first time, it will work fine. But what if you need to evaluate and then generate it? Then obviously this prompt will not work, right? So here you have to use the if statement. So here you will say if feedback or not feedback, oh yeah, feedback. So if feedback or flag, anything. So let's say feedback, if feedback, state of feedback, okay, is there, then for now we can say pass, okay. If not, then simply run this thing. Why? Because this will be my first iteration, this will be my further iterations, right? Because we are generating the joke on the basis of a feedback, right? Very good thing. So this is my first invocation. Okay, this logic is done, this is accurate. Now let's write the logic for the feedback, because now we need to regenerate or basically modify our joke. So I will simply say response equals llm.invoke, please create, or you can say please modify the following joke. Okay, George, please modify the following joke. And what is a joke? Let me just bring the joke. Please modify the following joke, and the joke is in the state of joke based on the following feedback, and feedback is state of feedback. Perfect, perfect, very good. I hope it was easy. Just a basic programming knowledge, and that's it. Basic knowledge about conditionals, and that's it. Nothing fancy, just a kind of if else statement, bro. That's it. Very good. Now after creating this thing, we obviously need to update the joke, which is joke, or let's say state of joke equals to response, and I would say response.content, because I don't want to save those metadata. Okay, so state of joke equals to this and return state. So this is done. Very well done. Now let's create the node for our evaluator. This is very important. So I have written the detailed you can say prompt for it, and I will just share it with you, don't worry. def and evaluate node. So now we need to evaluate the node joke. So now you can be the strict teacher of the classroom. Now you need to evaluate the homework. So you generated this joke, let me just read it and let me just see like what you have generated. So you can just behave like this, right? Okay, so now what you can do, you can simply write a prompt. Okay, so I have written this prompt just for you, and let me just show you. So it will be like, let's say, so I have to convert it because I just wrote it few hours back. So this is the, first of all let me just prepare some of the things. So first of all I need to fetch the joke. So let's say this is a joke, and who told you to complete everything? So joke is state of joke. Now you need to evaluate. So I will simply write the prompt. Okay, so chat prompt template dot from messages and system, you are a comedy critic. Wow, your job is to evaluate the following joke. What is joke? Joke, and provide feedback on how to make it funny. Okay, now I will write that prompt that I have written. So this is this particular thing, because I added some you can say patterns. Evaluate the following joke, response with funny or not. Perfect, because you have to be very specific, and you have to write this thing. This is very important. Response with funny, not funny. Even we have attached our LLM with structured schema, still you should guide in the prompt that you need to respond with funny or not funny. It is a good practice. Simple. And provide feedback if it's not funny. Simple. Okay, so now let's try to invoke it, and then I can say my chain. Okay, and chain will be prompt and then LLM schema. and then I can say response equals to chain dot invoke, and while invoking it I need to pass some things such as joke, and joke is joke, and anything else? No. Very good. And then I can say state of funny flag will be response.funnyFlag, and state of feedback will be response.feedback. Perfect. Return state. And one more thing, just tell me that what is left. We also need to increment the iteration, right? So that we do not make more than 5 iterations, right? So first of all I will get the iterations. So let's say iteration equals to state of max iterations. Perfect. So let's say this is 0 for now, for the first time. So here I will simply say state of max iterations equals to iteration plus 1. So every time it will be just keep on appending, or not appending, like adding 1 1 1 1 1 to the iteration, so that we do not come to this function more than 5 times. Simple. And here we are done. Our node is done. Now we need to create the nodes and edges. Simple. And if I just go back here, so just tell me one thing. Here we need to create one conditional edge, and just tell me what is that conditional edge. The conditional edge is these two. Why? Because you do not need to go to this evaluate node every time. You only need to go to this evaluate node if the value of maximum iteration is less than equals to 5, right? So we will create that evaluate node. Simple. So this is fixed because obviously this will go back to the generate node, but this is conditional node or conditional edge. So let me just create that as well. Conditional edge function. So I will simply say df check iteration. Okay, check iteration, and let's say this will be returning string. So I will first of all fetch the iteration equals to state of maximum iterations. If the iteration is less than equals to 5, then obviously return the node name, and node name, let's say our generate, not generate, basically evaluate node. Simple. Otherwise return end. Simple. Return end, because we simply need to generate the final answer. Simple. Okay, makes sense. Okay, if I just look back here, evaluate node, yeah. So let's create one more arrow here, because if the maximum iterations have surpassed the answer, then we can just generate the final answer. Instead of like from here, we can just generate from here. So it's fine. Simple. So let's go and create this thing as well. Graph schema is not defined because we haven't run anything. So let's say run all, and perfect. So now let's create the graph. Create state graph, and here let's say from LangGraph.graph import state graph start, and so I will say graph equals to state graph schema, generate node, evaluate node, add edge, then add conditional edges, then generate node, and check iteration, and then obviously the mapping the same mapping that we see error every time. So it will be like, first of all, not generate, I will say evaluate, and end is equals to end. Okay, perfect. So this is also done. So here it is done. Now we need to add edge from evaluate to generate. Okay, and then from generate to end. Graph dot add edge, generate node to end. Simple. Just 4 edges. Simple, because obviously we will always end the you can say joke with the generate node. Like, it's my choice, by the way. I can, let's say, end the process from evaluate node as well. So what will happen in that particular case? So let's say let's first of all compile this just to see like how our graph looks like right now. Because if I just, let's say, add the conditional edge, only the conditional edge, then what will happen? If you see the conditional edge, we have already the end statement here, right? So that means it will automatically end the graph if we do not have any kind of evaluate node. So we do not need to go back to the generate node after this end. So it's my choice. So I can also, let's say, comment it out, these two. So I can only create the 2 or let's say 3 edges. That's it. First of all, start, okay, and then from generate to evaluate in the form of conditional. Okay. Wait. Why did we just add conditional from generate to evaluate? Okay, makes sense, because that is a kind of conditional edge, because it cannot go every time to the evaluate node. That makes sense. So let's try to compile it. Let's say evaluator graph. You can just give any name, graph.compile, and let's try to print it. So this is my evaluator graph. Perfect. Let's see what do we have, because I think we can just change some edges, but let's see. So currently it is like this. So start generate node, and it will go to evaluate node only if the iterations are more than 5, otherwise it will not go to evaluate node, and this will simply go back to the generate node every time whenever it is coming here. So it is also kind of thing, but you can just redesign it as per you. Maybe you want to generate the final answer from evaluate node, so you can do it like that as well, but this is fine. Now let's try to invoke it. Perfect. And let's say evaluator graph dot invoke, and here I need to just provide the topic. Oh yeah, that is perfect. So we have just invoked the graph with 0 max iterations, and topic is AI. Let's not pick AI. What joke we need to make on AI? Let's say on, no bro, no jokes on programming, not at all. Let's say on cars. Okay, on cars. Let me just click on run all. Let's see what do we get. Let's see. And our joke will be updated. Okay, that's fine. Yeah, that's fine. Let's see what do we get. So bro, I just replaced my invocation function with this one because it was taking so much time, because obviously it is taking time because of iteration. So I wanted to see the data in real time, so I can see it now. It is generating the data seed generate node, and then this is the joke. Evaluate node is this joke, and it has simply provided some critique. Okay, so funny flag is funny. Oh, if funny flag is funny, why it is just generating more jokes? Okay, we will just check it further. Let's see the feedback. Clean, quick, fun, that plays and exhausted, and car exhaust. It's a mild gray honor, but works as light joke. Okay. To punch it up, tighten the setup for quicker misdirection and blah blah blah. By the way, if it is saying funny, why it is just going to that node? Let me just check our logic. So let me just go to my condition. Oh, makes sense, because see, we only need to go to the iteration like this evaluate node if the iteration is less than equals to 5, obviously, and if the funny flag is not funny. Makes sense? Only then we need to just go there, otherwise end it. So I'll simply say less than equals to 5 ampersand state flag is not equals to funny, otherwise end it. Okay, now makes sense. Now let's see the answer in the real time. Now let's wait for it. And I would also recommend you to just use this method for all the invocations so that you can just see the data in the real time. So okay, this has generated the node. Why did car go to therapy? It had too many exhaust issues. So funny. Evaluate node. So what it has evaluated? Oh, so it has said like funny flag is funny. Okay, makes sense. Okay, and now generate node has generated this thing. My car's great comedian, it's always exhausting. And funny flag is funny. Okay, that makes sense. That makes sense. So now we have got the joke and the execution is completed with the critique. With the critique. That means that now you can simply generate the joke with the help of critique. Now you will say, hey, why it has just gone to generate node? Because it will obviously go to the generate node one time because of this arrow. That makes sense, because it cannot simply like go to end because of our edges. Simple. So obviously we need at least one iteration of the joke. Okay. And then if it like surpass the value 5, then it should not go to that one. Simple. So this way you can handle the infinite loop issues by just adding this max iterations key. Simple. Very, very, very well done. So now you have understood and mastered all of the architectures available in the LangGraph. All of the workflows, React agent, everything. See, everything is covered. Now you are ready to build your LangGraph applications. But there's one more concept that I want to show you. It's called memory. And it's very important. So now let me just ask you a simple question. Whatever I am asking to this LLM, let's say I am this user, right? If I invoke this graph, okay, let's take the example of very simple use case. So let's talk about the memory in LangGraph. Okay. So now let's say I am this user. Simple. I am this user. And I am talking to this node. Okay. I am just talking to this node and this is just giving me the answers. Simple. Now when I just invoke this graph, it gives me the answer. But when I again invoke this graph, will it remember me? Obviously not. So now you will say, obviously this is the expected behavior, but I want this LLM to remember me. I want whenever I'm asking any question, LLM should answer as per my previous chat, as per my previous preferences. Then only I will get the desired answer every time whenever I'm just asking any question. That's the behavior you see in ChatGPT or any chatbot, right? Makes sense. So now let's see how we can just implement this solution in our code. Let's see. So now let's try to create our memory. And first of all, just a good thing, you can even create your own method to store the memory, because it's all about creativity, how you want to just store the memory. I am just showing you the way that is described in the LangGraph, okay, so that you can just know one of the creative ways as well. So let's say memory, because you can literally create. Let's try to complete this code and then I will just show you what are the other ways that you can use. Okay, simple. So let me just which one did I copy? I don't need to copy this one because I just need to show you the basic graph, because we are not like covering the complex graph. So let me just clone this one, rename 11, and let's say memory. And if you will take my advice, I will always say that always build your own method to store the memory so that you do not face the problems like vendor lock-in, because storing memory is very, very important. Okay, and I have faced those vendor lock-ins problems. That's why I'm just suggesting you, but still I'm just showing you how you can just do it with the LangGraph. So first of all, let's try to run this cell and let's try to create our LLM. So first step. So here I will also show you one more way, and it is also important when you want to use the built-in method of memory from LangGraph. So here what we need to do, we need to create the schema, right? So here we will create a very simple schema. Let's say class graph schema, and here I will just create a keyword called messages, and here I will pick the annotated simple of list, and here instead of using add, I have to use add messages, which is a kind of another reducer similar to add. Add messages is like kind of old way to do it, but if you want to use threads, you have to use add messages. So I'll simply say from langgraph.graph.message import add messages. Simple. And let's import annotated as well. And what is this? langgraph.graph.message or messages or message. I think this is the one. Oh, I think one G is left. Okay, perfect. So add messages. And one more thing, you have to keep the keyword as messages. You cannot keep like message or whatever. Okay, it is not allowed. That is like a kind of problem when you use like built-in features just to store the memory as well, because it will only create the automated addition of memory or basically history to your chat when you will use this keyword messages. That's why I like my own way of doing it. Okay, but let's try to explore this one as well. Then I will just give you my suggestions. So perfect, here we just need to get the message, and perfect. And here let me just change it to messages, and we do not have any kind of name, so that is fine. I can remove this as well, this as well, this as well. Perfect. So current message, and here's my response. Okay, that looks good. And this is our graph. So yeah, now is the thing. Now you need to compile the graph with just one tweak. Here you will compile the graph with something called as checkpoint, because you want to create the checkpoint for your chat, right? Whatever your last chat was. So I will compile the graph using checkpoint. So here what I need to do, I will simply import from LangGraph dot graph. Let me just check the class in the official documentation. Where is the class? Where's the class name? The class name is this one, LangChain.checkpoint.memory. Perfect. Perfect. So here I have imported this particular object called in memory saver. So this is a kind of object that we use to create the checkpoint. So I will say checkpoint equals to in memory saver. Perfect. Now while you can say compiling your graph, you have to pass this checkpoint. You will simply say checkpointer equals to checkpoint. Simple. So now what will happen, whenever you will be just invoking this graph, it will not be invoked normally. It will be now invoked using the checkpoints. Make sense? Very good. Now we also need to make sure that each user can access their chat, and it should not have any kind of reference between the chats, obviously. For that, we will invoke our graph with a different method. Okay, what is the method? Let me just show you. So instead of writing the graph like this, so we have to run the graph with configurables, or you can say with config. Simple. So first of all, let me just import the config. So you can import the config like, let's say from, actually you do not need to import the config, you can directly run it as well. Let's see. So I will say memory graph dot invoke, and my messages will be, let's say I will say my name is Ansh. Okay, simple. And after passing this, I have to pass the configuration. So I will simply say configurable, and then the configurable will be, let's say what should we say, thread ID. Yeah, thread ID equals to thread 1, or let's say my name, let's say Ansh. This is me, this is my identifier. Okay, my thread ID means my identifier, like, okay, this is me, I am chatting with you. Simple. So just make sure you use all of these things. Simple. So now let's try to run this thing, and we need to run all because we didn't run anything. So now what this will do, this will invoke the graph first of all, and you will see the graph here, and now it will invoke the graph with this query for sure, but it will also pass this configuration along with the query. So you have got the response, and it is saying my name is Ansh, and wow, we have just got human message. Where's the AI message? That's the thing. Human message, my name is Ansh. Okay, that makes sense, but where is our messages? Let me just see if we are adding anything or not. Your current message was this, and oh, we have to change the messages because this is now messages. Okay, let me just say run all, and now let's see what do we have. So perfect. So it is saying your content was human message, and here's my response. Nice to meet you, Ansh. How can I help you today? Now, if I try to ask the question like, what is my name? Let's see what it responds. Let's see. Okay. And it is saying, your message was this, my name is Ansh, and nice to meet you, Ansh. How can I help you today? So my name is Ansh, human message. I can simply get the latest message as well, but that's fine. So now I want to just show you what actually is happening. So if I go to response, let's say response, okay, because we just need to fetch the response of content basically, or let's say response of -1 dot content. Let's see. So I'm again asking the same question, what is my name? Response of -1, let's say response dot content. Dictionary object has no, because response is a you can say a kind of list, and within the list I can access -1. Now let's see. Okay, so it is saying your message was my name is Ansh. Okay, and here is my response. It will say your message was my name is Ansh and nice to meet you. How can I help you today? Here are a few things, and let me just make it like let me just beautify this, because whenever we just work with this kind of things, we have to just use something called as pretty print, because then only you can see like what was the you can say answer, because it will like keep on adding stuff. And let me just show you first of all with the new thread ID. So let's say I am Ansh Lamba now. I am a new person, so I am just sending a new request. Let's say my name is Ansh. Okay, let's try to invoke it, and now let me just bring the pretty print code. So what we can do, we can have like messages. So I will simply say for message in response of messages, and then message dot pretty print. Simple. Now let's try to run this pretty print, because I want to just see the, you can say, message in the nice format. Okay, now it is saying human message, your name, your message was this, and now it is like, why it is writing human message here? Because this is an AI message, right? So it is saying that is not a problem. Okay, because this is the main thing that we want. Your message was this one, my name is Ansh, and here's my response, nice to meet you, Ansh. So this was like very first message. Simple. This is like very first message. Now what I need to do, I need to simply ask the second question. I will simply say what is my name, and it should remember me, okay, as per the memory. Let's try to run this thing and let's see what do we get. Okay, so it is saying my name is Ansh, your message was this is the previous message, this is the new message, what is my name. So now it is saying your message was this is the kind of history that it is just telling me. Okay, so now it is responding me this thing, your message was this, and it is generating your message was this again, because it is like keep on appending the things. And it is saying nice to meet you, Ansh, examples, blah blah blah. I just want to see the latest message. Here's my response, your name is Ansh. It is like embedded you can say hierarchically, but I know how to find it. So here is a response. It is saying your name is Ansh. So now it remembers me. Why? Because I go to LLM with my identity card, which is this one, configurable. Now it remembers me. But if I go to LLM with any other name, let's say XYZ, okay, and if I ask the same question, it will not say your name is Ansh Lamba. Let me just show you. It will simply say I don't know you, because this is a different ID card. See, what is my name? And this is the your message was this thing, and here's the response. Let me slide. I don't know your name yet. See, because now this person is new. This person is new, and when I ask the question as my ID called Ansh Lamba, it knows me. It knows me, but with a different ID, it doesn't know anything. That is the concept of memory. And now let me share my insights, like how you can just take care of memories in LangGraph, or in, you can say, in the real world. First of all, you should never dependent on this particular method called in-memory saver and all. You should always create your own method to how you can just store the memory. For example, you can just write the data in the disk. You can create a txt file, okay, You can just store the ID and then the entire chat history using simple list comprehension. This is one way. Second way, you can also explore Postgres. You can create your Postgres database and you can just write the data into the Postgres database. This is just for the prototyping, okay? This in-memory saver, but it is good to understand the concept first of all, right? So this is my guidance and you can just take it, because when you will be just creating your own method, you have like full freedom. You do not need to just use the same keyword. You do not need to just use add messages or whatever, because you will handle everything. And when you handle everything, you have to just put extra efforts. If you want to use the vendor features, then obviously you need to just cooperate with the prerequest and all, right? So it's your choice. If you just want to do a quick prototyping, you can just use this one. If you want to build your own thing, you can just use any method. Okay, this is all about the memory in LangGraph. Now let's talk about a very important concept called human in loop, because whenever we just build the agentic AI frameworks, or basically agentic AI solutions using agentic AI frameworks, we have to involve this concept called human in the loop. Not every time, but sometimes, yes. Maybe you are doing something critical and you cannot let your agentic AI framework to complete everything without your permission. So if that is the scenario, then you have to involve this concept called human in the loop. Simple. So now if I just try to explain this concept, this is very simple. Let's say this is the same scenario here. So this is a task that this user wants LLM to do. Okay. But this task can be, or let's say, let's remove the query. Now this task can be performed and cannot be performed. So let's say there's a task for doing something. Let's say anything. Let's say sending an email to director. Obviously this is a risky thing, right? You cannot just send the email directly to director without confirming, without rereading it or whatever, right? So this is a task, but do you know what? You have to create the workflow to, let's say, send the summary of the day to the director. And this is a very simple example, by the way, just to explain the stuff. So let's say you want to just send an email to your director and you want to summarize the entire day that you have done so far and blah, blah, blah. So maybe you were just writing all of the tasks in a sheet, in a CSV, and then you created a workflow where LLM is just summarizing everything. Now you want to create a workflow to send that email to director on a daily basis. But before sending, you just want to confirm like the thing that is generated by AI is fine. What you will do, instead of directly sending this thing to director, you will involve human in the loop. So you will add one guardrail here. Simple, like this. And this will be called as approval node. So in this node, it will ask you to provide the approval. So here this user, okay, this user will be approving this thing again after triggering the workflow. Obviously, maybe this workflow is being triggered manually, or maybe the person is using some scheduling frameworks, let's say Airflow or anything. So let's say this was scheduled on a daily basis. So now this person requires to approve again. Okay, this person is required to approve this particular framework again. So before sending this thing to your director, right, before sending this thing to your director, you need to first get the approval. If you approve it, then only it will send it. Otherwise it will, let's say, keep it in draft or whatever, so that you can just iterate it later on if you do not have some time, anything. Okay, but on the basis of your answer. Make sense? On the basis of your answer. Okay, simple. Perfect. So this is the scenario. So when you involve this kind of element in your architecture, it becomes human in the loop. And to demonstrate this with the help of the code example, I would definitely recommend this official documentation for this thing, because they have actually demonstrated this thing with the very good example. So just go to LangGraph, and don't worry, I will just provide you this code in my VS Code editor as well. So do not worry at all. So this is the official documentation. And if you just go to interrupts in LangGraph, and if you just scroll down, you will see the full example. So here, what they are just trying to do, let me just explain this thing here. So first of all, they have created this approval node. Okay, and this approval node will have either proceed or cancel. Okay, so this is like on the right hand side. So it will only generate two things, proceed or cancel. Simple. And the question will be, do you want to approve this action? Yes. If yes, then obviously you will also see the details, like, hey, just show me the details, like what you are just trying to do. So you will see the details. Some details, let's say this is your email, this is a list of tasks that you have done, and blah, blah, blah. And then we are using a route. And this is a called, you can say, a kind of built-in function called command, where we can simply route our workflow towards, let's say, proceed node and cancel node. Now you will say, hey, where are these two nodes? Hold on, here are these two nodes. So if we have proceed nodes, then you will simply say status equals to approved. We will simply change the status. Simple. And if it is like cancel node, we will simply say rejected. Simple. And then we are simply building the graph using add node, add edge, and whatever. Simple. Very good. So far, this is very simple. Now let's talk about the critical part. Now we have to use something called as checkpointer for this, because LangGraph needs to make sure that it can save your chat in the memory or in Postgres, whatever, so that it can just make the use of checkpoints to provide that particular context. Because what will happen whenever you will be just prompted to provide your answer that, hey, do you approve it or do you reject it? You still need to re-invoke the graph indirectly, right? Because let's say the graph executed, then it is asking you, hey, do you want to approve it or reject it? If you say approve it, then yes, you will be just you can say re-invoking the graph. So checkpointer, what checkpointer will do, checkpointer will only trigger the graph from the state it was posed. Make sense? It will not just run the entire graph from the scratch. It will just run the graph from the state it was paused. Right? That is why we have to use a checkpointer here. And again, you know how to use a checkpointer using the config, and that's it. That's it. And this is the action details, like what you are just trying to send. Maybe here they are just using the example where you are just trying to transfer some money, but we can just change it, let's say daily logs, daily activities or whatever. Simple. Okay, very good. So let's try to apply this thing in our VS Code, then you will understand it. And by the way, it's very simple, because if you understood this part, then implementation is very, very easy. It's not a rocket science. It's just like using their built-in functions, and that's it. That's it. It's not something like you are building the concept on the fly in your notebook. No, you are building the concepts here on the fly, because it was up to you how you want to build your workflow. But here you are not building any concept. You are simply using the built-in functions. That's it. Okay, so let me just create our last notebook of the lecture. It's called human in loop .ipynb. Perfect. So here, let me just create a code cell, and before that, this thing. And let me just create this thing. So here we do not need any kind of LLM, because we are not involving LLM for now. We are simply involving the email, and we are assuming that our LLM has generated some text. So I will make some changes, obviously. So I will simply go to this command, which is saying this thing. So action details, we are not transferring any money. So I will simply say, I want to send daily logs. Simple. Send daily logs. So this is the not daily logs, or let's say daily summary. Simple. And the you can say initial status is pending. Why? Let me ask you this thing. You know the answer, because the concept that we have discussed will answer this question. Why the status is pending? Because we need to involve human in the loop to change the status. If you will say approved, it will approve it. If you will say reject, it will reject it. That's why I am simply saying pending. Currently it is pending, and it's up to you what you want to do. Simple. So I will generate the send daily summary. Let's say this is generated by LLM node, and then I have created this status, which is pending. Simple. Makes sense, and it's very easy. So then it will simply say approved and rejected, whatever you want to do. Simple. Okay, now let's try to invoke it. Then you will understand it better. So let's say, let me run it and see. It is saying interrupt. Interrupt means there's a function called interrupt that we use here. Where is that function? Interrupt. You will see it somewhere. Let me just search it. Interrupt. So initial interrupt. Perfect. Where is that particular function? Okay, so here they are just using this function here, decision interrupt. Oops. So this is the function. So this is a built-in function for interrupting the workflow. Okay, by LangGraph. and here it will ask you what JSON you want to provide, question and obviously some details so that the reader can actually see something, right? And here I have got the same message. Here the workflow is interrupted and question is approve this action. It is asking me, and details is send daily summary. And here you can imagine that there are some daily summary written by LLM. So you will read it. Okay. If you are fine with it, then you need to re-invoke this graph. Let me just go to the next line, and here you will just re-invoke this graph using this line. Let's say now I want to re-invoke this graph. So I'll simply say resumed status is equals to approved resume. Yeah, so let's say, let me just invoke this thing. Perfect. So here I just simply ran this as well. Okay, so that is fine. Let me just remove this area from here. By the way, it didn't run because it simply threw us this thing in the interrupt code. So that is also a good thing, but I can just remove it and put it in the next cell because it makes more sense. Let me just run it again. See, same thing. Nothing is changed. But now I'm simply saying that I want to resume it, right? Because resume is equals to true. I want to resume it. So now what will happen? It is approved. Now it is approved. That means it has simply approved my workflow. That means I have approved my workflow, that this is fine. Make sense? So now here what it has done, it has simply used the same config, that means your config that you used while invoking it, and it resumed the graph from the same state it was saved before. Make sense? I know this is like a little bit critical, but not exactly. If you will just try to debug it and play with it, you will actually understand it. It's very easy because the concept is the main thing. This implementation is like pure built-in functions, no concept at all. Okay, so this is your config. Now if I say resume equals to true, now obviously I have just simply ran this thing. Okay, let's say I use a different config. I will say approval 123 and thread ID will be, let's say, 456. Okay, if I just run this thing, it will be saying like, do you want to approve it? And I'm not happy with it. I will simply say no, I don't want to resume. You can say resume it. I will simply say false. Then it will be rejected. Make sense? Then the status will be rejected. Okay, now you can continue with this particular workflow. What you will do, you will attach more nodes. If the status is approved, then simply send the email. If it is rejected, end the graph. Simple. Can we just build this particular thing by ourselves? Obviously, there's no rocket science in this. You know already that how to handle memory. You can easily add one key in your, you can say, your schema, and then you can just use it similarly here because they are also using the same thing. But here you are using the built-in functions, pure built-in functions. But now you understand the concept, like what exactly we need to do. We need to simply go to this node and we need to re-invoke it from here. Simple. That is the entire concept. Re-invoke it from here with all the context. If you want to use built-in functions, I have already shown to you. If you want to use your own method to build this thing, you can. No one is stopping you. And I also built my own way of re-invoking this thing. Okay, so you can also build it. It's not rocket science. So this is all about your human in the loop, because we simply need to get the approval from the human, and human will decide what we need to do. Make sense? So that is the entire concept of human in the loop. So this is your masterclass of LangGraph, and I hope that we have covered so many things, architectures, workflows, you can say state transfer, everything. So I hope it was fun, and I hope you learned a lot. And if you like the video, if you learned a lot from this video, simply hit the subscribe button and drop a lovely comment. And one more thing, you can also share this video with your friend so that your friend can also grow in your life. Okay, because when you help others, you also get helped. Okay, so happy learning, and click on the video coming on the screen right now, and I will see you there. Bye bye.